Hello and welcome to Start Dev Change. My name is Seth Juarez, and awesome on the other side, socially distant, we have
me. Hi, everyone. I'm Donna Sarkar. It is, hello. Thank you so much for joining us this morning. We know that this is a weird time and it's just getting weirder. So we are really grateful you took out time out of your day to come and hang out with us today. So Seth, what are we doing here at Start Dev Change? What's the deal?
Speaking of getting weird, I'm pretty excited. Actually, I've been programming for like 20 some years, and I'm looking over this schedule, and there's stuff that I'm excited to learn about. This is all about learning new things, and whether you're super experienced or you're just getting started, everyone's welcome. And this is super cash, so please make sure to go to, for example, Start Dev Change, the hashtag. If we can go to my screen here, there's a couple of ways for us to actually interact together. We want to make sure that you do that because we're really interested in the interaction. So the hashtag Start Dev Change on Twitter. If you want to go to Learn TV as well, on my screen you can see Microsoft.com learn/TV, or you can go to twitch.tv Microsoft Developer, where you get all of that. But again, we are super excited about the actual interaction. So make sure you interact with us. I'll bring up the Twitter feed every so often, and we can have a fun time learning what you're learning and then learning how to learn with you. A lot of learning going on. What do you think about that, Donna?
That is a lot of learning, dude. That is a lot of learning. So listen, this is going to be a very cool 2 days. So just so you know, you signed yourself up for 2 days of us. Day one, that's today, is all going to be intro to programming stuff, right? And that's going to be introduction to open source, introduction to static web apps, introduction to all sorts of things that are modern tech that people who are creating jobs are looking for talented people to do. So we're not going to be teaching anything that's irrelevant or things that you should have learned 25 years ago. These are all things that are extremely relevant in the world today with very, very viable job opportunities. There's some things on this schedule, like Seth was saying, that are really good for industry veterans like us. I've been an operating systems dev for 15 plus years. That's a long time. So I'm looking at static web apps, which is midday, and thinking, I should learn that. That sounds like a useful thing to learn. Another topic that I'm very interested in is how to contribute to open source projects. It's not something I do. I've worked at a large company for a long time, but I know that that is a really great way to build up my technical resume. So Seth, what are some topics you're interested in? Either today, day one programming, tomorrow, Power Platform.
Yeah, so I'm looking, I got the schedule right here in my hands. There are so many, like, for example, Brian Clark's going to talk about Twitch. I watch Twitch, but I'd love to maybe do a show. I love doing camera stuff. I'm terrible at it, incidentally. I mean, Donna knows this. But for example, intro to languages. Like my favorite class ever was languages, and so I'm excited to see what Shannon's going to talk about. We have intro to VS Code and Node.js. I'm not a big Node.js person, but I'd love to get involved with that. And again, here's one. And look, again, I've been doing this for a long time, but look at this. Working smarter, steps to getting unstuck.
Yep.
That's not a beginner thing. That's a life thing. So I'm pretty excited about that. And then at the end, I think we have a career panel of some amazing folks to talk about what's going on. Then we get to recap at the end. So they let us do whatever we want at the end.
Pretty much.
But again, the reality of the matter is that the most important thing is please interact with us. This is for you. We're all beginners at something, and there's no shame in that. And there are no such thing as dumb questions. Only the dumb people that don't ask them.
This is true. So we highly recommend, whether you're a beginner in tech or a beginner in this specific tech, join us, stick with us, tell everyone. We will assign homework throughout the day, so definitely chime in on Twitter and let us know what you'd like to hear more.
I think it's time.
I think it's time.
I think it's time. Are we ready for Scott Hanselman over there in the back booth? Like, thumbs
All
up.
right.
Scott Hanselman coming up, talking about the art of computers. Let's go to him right now. You're on mute.
Hey, everybody. I'm Scott Hanselman. I'm very excited to be here today, and I really appreciate you've got today and tomorrow 2 wonderful days of great learning with great friends available to you. I am going to give a little keynote here, which is very exciting. This is a new talk that I've been working on that I call the art of computers. And the idea with this talk is to give you an understanding about how, or later in career, we'll say, engineers and developers think about computers. You're going to have lots of opportunities to learn from engineers of all levels during this event. I want to encourage you to go and complete some of the interactive learning exercises, check out the videos, practice, get badges and certs and stuff, discover your own path with Microsoft Learn. You can check it out at learn.microsoft.com. It's very exciting, and there's a bunch of interactive learning environments and exercises that you can check out. So what I'm going to talk about today is something that I call the art of computers, because I think that we spend a lot of time thinking about computers, and we think that it is they're magic. It's a science. We hear about computer science a lot, but maybe it's not as magical as you think. This is how I think of it. I've been doing computers now professionally for 30 years and messing around with them for over 40. Here's my first slide. I thought it would be fun to put a slide up with Comic Sans because it bothers people that I use that font, but I think it looks amazing. So I'll go ahead and I'll make that prettier, because when you do computers, you have to use a pretty font. All right. And then, of course, if you're going to do a talk, a keynote at something like this, you have to use some like really cool, evocative stock photography. And you also have to be a TikTok influencer. And you can cash me here. So I've got my background, because that's what computer people's rooms look like, right? Isn't that a great example of what the computer person's room looks like? Well, actually, it's not. Here's what my room looks like, because that's really where the real work happens during the pandemic here. But seriously, I welcome you all. I want you to be excited to be here. If you're early in career or later in career, we welcome you to start Dev Change. And I hope that in general, technology welcomes you warmly. I wanted to show you this wonderful actual magazine cover. This is a magazine cover here. Let's zoom in on that, from March of 1984. And look at this young lady here is on I want to say that's a Texas Instruments TI-89. She's got her bubble gum. She's getting ready to do something with a modem or a mouse there, and she's starting her coding journey. That's really exciting, and that's the kind of feeling that we want people to have when they're getting excited about technology. That's from 1984. Let's get back to that time where everyone felt excited about technology. So here's a question, my friends. When you're starting in tech, what's the trick? Are computers an art, or are they a science? We're going to try to answer that in this little talk here, okay? So as I mentioned before, I've been doing technology now for almost 30 years, but that doesn't make me an expert. That just means that I've had an opportunity to fail a lot and fail comfortably. So I've learned a number of things, and I'm trying to break them down here into kind of 4 categories of how I think about them. When you think about computers, particularly programming them, problem solving is the first thing you think about. We're going to talk about that. Then we're going to talk about what it means to layer things, layering in computers, why layering is important. I see people are arguing in the chat right now about whether it's an art or a science. We'll see, my friends, we'll see. We'll also talk about composition, when you compose solutions together with different things. That happens a lot on the Power Platform. It happens a lot in the cloud with things like Azure, when you compose things together. And then we'll talk about patterns and why patterns are important. So let's start with problem solving. If you're going to be a dev, a programmer, an IT person, a cloud advocate, you need to problem solve at scale. That means asking yes/no questions, the binary search, they call it. Is it this or is it that? If you can eliminate a class of problems, then you can cut them out completely and slowly debug quickly. I'll give you an example. I was presenting recently to a number of young people. They were high school students. And I said, let's learn to program, everybody. I think they were maybe 14. All right, friends, we're all going to learn to program. Bunch of young ladies in the room there. And I said, hey, my toaster is broken. I just hung there. let it be uncomfortable and awkward, waited for someone to help me with my toaster. They're all thinking, I thought I was learning to code. What's going on? Where's the code? Aren't we opening Visual Studio? What's happening? And then someone yelled out, does it have power? Oh, that was great. Someone else said, you should buy a new toaster. That was their solution. And I think that's an okay solution. It's a simple solution, but buy a new toaster was their answer for solving my toaster problem. I just want toast. But someone said, is there power to this toaster? That's a person that's thinking in the terms of systems. Number one thing after all these years is understanding how the system works together. It's the kind of thing that helps you, perhaps, as a technical person or as a burgeoning technical person, explain to your family why the internet's down. Even just knowing to turn the router on and off is an acknowledgement of the larger system at play. So with the toaster not working, I can say, hey, well, there's power involved. Like, there's not just the toaster. The toaster doesn't live alone in the world. One of the other young people said, well, maybe you should plug in something else to confirm if the power is on. And I was like, here we go. Now we're talking. Here we go. Someone in the chat just said, make sure you paid your bill. I love that. That right there is systems thinking. What's not systems thinking is dragging and dropping the text box again and hitting delete and dragging it again and hitting delete and pushing save 5 times. That's just doing the same thing multiple times and expecting a different result. But what we're doing here is we're thinking about how it fits into the system. Did I blow a fuse? Is there any power in the building? And then, I love this, one of the young people yelled out from the back, do the neighbors have power? I didn't even think about that. They said, go out the window and peek out and see if the neighbors are there. Folks in the chat are talking about that. Are the connections there? Are they loose? Like, you would be surprised how many times a loose connection has messed up my web application, which has been a problem. And then one of the final people yelled out that maybe that there was an EMP, an electromagnetic pulse, and aliens had come, and that was why I couldn't have toast. Turns out I'd blown a fuse. But we spent almost 15 minutes having a really interesting conversation. And what's exciting about this, and why I think it's fun in the chat that people are talking about this, is there's a lot of things that can go wrong. There's a lot of things. We could probably make a list of 100. I love that someone in the chat just suggested that maybe the bread was faulty. We don't know. Could be jammed in there. Could be a rogue Pop-Tart. We don't know. So early in your career, you're going to spend a lot of time Googling with Bing for stuff. You're going to search for things, and that's going to be okay. And then later in your career, you're going to discover that just one question can eliminate a whole class of problems. Maybe they're dumb questions, but just like Seth said at the beginning, there are no dumb questions. There's just the person that doesn't ask them. So we really want to make a welcoming community, both this community here at the conference, but also at the jobs, at the universities, and at the homes that you are going to be a techie at. We want to make a welcoming community where you can ask questions without being judged. Because if an early in career person can ask a question, they can eliminate a whole class of problems. So I love that that Lino in the chat just said it's always DNS. That is actually really true. There's a famous American president who said it's always DNS. DNS is the domain name services that turn a URL like www.microsoft.com or startdevchange.com into an IP address. And as you will find in many, many years of your time on the internet, it's almost always DNS. A lot of my problems I have are trying to figure those things out. I just made a list here in this slide about all the things that I know as an old person to check for. And it's literally just going through that list and checking for those things to make sure that maybe that's what it is. Maybe it's a port. Maybe my certificate's changed. You'll learn about all these kinds of things. My sons and I were watching Sherlock Holmes recently, and someone had murdered someone else. And when then they caught them, they grabbed that person. They said, look, it's her. And they said, no, she was on the other side of town. And immediately Dr. Watson said, oh, There's twins. It's twins. That's how they murdered the guy. There's two of them. Well, I put that in the list as well because it's never twins. Whatever the problem is, it's never actually twins. So be aware of that. So problem solving, super important. That is the thing. Ask questions at scale, yes, no questions as quickly as you can. Super important. Next thing, let's talk about layering. What does layering actually mean? What does it mean to layer a problem or layer a solution in order to solve a problem? Well, layering is vertical, and the intent of layering is to hide complexity from yourself and others. This is a great thing, and this is why computers work at all. We accept that a layer is there to hide complexity, and if the layer works well, we don't worry about what's underneath. An example of good layering would be switching from a manual stick car to an automatic shift car. An amazing example of layering would be like a lift or a ride sharing system, which abstracts the car away completely. You just get in. You don't even think about the tires and the gas and the car insurance. You're hiding complexity. You could go and write assembly language and do a really low-level application, or you can write a Power Platform application and stand on the shoulders of giants and hide that complexity from others. Folks in the chat are talking about this. How do graphics cards show graphics? They've worked for so long. We just assume that they work. These are really interesting things to think about when we're exploring our new careers in computers. Now, layering, I like to think about, is in fact also lying. You're lying to yourself, and that's okay because you're choosing to lie. You're hiding complexity. And this is really interesting because we can choose to look underneath. We can peel the layer away and see what's underneath that. Here's a really cool example. We've all sent email before, okay? Here's an example of an email. And well, we don't really think about the protocol, like how does it get sent? You push send and the email goes and then it's done. So I just decided to flip this around. I'm just going to take this and I'm going to turn it over and I'm going to show you the other side of the email. And you can see that there's a lot of text there and it's a little bit scary looking, but I see name value pairs. You see how it says from sender to recipient. And you'll notice here that there's some separators. This is the boundary. So I can see what's separating parts of the email. And here's the plain part of the email. And here's the HTML part of the email. So that's interesting. So then you say, okay, Scott, that's cool. Now we understand what email looks like. Well, when you're posting a form, when you're posting an HTML form, look at that. That looks familiar. There's a boundary separating sections of the form from the form data and other things. So an email isn't that far away from a form post. Do you need to know that? No, you don't. That is an interesting piece of trivia. And that's an example of a thing that you really don't need to know until maybe one day you need to know it. Just like you'll be in a ride-sharing car, you'll be in an Uber or a Lyft or a taxi, and one day the tire will pop. It's not really your responsibility to fix that tire, but it's nice if you know how. I'm not a mechanic, but I can change my oil, I can fix a tire, and I can call another ride-sharing service. So finding out that email and HTML forms are basically the same thing, and they're older than I am, is really interesting. So when you're exploring tech, you can discover and learn that all ideas grow out of other ideas. HTML is text that goes over a port. And if you don't know what a port is, that's okay. We can learn about those things later. But email is just the same. It's going over a port. It's using TCP/IP, the transmission control protocol that we use here on the internet. It's all just internet traffic. So when you're making your first Power Platform application and you're going to post forms and you're going to call APIs and you're going to start stitching stuff together, that's what's happening underneath. That's what's really interesting. All these ideas are being reused. On the right here, we have a picture of a record player, of an old Victrola. And there's a needle that touches wax that spins around right there. And that's pretty interesting. And on the left, we have a classic hard drive. They're the same thing. These things are the same. What's happening here is a spinning platter with information encoded on it is transmitting from place to place. In the case of the Victrola, it's happening over sound, and in the case of the hard drive, it's going maybe over some cables. These ideas are the same. That's 150 years apart. Still the same thing. Acknowledging that, thinking about that is really, really interesting. Folks, of course, are arguing in the chat that hard drives and SSDs are different. Indeed, but the idea of the fundamentals of the wheel are still there. It's really interesting. So then when we have these things, available to us, we can start to compose them. We can start talking about composition. And composition allows us to model relationships between systems. And we can say, this has a relationship with another thing. Folks are asking questions like, what's a port? And I apologize for using too much technical language. You can check out my YouTube at computerstufftheydidn'tteachyou.com, and I talk about what ports are and things like that as well. So composition models has relationships. When you compose things, when you plug two things together, or you take this thing and you put it inside that. When you compose a car has a tire, and the tire came from somewhere. These things also are ways of hiding complexity, hiding the complexity of the car, hiding the complexity of the computer, and things like that. And sometimes when things are hidden from you, you can get overwhelmed and frustrated, and then you can choose to dig deeper, or you can choose to ignore it. And that's interesting. Here's a true story. There's a really great show on Netflix, and there's a gentleman on that show who plays an AI. He plays an artificial intelligence. And I got to meet him. He's a lovely gentleman named Chris Connor. He's an actor, and he plays Edgar Allan Poe. So I got to go and interview Edgar Allan Poe, Chris Connor, from Altered Carbon on Netflix. And we met at the Microsoft office. And I went and I recorded a podcast with him. And it was amazing. And I was thinking, this is great. This is the coolest person ever. I want to be this guy's friend. So I'm hanging out with him, and I wrote about this. Here's me looking like a dork and him looking awesome. And then we have a great experience. And then I go back with the SD card, and I plug my SD card in, and this is what I see. Here's the SD card. I kept it because it was such a painful memory. I've got this SD card, and if I zoom in here, you'll see what happened was I had infinite empty folders. I just talked to an actor that I looked up to and recorded an amazing podcast. Yeah, I love it. Someone in the chat said, does it have power? These are the questions that we have to ask ourselves. I felt this in my chest. It hurt. I was like, oh my, I just lost this interview. This is me in my disk looking for my files. It was really, really stressful. And at that point, it's just a black box, right? This SD card is just there, and is the interview in there? I don't know. How deep do I want to go? How much do I want this thing back? Well, pretty badly. A lot of great questions. This is like a toaster question. Our friends in the chat are saying things like file systems. Someone said, always have backups. That's a good question, and I will take that responsibility. Should I have a backup of a thing that happened 10 minutes ago? Maybe. I literally just recorded it, went home, and it was gone. But here's what happened. I looked at my disk in Windows, and it showed me that there was actually used space. So something's there, and it looks like about 300 megabytes, which is about how big an interview would be. So that's something, okay? Now, that's as far as my abilities go. But I know about layering, I know about composition, I know how to search. So I could start thinking about where this could be. And I know that there's bits and bytes, and they're sitting on this disk somewhere. So could I maybe get all of the bytes, lay it out, like give me a dump of every byte that's on this device? So I did that. And I went and I Googled and I binged and I binged and I Googled and I looked for things and I found tools that said that should be this and this should be that. And those are all zeros, and zeros are probably not a good idea in this situation. And it took me a long, long time, many, many hours, and I got deeper and deeper into this thing until I finally found out that my file system was corrupted and it could not be fixed manually. And I ended up learning all about file allocation tables, what's called FAT32. And I also learned that when I recorded my podcast, I didn't record one file, because when I got my file back, it sounded weird. It's going back and forth, and it was like left and right, and it didn't understand what was going on. And it turned out that what happened was the tool that I use records the left side and the right side as a separate file. That was very weird and interesting, but I ended up getting those files back, and I saved the day, and I maintained my friendship with my Netflix friend from Altered Carbon, which was really exciting. So does this mean that I'm some kind of an elite hacker or some cool person who can go and debug stuff? No, it does not. What it means is that I acknowledge that nothing in the computer is hidden, and I just had to ask myself, how far did I want to dig? Think about that for a second. I could have plugged it in, and I could have run check disk or asked Windows to fix it, but I said, I don't trust that. I'm going to go a little deeper. I don't know what I'm doing. I really don't, but I know how to read. And I went through all the different things, and I tried to learn, what is the computer hiding from me? What is layering on top of itself? There's a file system, and underneath that, and underneath that, and underneath that. This is a very simple analogy. I keep coming back to it, this idea of the car. You don't have to be a mechanic. No one here at Start Dev Change is asking you to be a mechanic and know how to build a car from scratch. But there's a couple of interesting and useful things that would be cool. So you're going to learn how to make great applications. It'd be nice to know how to reboot the router. Know a little bit about, how to have a little bit of a network, or maybe set up if DNS or if a URL doesn't look right. You could say, hey, that URL doesn't look right. You get to decide how deep you want to go. We're going to spend our time here talking about applications, but other people in computers and technology decide to go deeper and deeper and deeper and deeper. And if I wanted to, I could probably go and learn those things. I could go and learn about how they put those bits and bytes and electrons on this and how they stay there. But I fortunately didn't have to. I only had to go down one level there to the file system. Is this the same thing as abstraction? I love that question from the Walrus in the chat. That's exactly what this is. Abstraction is hiding complexity. And choosing to deny that abstraction and look underneath it is part of the debugging process. Yeah. Someone's making another great point where they talk about how low do you want to go? Someone had a very funny thing once. Let me see if I find that. Here, I'll just use my keyboard. There was an interview question, and someone said, hey, when you type www.microsoft.com and you press enter, what happens? Some people say, well, the browser makes a request, and it brings back the HTML. And that's a great answer. But I did this interview, and I said, you type Microsoft.com in the browser and you press enter, what happens? And the interviewee says, well, you take the key, and the metal and the key touches the metal underneath it, and then an electron jumps from the one key to the, and then they started going into the atomic level and talking about electrons and neutrons and quarks and stuff. How deep do you want to go? When you're thinking about abstractions, how much do you want to abstract? Is that a good answer? Maybe it wasn't the answer that I wanted, but it's a totally valid answer, because that's exactly what happens when you type Microsoft.com and you press enter. Figuring out what layer you want to live is where your career is going to start. And then finally, the last thing that you want to say and think about are patterns. The other ability that you'll have as you spend more time in technology is the ability to recognize patterns that you've seen before. You go, hey, I had that happen before. That was a mistake that I made before. That's good information. One of the things you'll notice that my stories unfortunately involve me spending many, many hours debugging things. But the fun thing about spending many hours debugging things is you only have to do it once. One time I spent 13 hours debugging a Raspberry Pi. I've got my Raspberry Pi here, not a real Pi, but a computer Pi. Here's a Raspberry Pi. And I was trying to copy a file onto the Raspberry Pi, and everything was great, and it was working, and then it stopped. I was using FTP, and I FTP'd, file transfer protocol, my file onto the Raspberry Pi, and it didn't run. I was finding myself in a classic works on my machine situation. So once again, I decided to go a little deeper, and I learned something. I said, look at all these scary files. What's going on here? And I go, hopefully you'll never have to look at things like this in your career. But I noticed that they were missing stuff. 0D, all the 0Ds were gone from my file. When I compared the one that worked with the one that didn't, I said, this one's missing all the 0Ds. That's super weird. There's one, and there's one, and there's one. Who stole my 0Ds? And why would that be a problem? Well, it turns out that there was a checkbox in my program that said, if you have a file without an extension, you should treat it as ASCII. ASCII means text. So it was taking my program, my binary file, my program, and it was turning it into text. So what does that mean? Why is that a problem? So what? It turned it into text. Well, where have I seen that before? Pattern recognition is so important. Well, 0D is hex for 13. Yeah, someone in the chat says, uncheck it. Yes, I did uncheck it, but I want to know why. 0D is carriage return. Then you find yourself asking the question, what's a carriage? Why is it returning? What's going on? I want to know. Well, it turns out that a carriage is the top part of the typewriter. And when you return it, you pull this return over, and then you spin this and you say line feed. So it's 2020, and we're still thinking about carriage return, bing, line feed, and then you rotate that and feed that. When you think about that, when you're using Git or source control, you'll see carriage returns and line feeds. Isn't it interesting that 100 plus years later, we still think about carriage returns and line feeds? And in my case, those were being stripped out. I've also got a video where I talk about this a little bit. So as I get towards the end here, I want to remind you what we just discussed: problem solving, layering, composition, and patterns. And ask yourself, what can you make now? When you can layer things together, what can you start making with those things? Here's an example of a wonderful, fun thing that I made, and I work on with a lot of friends. And I got to sit on a number of projects and work with this, is an open source artificial pancreas. I'm a diabetic, and diabetics have to take insulin and measure our blood sugar, and it's a whole thing. But once I get my blood sugar from these different implants that I have, I can go and upload them into a database. I could build a Power application on top of them. I could make an API. I turned it into a REST API for my body. So now I have a URL that I can visit that will tell me my blood sugar. And, oh, don't be sorry, friends. I'm not sorry. I appreciate that, though. And then I can make like little screens that have my blood sugar on them. This is a little screen in Python with it's green, showing me that my blood sugar is good. And then I put my blood sugar, with the help of my friend Nate, into the prompt so I can see what folder I'm in and what project I'm working on, and I can see my blood sugar, because that's important to me. Once you have the pieces, once you understand layering, you can start composing things together and doing a lot of fun stuff. So to our question as we end, what's the trick? Are computers art or science? Yes, they are both. That is the trick. You, my friends, can build anything that you want once you accept and understand these basic principles. And I want to remind you, even though I started this talk with the statement that I've been doing tech for 30 years, we're all amateurs. We're all learning. The things that I learned 30 years ago are not the same as the things that I know today. There's no professionals. Someone might say, yeah, I've got 20 years experience. You have to ask yourself, is it the same year's experience 20 times? Maybe they're just repeating themselves. And if Tim Berners-Lee, who invented the World Wide Web, chooses to not put senior web developer at the beginning of his name, he didn't even put the. He could have shown up, hey, what do you do? I'm a web developer. Oh, yeah, senior web developer? No, the web developer. I did that. If he can be a web developer, then you can be a web developer too. So go out there, be a Swiss Army knife. It's okay to be a funny little knife that doesn't do anything well. That's what I am. And but focus on the fundamentals. Just at least be a good knife. Don't skimp on the basics. We're so glad that you're here. Thank you so much. And I'm going to throw it back to Donna and Seth in the studio. Thanks, friends.
Hello. So, how interesting was that? Is tech and art or science? It's an and. So we do not have a lot of time right now to go through Twitter and call you out and assign you homework, but we are going to do that. So thank you for all your engagement. We see you on the Twitch. Thank you for your engagement. Seth and I are actively monitoring live twitching, I guess.
Yeah, live twitching.
Live twitching. That sounds weird.
We actually have to learn what it means when people do the Twitch.
Yeah, because we are not cool like that at all.
But we have someone to teach us later
We are.
on.
That's coming up second.
Okay.
But first, speaking of ands, we're going to bounce to a panel of 3 inspirational humans who you absolutely must know. There is Danny Thompson, who used to fry chicken at a gas station, is now a software engineer. April Sprite, who used to work in fashion merchandising, is now a software engineer. And Aisha Brown, who is ex-military, now working in technology. So these 3 people are incredibly inspirational and so authentic, and they are going to share their journeys with you right this second. Are we ready for you 3?
Hey, thank you, Seth and Donna. I'm so excited to be here and part of this event. To be completely honest, I'm such a huge fan of Donna that I'm kind of fangirling on the inside, but I'm trying to keep this calm, cool demeanor on the outside to make sure you know that I'm here for the right reasons. But the way I always start this off is my journey to tech was not the traditional one, and the reason why I got into tech was because of a rapper. This rapper invested several million dollars into a tech company, and he was giving an interview about this on TV. And this kind of was interesting to me because I never knew why someone like that, from my kind of background, my kind of area, would ever invest into a tech company. And he said he was learning how to code. Now, this blew my mind because I never knew someone from my background could learn how to code. I thought this was reserved for the PhDs and the rocket scientists of the world. I never knew an average individual could ever be in this field. And so he starts learning how to code, and the reasoning was profound. He said, why wouldn't you want to know how the thing that you touch 90% out of your day operates? Why don't we have a basic understanding of how computers work? I have a basic understanding of my body. I know if I'm sick, either A, I need to go to a doctor, I'm not going to make it, or B, I can take some Robitussin and ride this out, I'll be A-okay. Or if my car makes a weird sound, I'm like, oh, I need to go see a specialist. So why don't I have the same understanding of how this computer operates? Why is the limit of my understanding opening youtube.com and watching videos of cats playing around with yarn, right? So he starts learning how to code, and so do I. And I get on freecodecamp.org and I start learning. And I'm going and I find out about this thing called meetups. And I go to this meetup, and at this time in my life, I know HTML and CSS. I make it a very bad application, very simple, where you enter the URL of an image and add some coloring on top. It's a really, really bad filter, but it's safe to say at this point in my life, I could cure cancer with code. I can't, I'm terrible. It sucked. But so I go into this meetup, and I very quickly realize that I don't know anything. And people are saying these foreign language to me, like C# and Java and SQL. And I don't know what any of this means, but now I'm hooked. I've been introduced to this brand new breadth of knowledge that I didn't know existed. So I start learning. I go home and I start learning. I start learning about JavaScript. I start learning ES6 functions. And I go to that next meetup. I'm like, well, do you know what an ES6 function is? Do you know what an error function is? Now I start going learning more and more and more. And I go start learning SQL. And I go to that next meetup. I'm like, well, do you know what a SQL table is? Do you know how to do a SQL query? And I start learning more and more and more. I start learning about Java. And I go to that next meetup. I said, well, do you know Spring Framework? Do you know how to do this in Java? And now I'm a part of this amazing community of phenomenal developers that are there that just want to help as many people as they can. And I love being a part of this. And I truly preach meetups all the time because meetups genuinely changed my life. If it wasn't for finding a supportive community of developers, I don't know if I would have ever been able to make that transition to tech. Because one thing you have to understand, this entire time, I was working in gas stations frying chicken. I fried chicken. I had a PhD in fried chicken. I could fry the best chicken around. I gave Chick-fil-A a run for their money. But I was stuck not making anything. I'd work 80, 90 hours a week and I'd make just enough money to be broke. And things were getting hard and I found myself really questioning like, what am I gonna do? Like how am I gonna pay all these bills? I got a kid on the way. I don't know how I'm gonna make it. And I go and I start progressing and I start getting involved in these communities. And I remember going on these interviews and I was doubting myself. I'd have all this imposter syndrome and this doubt coming to me like, Danny, they don't need you. They don't want you. They want professional developers. They want people with experience. They don't want someone that smells like fried chicken when they come into this interview because you're coming from the gas station. They don't want you. They want someone that knows what they're doing. And that's not you. My doubts, my insecurities, everything that I doubted about myself, I made it. I'm Danny Thompson, and I'm a software engineer. Thank you. I'm so happy to be a part of this, and I hope you find some inspiration today to make sure you get to where you're going. And with that being said, I kick this off to Asia.
Man. Oh, Daddy, that was passionate. Thank you. I'm a +1 on the fangirling for Donna, too, because I'm a Donna fan. I told her on Twitter earlier that I don't have enough stickers on my computer yet, but I'm going to get there. So I am taking donations if you're sending stickers. My journey to tech was a little different. And I spent 16 years in the United States military. I spent 4 years in the Air Force, and I knew I wanted to be a Marine. But I was 17 when I joined, and my dad was like, nope, not going to happen. You're not going to the Marine Corps. All my uncles were Marines. All my uncles were crazy. They were wild. He was like, no, you can go in the Air Force. So I did my 4 years in the Air Force. I was a mortuary specialist. And what I learned in that job was that nobody talks back. And it was lonely. So I was like, I don't want to do that no more. So when I went to the Marine Corps, they're like, what do you want to do? I said, I want to be somewhere where the people talk. They were like, cool, great. Communications. And I was in communications, but I was on the hardware side. So more things than people. And from there, I was like, well, I want to do something where I get to talk to people. So I went on recruiting duty. Recruiting duty really, really changed my life because that's where I learned that I love to bring people along. I love to make people smile. I love to see people's dreams come to fruition. Like I would literally just sit there and listen to people tell me about their lives and what they wanted to do. And I would try my best to match them up with something that fit or at least led them towards their passion. And for me, that's where I got all of my enjoyment. That's all my enjoyment. And then came time one day I'm sitting at work and I'm like, all right, I'm done. I want to do something else. And the day I decided that I was going to leave the Marine Corps, and I did 12 years in the Marine Corps, it was, I'm going to go to Microsoft. That was it. What are you going to do? I don't know, but that's where I want to be. And I decided that I wanted to go back into tech, but I wanted to do something where I can talk to people, I can help people, I can bring people along and just contribute like goodness out. That was my thought process at the time. And I landed somewhere in Microsoft where I could do that. However, I didn't have the people part. So I was doing great things. I was with a great organization and the organization was doing great things. They were helping people, but I missed talking to people. So I went out on this venture to like, let me go find people to talk to. I want to be customer facing. I want to be out. I want to be in the community. I want to be talking. And I landed here in Fast Track for Azure. I love my org now because I get to talk to everybody, profits, nonprofits, tech for social good, schools, the Boys and Girls Clubs, just places where we get to literally see the things that we're doing come to fruition. And when I got here, I'm like, the imposter syndrome was real because I'd spent so much time in the military that I would come and I would just sit at my desk and be trying to figure out what I was doing there. You know, my boss would look at me and she'd be like, what are you doing here? I was like, I work here. She's like, I know you work here. I hired you. And then I really wouldn't know why I was here. And I had to struggle to figure out my why again. So I say that to say, it doesn't matter what your background is, where you came from, what you do. You know, anyone who knows me at work knows that I'm on skates. I'm always on skates. That's what I do. I mentor on skates. I work on skates. Sometimes I'll be on customer calls, won't have my camera on, or I will have my camera on, and I'll just be listening. And they're like, why are you always on skates? Well, because I have anxiety. And in order for me to maintain my anxiety, I maintain fluid movement. So I'm usually moving. So nothing can stop you but you. And if you want to code. You want to develop. If you want to build. But you have to do something. And the only thing that is going to stop you, that's going to block you, that's going to tell you that you're not good enough is yourself. Because anything that's put in front of you, you can either go around, go through, go over, or you can turn back around and walk the other way. But I promise if you just keep going, you're going to learn it, you're going to know it, you're going to overcome it. Like, this is a beautiful, beautiful community to be in. It doesn't matter if you've been out of the workforce for 10 years. If you've been out of the workforce for 10 years, I guarantee you've been doing something. You've been building a skill somewhere else. And it's very, very easy to just jump right in. All you have to do is take that first step forward. And once you take that first step forward, you don't ever have to go back. So thank you for your time. I appreciate being able to sit here and chat with you all. I'll be in the comments in a little while on Twitch. I'm going to kick it over to April.
Hey everyone, my name is April Spate and I'm a Senior Cloud Advocate on the Spatial Computing Technical Team here at Microsoft. I transitioned into the tech industry 7 years ago. Prior to coming into tech, I worked in the luxury fashion industry as both a menswear stylist as well as a visual merchandiser. Since transitioning into tech, I've taken on a variety of roles in project management as well as being a systems analyst, a program manager, and now today here in developer advocacy. Absolutely love it. One thing that I'm often asked is, how did I transition into working with extended reality, especially since I don't have a developer background? Well, today I'm here to tell you that story of how I got into the XR industry. And I will say it all started with a tweet on Twitter. So for starters, I joined Microsoft in February 2019 as a senior program manager with the docs.microsoft.com team. My area of focus was interactive features for the documentation platform. So as I mentioned, I didn't have a developer background, nor did I have a CS degree. I was actually coding in my free time, and I did it because I thought it was fun. That summer, I took a trip back to the East Coast to visit my family. And of course, while waiting in the terminal for a delayed flight, I decided to get on Twitter and scroll and see what was going on just to pass some time. I happened to have came across a really cool HoloLens 2 demo that integrated speech translation. And what happened was that the speaker could speak in their native language and then it would be translated to another language on the receiver's end. So thought that was absolutely cool. I instantly went to Twitter and I asked everyone, what was it that I needed to learn in order to do what I had just saw? Fortunately, the response was plentiful. I got a lot of feedback from the XR community on how to get started, and that also led to me being invited to a workshop that Magic Leap was hosting that upcoming weekend. So I agreed to go to the workshop. Only problem was that I didn't have C# experience and I didn't know Unity at all. So essentially I had a 5-day cram session of learning this new programming language as well as this new development platform for gaming. And it might have been a very difficult, intense struggle, but I actually finished it in time for the workshop. And I felt that I had just enough knowledge to get started. Turns out I knew a lot more than I thought I did, and the workshop went pretty well. Shortly after that, I met up with some folks that worked in Microsoft within the area of mixed reality as well as spatial computing, and I got a chance to actually try out a HoloLens on my own for the very first time. Absolutely thought that was cool. I stayed in touch with those individuals, and I also had a mentor at Microsoft that helped me get ready for that next step in my career, which happened to turn out to be developer advocacy. I also connected with my actual manager that I had at the time, and we put together a career development plan that would help me prepare for that next role. Fortunately, later that year, earlier, let's say here 2019, the opportunity presented itself and I made the transition over to my now team, which is within spatial computing. Shortly after joining that team, I attended MIT Reality Hack, and that was my very first hackathon ever. Didn't know what to expect, but it was probably one of the best experiences I've ever had since being in this industry, I would say. Myself and 3 other individuals, we created a VR learning experience app that's designed for children to help with children with dysgraphia as well as dyslexia, and it helps with their letter formation and their word recognition. Completely shocked that we actually won 2 categories at that hackathon, and I will say that gave me the confident boost that I needed walking into my now role in developer advocacy. One thing I will definitely say is where I'm at today definitely took a village. Making this career transition, especially into this whole new, different area of tech, would not have been possible without the help of everyone that has helped and contributed resources, folks that I met with along the way, whether it be online or in person, having people behind the scenes that are rooting for me and are helping me make connections. That definitely made a big difference. When it comes to career transitions, it truly takes a village. It's not something that I feel that everyone should just do on their own. If you have the opportunity to work with others, pair with others, network with others, definitely do it. That's 100% how I got to where I am today. I want to wish you all the best of luck in your career transitions wherever you are on your journey. And if you want to stay connected, come find me on Twitter at Vogue and Code. And you can also connect with me as well on my website, which is www.vogueandcode.com. Until then, you all take care.
Thank you so much for allowing April, Danny, and I to come share some inspiration and energy with you all. I'm going to kick it back over to Seth and Donna.
All right.
Hello.
Wow, I feel like I can do anything.
Those stories are so inspiring because all of these people had complete, full lives before tech. And they realized, hey, you know what? There's so much opportunity out there. There's so much opportunity to get a great job that'll last me forever, a great paying job that'll last me forever, and one where I can really pursue all of these like curiosities I have about how things work in the world.
Although I will, there is one, I do need to make a correction to something somebody said. If someone showed up to a job interview smelling like chicken and I knew they made it, they would be hired on the spot.
Immediately
just
hired.
saying,
Immediately.
to throw that out.
We just had a long discussion about what we're going to order for lunch, and now it's going to be fried chicken. Thank you, Danny.
That was
It is
awesome.
going to be fried chicken. Love that. We're
And here's the thing, like, there are so many of you out there thinking, nah, tech, I can't do tech.
Nope.
No, we actually need everyone, right? Because there are problems that everyone needs solved, and tech is a good way to answer it. Are we talking to Brian Clark? Let me ask our producer.
Yeah, let's ask.
Okay.
Oh, by the way, this is not going to be the most highly produced event you've ever seen.
No.
By design.
We're beginners at some of this stuff, too.
We're beginners at
so.
event production, if you can't tell.
So is Brian on the horn? Okay. Oh, okay. Get a thumbs up.
Brian's
Brian, can you hear me?
Seth, I can hear you.
Okay. I think it's. Where are you on the moon or something? What is that?
Where are you?
I am, and it's wonderful out here. The view is amazing, and I'm so happy to join you from here. I mean, I was a little busy, but I thought for you and Donna, I'd make some time.
Well, I'm looking here. The next thing doesn't start till 9, so we have about 5 minutes for you to help us understand the twitching. What is? Tell us about the Twitch. Am I saying it right? Is it the same as the TikToks?
Yes. You threw me off there a little bit with the pronunciation, but I think I understood what you meant.
Okay.
So Twitch, everybody, welcome. Happy to have you all watching. Those of you that are on Twitch, if you're not on Twitch and you haven't heard of it before, it is a live streaming platform. For those of you that have heard of it, you might have heard of it because of gaming, and you think it's just related to gaming, which it is. I mean, not just, but it's mostly known for the gaming side of things. But there are other categories, if you will, that people can stream under. One of them is science and technology, and that's where a lot of folks that are in the programming community, developers, coders, come together to share what they're learning and collaborate with each other and build community, get to know each other and help each other out. So really quick to kind of give people an overview of, let me bring up my slides here.
And you're going to be doing a session about this later on too, right? So this is just like a digest.
Yeah. Real quick overview, real quick, I promise. So if Jim in the back, throw up the slides quick. There we go. Thank you, Jim. So this is what you typically do when you type into the keyboard. And now I know a little bit more thanks to that story Scott shared, how a keyboard works. You type in twitch.tv into your favorite browser. You land on the homepage here. Now it's going to be very kind of maybe daunting at first because there's a lot going on if you're new to it. But the key that you want to focus on is that search bar at the top. that's going to show you some options to search for things. I'm going to tell you exactly where to go. You want to search for science and technology. That will bring you to this view. And then in here, it's going to show you a list all the way down of all the streams that are live right now in this moment. And you can pick and see based on the title and whatnot that the people are streaming about to figure out what might interest you the most to go learn more and get to know that person that's streaming that type of topic. There's also some tags here that you can filter a little bit more. Maybe you want to focus on game development or software development, things like that. And then, as I was mentioning before, this area here is those screens are folks that are streaming, such as chickens, which is part of science and technology.
Of course. I mean, what else could it be? Look, I'm looking right here. There's a I think it's a gentleman or a person messing around, says, I use Twitch every Sunday at 11. I am just now learning to code, and I do it live on Twitch. It's scary at first, but it's so much fun. That's kind of inspirational.
Yeah, it really is. And if folks haven't checked it out before, maybe you didn't hear of it before, it's an amazing experience for everyone that's involved, both streamers and folks that are viewers in the community, because of the fact, and if we bring it up here, this next screen that I have, this is what you would see, not blurred out, I'm just blocking things here,
Sure.
but you would see the streamer in the main screen, and then on the side, there's a chat room. And that's what, if you're watching on twitch.tv/Microsoft Developer right now, you'll get that kind of presentation to you. The chat room is where you can get that real-time interaction with the hosts of the stream. And you can ask questions and learn from them and offer your help. Maybe they're struggling, they're stuck on a bug or something like that, and you spotted it. You can offer your help via text in the chat channel there on the right-hand side. Let's get that highlighted real quick. There you go, a little red box around there.
Very nice.
So there you go. Any questions, Donna and Seth?
Donna, do you have any questions for?
Are we cool enough to do this?
Are we cool enough to do this? Is this I love doing video stuff, you know. I'm on a video right now for those that are wondering. But what would you Twitch about? Is it Twitch a verb? Would you Twitch?
Yeah, I think that's what the kids are saying nowadays.
Okay.
They're using it as a verb. And yeah, it's great that you're bringing that up, that question. Maybe you're new to programming or you're experienced in programming. I really believe that it is for everyone. And the important piece of that, especially for folks in this conference where it might be new to development, they're starting their journey in learning about programming. I think you bring a unique perspective that other folks may have lost sight of, those that might be more experienced, right? And you're going to be able to teach and provide more insight and like I said, perspective on that learning journey as you share that through streaming, if you want to get started streaming, or you can start out as a viewer and help other people out too. I think it's short answer. I think it's for everyone that's looking to be in development.
And I think it's cool because early on, I don't know when it was, the early zeros, people were pair programming is the thing.
Yeah.
And this is the way to do pair programming when you're learning stuff. You're like, hey, no, you should probably do it this way, or some thoughts. I really for example, I use Twitch a lot, but I don't stream to Twitch. Maybe I should, I don't know, would anyone watch a show that I did? What should I talk about?
AI?
Well, I think whatever interests you most is probably, if you're looking to get started streaming yourself, I would suggest streaming what interests you the most, because if you don't, then you're not really going to feel the motivation to start sharing and streaming. You're gonna lose that interest in keeping going and not feel very motivated about it. So I would say whatever you're interested in, so maybe AI and machine learning. I think there's plenty of room. There's an abundance of room for folks to start streaming themselves.
So someone said start playing games. No one wants to see this dad play an old school game. I'll basically be that guy that's walking into the wall all the time. Am I doing this right? And then I don't know how many people would watch that. It'd be
Everyone
funny.
would watch that.
Seth, I'm telling you, people, I think for the most part, watch streams for the person, and then on top of it, the icing on top would be their learning, from what you're sharing.
Well, Brian, this has been awesome. We're going to get more of this goodness later on today. But coming up, we have, and I have in my little hands right here, we have Intro to Languages, Hello World,
With
for
Shanna
30
Matthews.
minutes with Shanna Matthews.
Yeah.
Are we close to that? Are we good?
We good?
We good.
We're
Let's
good.
go to that right now.
So let's go to Hello World with Shanna Matthews.
Hi, thank you, Seth and Donna. Good morning from Seattle. My name is Shanna Matthews. I work at Microsoft in developer advocacy, focused on students. So I'm excited to be talking to all of you today, all you beginners, students out there, people coming in and trying to learn tech for the first time. It's really intimidating. So thank you for coming to hang out with us, and hopefully you can learn something. today I'm going to be giving a session called Hello World in 3 languages. The idea is to be like a brief compare and contrast between some of the 3 most popular and beginner-friendly languages. And it's kind of stuff that I wish someone had told me when I was first trying to get started with coding. Before we jump right into it, I actually wanted to talk to you about some of the resources that are available after you listen to this talk. If you're excited about learning some of these languages, please go check out Microsoft Learn. I'm sure you've heard a little bit about it and you'll hear more about it throughout the conference, but Microsoft Learn is your best friend for learning anything about technology. The link here, aka.ms/stc/hello world, links you to a really awesome learning path about Python that's super beginner friendly. So it starts from the very basics, helps you get started with everything from writing your first Hello World program in Python to setting up a developer environment, and keep it on going. Also, please hang out with us here, ask us questions. We're live on Learn TV and at Twitch. I will be on Twitch after my session to follow up and answer questions if you guys ask them. I won't be monitoring the chat while I'm chatting with you guys here, but please ask your questions. Someone will be on trying to answer them as I go, and then I'll be on afterwards to follow up with anything that was missed. Cool. Okay. So like I said, this talk is kind of one of the things I wish someone taught me when I was first learning how to get started with coding. There's just so much context. There's so much syntax. There's so many weird background things. There's just so much that you're expected to know already going into it. So the idea of this is to like help you get started with some of that stuff, take you behind the scenes a little bit, tell you a few things that I wish I would have known when I was learning. And we're going to be using the Hello World program as our example. We're writing or messing with any code today. And I'm going to give you a tiny bit of background about what the Hello World program is, why it came to be. Probably, maybe if you're watching, you've heard of it or you've seen it before. Right now on screen, we have the Hello World program in the programming language C. We're not going to be talking too much about C today. It's not one of those top 3 languages that I would recommend for beginners, but it is really interesting for historical reasons. And it's tied into where the Hello World program even came from in the first place. So let's talk a little bit about that. Hello World, as I said, is usually the first program you write in a new language. It's really to help you get your feet under you, make sure you can do just the very simplest thing in a language. Make sure you can print some stuff to your console, to your terminal, print some stuff out. So why do we use Hello World? We use it to get our feet under us. We use it to get familiar with a new language, do something simple, make sure we can actually run a program. And where did it come from? So the Hello World program is widely credited to the guy in this picture right here. His name is Brian Kernighan. He's super famous for writing a book called The C Programming Language with his co-author Dennis Ritchie. And the program Hello World showed up in this book about the C programming language, but that's not actually where it came from exactly. Brian Kernighan wrote this program actually in his first book before this one, which was about the programming language B, which, yeah, B is the programming language that came before C. That book was called A Tutorial Introduction to the Programming Language B. And in that book, he included the Hello World example, and then he wrote it again in the C programming language book, which was wildly popular, and it took off, and people have been using it really consistently ever since. So I think this is one of Kernighan's biggest legacies, the Hello World program, and of course the C language as well. So what are we going to actually do today? We're going to look at Hello World programs in Python, C#, and JavaScript. We're going to play around with each of them a little bit. We're going to kind of understand what are some of the weird syntax quirks. Why might we as a beginner choose one of these languages over the others to try to learn it first? What are some like stereotypes about this language? What's some of the context around it? You know, why I like to think of it. Why are you going to find people like poking fun at each one of these different languages? So like you can be in on the joke when people are making jokes about these languages. So really the best way to get started and playing around with any language, with anything in tech, is to just get your hands dirty and do it. So we are going to do the rest of this session pretty much, except for maybe a little bit at the very end, in Visual Studio Code right here. A quick note before I just jump right into it. My setup here in Visual Studio Code is not quite standard and not quite normal. It's just something that's to make it easy to run all these languages at once in one fast session. So if you see stuff that's a little funky, like all this stuff going on at the bottom, all these folders, don't worry about it too much. We're only going to be focusing on what's here in the editor portion and what we do here in the terminal portion. So just typing out a few commands. And if you have any questions about what else is going on in here, please throw them in the chat. People will be happy to answer, and I'd be happy to talk more about it afterwards. Okay, so first up is Python. Python is one of my absolute favorite languages. I think it's super beginner friendly. It is not the language that I started in personally writing code, but I think it's the language I wish I started in. And part of the reason for that is the syntax is extremely simple. So this is the Hello World program in Python. And as you can see, it's just 2 lines of code. It's super simple. All we're doing here is defining a variable called message, and then calling the print function with that variable and printing it out. So it's very intuitive. You can kind of tell exactly what's going on here, even if maybe you don't have a background in coding. I bet if someone had never written code before, they might be able to guess even what's happening here, which is not always common. So how do we run our Python code? That's also simple. I'm going to type Python 3 on the command line and then the name of the file that I want to run. If you're on Windows versus Linux, you might type just Python versus Python 3, but we're typing Python 3 for today. So we can see we have run our code. It worked. We got our message, hello world. And if we wanted to change the string, hello friends, we can run it again. Bam. That's hello world. So let's talk about syntax of Python. And when I'm talking about syntax, I mean like the weird things that you have to type on the screen to actually make the code work. Python syntax is actually pretty easy to grasp compared to some other programming languages, but it is odd in some ways. So one of the ways that it's the weirdest is what Python does, or how it cares about white space. And by white space, what I mean is the characters that you type in here that don't just look like anything. So I'm typing a bunch of spaces, and if I highlight it, you can see those dots mean spaces. You can type tabs, and if I highlight it, you can see those little arrows mean tabs. So tabs and spaces are pretty much what we refer to when we say white space. And Python is really funky compared to pretty much all other programming languages because it cares about white space. Let me show you one example of what that means. So I'm gonna make another variable is conference and set it to true. So I've just made another variable and set the value of that variable to true. And then I'm gonna write an if statement to check something about a variable. So I'm gonna check if is conference. And so what that's doing is checking if is conference is true. Then I'm gonna change message. Let's see if I can spell. Okay, so quick, let's run this just to show that it works. So what we've done is we've got this variable, set it to true. We're checking if it's true, and then we change our message. You can see that the message was changed. Awesome. So the thing that's funky about this is Python here is actually looking at this white space right here that I'm highlighting to tell what goes in this if block. Most programming languages are going to look for curly braces instead. Curly braces. So it's going to look at these things, which are called curly braces, to try to check if something is part of an if statement or another logical block. Python doesn't do that. Python, we don't use curly braces, and it's a little odd. We use white space instead. So one kind of gotcha with this white space thing. Oh, and I'll show you. Like if we did that instead, Python's not going to be happy. You can see already Python is saying like, hey, I expected this to be indented. So let's indent it again. Don't want it to be that mad at me. And let's look at one gotcha with Python. So we said that we care about white space. And one thing to keep in mind, as I was saying, there's two kinds of white space normally that we talk about: spaces and tabs. And lots of programmers like to argue about spaces versus tabs. I personally don't like to argue about spaces versus tabs. I like to say, hey, do whatever works for you and your code. But Python, you need to be consistent at least. That's the most important thing with Python. So right here, we have two tabs. We have a tab here, we have a tab here. And that's all good. We can do whatever we want. But what we can't do is add spaces and tabs together in one file. So let's just like print something else. Hello. So as you can see here, we've got spaces here, tabs here, and Python is already telling us that this is an issue. We have an inconsistent use of tabs and spaces in indentation. So if we tried to run it, we'd get that same error. Visual Studio Code is being really nice to us and kind of showing us that error before we even do it. So thank you for that, VS Code. So I'll just show you, if you made them both spaces, you'd have no problem. So space is fine, tab's fine. You just gotta pick one or the other. Okay, cool. So another just thing to mention that we'll maybe see more is that we don't use semicolons in Python. That's because, again, try to keep it as simple as possible. So we don't use semicolons. We'll see those in other languages. So let's think, why would we use Python? If you've kind of heard of this new AI or data science thing that's becoming really popular these days, Python is a great language if you think you might be interested in data science, because it's very popular. It's one of the most widespread languages in AI and data science. Python is also great at a lot of other things too, though. So it's not just niche for that area. It's great for web development, especially backend stuff. It's great for general development. It's great for prototyping because you can write pretty quickly when you're using Python. It's also good for people who kind of don't consider themselves programmers, but have to write code for some reason. So they might be wanting to automate some tasks that they're doing, or they might be a researcher and just need to write a little bit of code to help with some of their research. Python is great for all of those people. One stereotype about Python before we move on to our next language is that Python is slow. This stereotype is kind of true. It can be true. One of the reasons for that, one of the reasons Python can be slower than other languages is because of typing. And when I say typing, I am not actually referring to the typing that you do on your keyboard. I'm talking about variable types. So I mentioned that we were defining a couple variables here. These variables have types to kind of help our compiler, help our interpreter know what we're supposed to be able to do with them, know how to treat them. So the type of this message variable we can see, because VS Code, again, is being really nice and awesome for us, is str. And str is short for string. So string refers to words, basically, a series of letters or characters that you put in quotation marks. We can see isConference is a type bool, which is short for Boolean, which just means it's going to be true or false. So there's a lot of other different variable types, and you could even define your own in most languages. But the interesting thing about Python compared to some other languages, and one of the things that makes it slower, is that you can change the type of a variable. So when we defined our message variable, we didn't say anything about what type it was. And then later, if we want to change it from being a string type to being an int or integer type, or just a number, a whole number, Python has absolutely no issue with that. It totally lets me do it, no problem. Python is able to do that, no problem, because it's doing a lot of extra work for us on the back end to make that possible. Okay, let's go ahead and move on to C#, our next awesome programming language for beginners. C#. And I'm just clearing this terminal so we can get rid of all of that Python-y stuff and we can just think about C# now. So let's actually talk about stereotypes first. C# is stereotyped for being very verbose. I think when you compare this, what we're seeing on our screen, just our Hello World program here, which we have 14 lines of code here already. I guess we can get rid of this. 13 lines of code. Versus Hello World in Python, which is just 2, we can see that, yeah, maybe it's a little verbose. There's a lot going on here. To just do, again, really 2 main lines of code. We have to have a lot else on the screen. Sometimes people will call all the rest of this stuff on the screen boilerplate code. I don't really know where the term boilerplate comes from. Maybe someone in the chat, if you know, type it in the chat, I'd be interested. But it just means like extra code that we're making explicit. So a lot of the stuff that we've written out explicitly here is kind of happening behind the scenes in one way or another in other languages. But in languages like C#, we write it out, we make it totally explicit. So we as a developer can see exactly what's going on and sometimes maybe even tweak it if we'd like to. So if we're really trying to compare and contrast, though, these 2 languages, these 2 lines are the important thing. So again, we're defining a message, and this time we're explicitly saying it's a string, and then we're printing it out. So to run this, there's lots of ways to run C# and other .NET family languages. I'm going to run them on the command line just to be a little bit more similar to how we did it in Python. So what we're doing here, just type .NET run, and .NET is the family of languages that C# belongs to. And then we can see we ran it, hello world, awesome. So let's quickly talk a little bit about syntax. One contrast, as I said, is that Python is weird, cares about white space. Most of the languages, including C#, do not. So I can like do whatever I want. I can even put this all the way up here, right by my little curly braces. C# is going to have absolutely no issue with that. It'll run it no problem. I can have tabs, I can have spaces, I can have literally no tabs or spaces or any kind of white space in my whole program. C# is going to be fine with that. I can even put these on the same line because we're using those semicolons to separate lines. C# says A-okay. But I'm going to say not A-okay. That's really strange, and people don't like to see code like that. White space is there for a reason, to kind of like help us be sane. Cool. Okay, so one other quick note. I talked about typing. So C# is not as chill about typing as Python is. So we have kind of said that message is a string, and if I try to change message later to another type of variable, like an integer again, C# is going to tell me it can't implicitly do that. So it's going to give me an error by default unless I do some fancy stuff to try to fix that. So we're seeing this cannot convert type int to string, and that's because C# is convinced message is a string. So that strict typing, what we call that, is one of the things that can make it easier for C# to be really fast. Cool. So why would we use C#? So C# is a great all-around language. It's part of the .NET family of languages, so it's compatible with a lot of things. It's got better compatibility with other languages if you're trying to use it for a really big project. You have to write in multiple languages. It works well with Azure. It works well with the cloud if you're interested in that kind of development. It's also really popular for game programming or augmented reality or virtual reality programming. C# is used in Unity, and there's also some game engines that C# is used for too. I love C#. It's a language that I like writing in a lot. I actually like that it's verbose. I think it's a super awesome programming language. Cool. All right. Last up, JavaScript. So let's clear this again. JavaScript. So C#, what we were just looking at, fun fact, is actually similar to a language called Java. And another fun fact, the language Java is absolutely not really similar to JavaScript at all. So don't let that trip you up if you're ever talking about all these programming languages. So Python, C# or JavaScript, I think are all great beginner programming languages. They're awesome to get started with. I will admit, JavaScript is not my favorite of the bunch. It's just one that I haven't worked with as much, but JavaScript is really awesome. There's a lot of great reasons to use JavaScript, and the main one is it's extremely popular. It's everywhere. JavaScript really is the language of the web, and web development is like the most employable, maybe, programming type of job. It's just so popular. Everyone is doing web development. Web development is part of everything, and JavaScript is all over the place. There's tons of frameworks and libraries to use with it. So let's quickly just run this so we can see, again, we have just our 2 lines of code. It looks kind of similar to Python. I'm going to be running this with something called Node. Node is a runtime for JavaScript. There's a great YouTube course that just came out on YouTube. Maybe someone can drop the link in the chat, or I will later, to teach you all about JavaScript and then about Node. So I totally recommend that. Brand new, really awesome people worked on it. So JavaScript right here, just because it has 2 lines, it kind of looks a little bit more like Python, but in a lot of ways, JavaScript is actually more like C# if we're talking about syntax only. So we are supposed to use semicolons. We will use curly braces. So let's quickly conference true. So if we were going to write an if statement, we're going to use our curly braces again. And JavaScript does not care about our white space. So we could do something weird right here. Hello, viewers. So we could do something strange like that. JavaScript wouldn't care at all. Totally fine with it. So we kind of talked about why would we use JavaScript, language of the web, all over the place, a little bit of syntax. One stereotype about JavaScript is that it's quirky, I will say. It is odd. So one of those oddities, really, you can see right here, and the fact that I didn't put a semicolon. That's honestly just because I forgot. But JavaScript is a little odd compared to other languages because it's not going to care too much either way. By default, Node isn't giving us an error if we have that semicolon or if we don't have that semicolon. That's because JavaScript does some extra work behind the scenes. Like if you forgot a semicolon, it kind of tries to insert it when it's trying to run that code for you, which is nice, but it's always better to remember to put your semicolons in with JavaScript. Another quirky quirk with JavaScript is something called, what is it called? Type coercion. It's called type coercion. So I won't go too deep into what type coercion is, but I'll kind of just show you like an issue you might run into with type coercion. So right now I'm defining a new variable. So this variable was already of type string. I defined this variable of type string. But the interesting thing is these 2 types of strings are actually slightly different. One's a basic object, a basic string type, and one's like a fancier object string type. If you're really curious about what that means, happy to talk more about it in chat afterwards. But I just want to show you some of the implications. So if I want to check if those 2 strings are the same, I will, here, same. So I might check if they're the same like this using an if statement. And so I've checked, does this message equal this message? And it printed out same. So yes, it does equal the same thing. But if I do a quirky, weird JavaScript thing and add a third equal sign, it doesn't print out anything because now JavaScript does not say they are the same. And this is because of what I said, type coercion. So when we were just doing 2 equal signs, JavaScript was trying to do its best to make these 2 strings, these 2 objects, the same type before it compared them. With 3 equal signs, JavaScript didn't do any extra work to try to make the objects the same type before it checked what was in them, this actual hello world text. So just some funny JavaScript stuff. Okay, very last thing. we've shown 3 really great languages that are awesome for beginners. I just wanted to point out, it's great to learn programming languages because they can help get you a job, they can be really useful, but programming languages can also be really fun. So I wanted to show a really fun programming language called LOL code. Just in the couple seconds we have left. This is an example of a programming language that is not going to help you get a job. It was just written for people to have fun and written for people to have fun trying to make a program in. So this is the Hello World program in LOL code. Let's run it really quickly. So what we're doing, the 2 lines that are the same again, is this I has a message. So we're defining a message variable, ITZ it's. So it equals hi world and then visible. So printing it out. Yeah, there's other great examples of LOL code if you look on the internet. Happy to talk more about it in chat. Yeah, otherwise catch me in chat. Don't forget to check out those resources on Microsoft Learn. There's also learning paths for learning Python, C#. There's a learning path on learning Node, and there's those YouTube series, a bunch of them that people at Microsoft have made for learning these new programming languages. So get out there, give it a try. Don't get scared. Just keep learning. Thank you, everyone.
All right. Thank you, Shayna, for that amazing overview on these 3 languages. So for me, Python was new because Python, and I don't do data science and AI stuff.
Python, you can actually, like if you talk to Nina Zakarenko, you can do all sorts of amazing things with Python, including building entire web applications, which is pretty cool. So it's not just a data, it's for everybody. And I wish I would have started with Python. I actually started with a VB script a long time ago. Yeah, ASP3. And then my first ever programming language, actual object-oriented programming language, was Java.
Oh.
1.0.
My first one was C++, and to this day it's C++. And I am that person who's I don't need to reskill.
I don't like cleaning up after myself, Donna.
I know this about you, Seth.
Yeah, so...
speaking of nothing really, we haven't tweeted in like 5 minutes, so we should go to the Twitterverse and see what you're all saying to us. Hopefully you're harassing us a little bit, because otherwise we're going to have to harass each other.
I am refreshing my screen here.
Seth is refreshing.
Well, it looks like there's a lot of... Here's an important one.
Yes.
Jonathan Sinclair.
Yes. Hello, Jonathan Sinclair.
Needs us to help him decide which shirt he's going to wear for his session tomorrow.
I like the black clover.
Yeah.
Yeah. Jonathan Sinclair, black clover.
Yeah, so make sure y'all go let Jonathan know about that. Keep the tweets coming.
Yeah.
I'm looking here at the latest ones.
We saw something from Louise show up a little bit ago.
Let me scroll down. Oh, there she is.
There she is. Hi, Louise. I love your nails, as always.
Yeah, that looks like fun. Looks like a fun thing to do.
Exactly. Hello, world, 3 languages. So we love hearing from you. We're also following along on the Twitch and watching all your chats and such and such.
Here's my Inception. Like I'm on the Twitch now. Can we go to my screen? Look at this Inception-ness. Yeah.
Like.
Whoa! It's like incepting now. Let it incept. Oh! Inception.
That's weird, Seth. Stop doing it.
Oh, I gotta
stop doing it.
I gotta stop it.
Okay.
I gotta stop it. Okay.
Stop.
Okay.
Okay. So we thought the Python bit was so interesting that we need to have more of a deep dive. And we decided to call an expert, our friend Cecil, and he's going to tell us a lot more about Python, how to get into Python, how to write your first Python, and all of the detailed questions all of you are asking in the chat. So he's going to be joining us in about 2 minutes.
Is he queued up? Is he ready to go? Or do we need to ham it up a little bit more?
We can be hams. We can be hams all day.
Oh, no. He gave us a thumbs up that he's here, but we're still going to ham it up.
Oh, we're still going to be a ham while I'm working on this donut.
If we're a little extra weird today, we're gonna just lay it down. Donna and I had a show we had to cover until midnight last night.
Yeah.
Oh, we need to go.
He's like, shut up.
He's like, go to his screen.
1. Bye. Hi, Cecil.
Thank you so much, Seth and Donna. Hi, everyone. Thank you so much for joining me today for my session. Hope you all have been having a great time at Start Dev Change. My name is Cecil Phillip, and I'm a developer advocate at Microsoft. And what we're going to do in the next few minutes is talk about some computer science fundamentals. And we're going to kind of use the Python programming language to kind of help reinforce some of those things. So why don't we get started really quickly? And let's talk really quickly about what exactly we're going to cover in the next few minutes. Right? I definitely want to talk about
what is computer science, right? Because I think it's important for us to understand like what it is and what's the role that it kind of plays in our life and in our world. We're going to talk about what are computers good at. We're going to talk about what are algorithms, because I think those are some things that are very fundamental for really understanding like the whole concept of computer science. And then hopefully along the way we'll learn a little bit of Python too. Now I can tell you some things that we're not going to be able to do. Like I'm not going to be able to teach you computer science in 25 minutes. I'm also not going to be able to teach you Python in 25 minutes. But hopefully after watching this, you get a little bit of inspiration for you to go ahead and continue learning and trying some things out. So let's go ahead and get started. What exactly is the purpose of computer science? And more so importantly, like what do we really think is the purpose of computing in general? And I know some of you might have had some classes, or maybe you're thinking about going and starting some classes. And so you might have your own definitions of what that is. But I want to give you Cecil's definition of what computing is really about. And for me, it really comes down to a very fundamental concept, right? We want to be able to move information from one place to the other. We want to be able to store data, or we want to be able to retrieve data, right? And really, that's what we're talking about. If you think about like the devices that are in your pocket, if you think about some of the things that you do day to day with like your phones and our laptops and computers, it's really about sharing information, right? If I have an idea in my head, like how can I type it into like a Word document, and how can I share that Word document with you? If I'm doing some type of research and maybe some of my colleagues are different parts of the world, like how can I really share that information with all of these different types of people? And how can computers, how can these devices, and how could this really interesting piece of technology help me do that, right? And that's some of the things that for me is really at the core of really understanding the purpose of computer science. Now, within the industry, like there's tons of little bits and pieces and like different categories that we can kind of put this into. We think about like machine learning, or we think about tech. We think about security, or we think about databases, or we think about networking, right? All of them with their own respective like areas of focus and things that they're really concerned about. But in each of them, the core is, well, how do I protect that information? How do I share that information, right? How do I get it from one person to another person, right? And this is where we really rely on computers to help us do that. With computer science being the study of how we can efficiently use computers to help us achieve our goals. Now, I'm going to give you a secret, right? Computers are actually really dumb devices, right? And what do I mean by that? Like computers by themselves really don't do a lot of things, right? Computers are only useful when people are involved. And that's what I mean by that. Computers need people to function. They need people to tell them what to do. They need people to help them operate, right? They're good at a lot of different things. They're really powerful and they're really intelligent. But I think we need to always remember that computers are for people, that software is for people. Technology is really for the advancement and betterment of society, to help us share information better and to help us communicate and connect with each other in a better way. Now, I said computers are dumb. Don't get mad at me. But, there are a lot of good things that they're good at. Like, for instance, like they're really good at calculating and doing work really quickly, right? They're also really good at storing and retrieving information. They could do that much faster than us as human beings do. And they're also really good at communicating with each other. If we think about like the internet and what it is, right, and how easily like we can get information from, to and from our family members all across the world. How again researchers can store and share information with their colleagues that exist, regardless of whatever their geographic locations, right? Like they're able to do these things very efficiently and much better than we can, right? And so, with the combination of people, right? And this is gonna be a theme that I'm gonna talk about a lot, is the importance of people in computer science and in technology. With the addition of people and computers as, kind of like an extension to our brains and our thought patterns, we're able to really achieve some really amazing things. And now when we think about computing now we think about, well, how exactly do I talk to these things, right? And we talk to them using programming, right? Programming languages are, there's tons of different languages that folks can learn and they could try out and we could use. But, this is what we actually use to communicate with these machines, right? This is what we use to tell them, well, this is how I want you to do whatever this particular task is, right? And again, like I said before, there's tons of different languages with different benefits and different purposes and different contexts where they really excel at doing what they're doing. So with that being said, what I actually want to do is I want to dive over and I want to take a look at Visual Studio Code, and I want to show you how we could start programming, using a language called Python. Now, Python is a great language for you to learn, regardless of whether you're new in terms of getting into computer science and new into programming, or whether you're someone that's already been in the space for a really long time. The great thing about Python is that it doesn't take a lot to get started. And there's tons of support for doing things like, again, I can do machine learning and I can build web apps and I do tons of amazing things. Or if I really just want to do something really quick and simple, it can help me as well. So it's a language that kind of stretches out and it spans and it supports a lot of different type of learning styles, and it also supports a lot of different types of scenarios in terms of folks really trying to understand, well, how can I achieve this thing, or how can I do this thing? So what I'm going to do is I'm going to hop over to Visual Studio Code really quickly. And why don't we start writing a little bit of Python code, and we could start to see some of these computer science concepts and how we can apply them to this language. So the first thing I want to talk about is variables, right? And I'm going to start typing here really quickly. So I'm inside of Visual Studio Code right now, and let's start talking about variables and what variables are. Now, if you think about a package, right, or an envelope, or maybe you're ordering stuff online. I know this is a time a lot of folks are ordering stuff. Everything, we put things inside of like a box. And I can think about programming and I think about variables as like a box. Like I'm going to put something inside of this box, right? What might that thing be? So that might be something like, I don't know, let's just call it stuff, right? I'm going to put stuff inside of a box. Now, what I've just done is I've created a variable in Python called box, and I would just literally put some stuff in it, right? And that's how easy it is for you to get started, like writing Python and adding, creating a variable that has stuff. Now, if I want to peek and see what's inside of that box, if I want to see like what kind of stuff is actually in there, I can just simply print that out. So already we've seen how I can create a variable and I could put some stuff in it. And then now I can get some stuff out of it. And what I'll do is I'm going to hit this run button really quickly. And we'll see at the bottom here, notice it says stuff, right? Which is what I'm expecting it to do. Like I wanted to print out the stuff that's in the box. Okay, so you've seen how to create a variable, but what exactly is a variable, right? A variable essentially is just a container for us to put things inside of. And we think about it like, hey, I might have numbers or sentences, or I might have some information that I got from a database, or maybe even my document that I wanted to store somewhere, right? Like I can put it in something called a variable, right? And its job is to hold that information, right? Here I have a box. I'm going to put stuff inside the box, and now I'm going to be able to do different types of things with it, right? If you think about, for instance, if I want to create another variable, let's say I got to call this like number 1, right? And I'm going to put 1 in here, and I'm going to have number 2, and I'll put 2 in here as well, right? Now we can have these 2 variables, and I could start doing work with them, right? So when we start doing work with variables, we start to talk about things like operators. Like how can I carry out operations on these different numbers? So again, I could do something like num1 plus num2, right? And now this could be like the answer, and that's WER, right? But again, I've just created another container, all right? And the job of this container is to hold the results of this operation that I carried out, right? So I did some stuff with the first 2 numbers, and now I'm going to go ahead and I'm going to store it somewhere, right? I'm going to put it in the variable. So that's what we think about variables as, places where we can go ahead and we could store stuff in. Now, in addition to just being able to store one variable, I'm going to get rid of this here really quickly. I might want to store more than one thing, right? So again, imagine like we're placing an order, right? And I want to have a list of different things, right? I want to have more than one thing that I'm ordering. Like I might want to order, let's say I need flour, right? I need to go to the store and I need to get some flour. I need to get some eggs. Maybe I need to get some milk, right? Here's my list, right? Here's my list of things that I need to order, right? And now, again, instead of just worrying about, hey, I just have one variable with one value, now I have this order that has more than one value in it. And as you go on and you start reading about computer science and learning about it, you're going to hear the word data structures come along. And data structures being, what are these different constructs within programming that we could use to represent information in a different way? So for instance, like what I've created here on line 4 is a list. So inside of my list, I have 3 different things inside of it, right? I have flour, I have eggs, and I have milk, right? So those are the things that I need to get from my list. Now, what if I had another list, right? Let's think about this really quickly. Let's imagine that I'm home, and let's imagine if I'm home and I want to make a pie, right? Or I might want to make a cake or something like that. Like, how would I do that? Well, if I want to make a cake or a pie, then I'd need ingredients, right? So for my ingredients, I might have something like, let's say I want to make an apple pie. I'll have apples, right? I'll have sugar. What else I might need? Apple, sugar, whatever it is. We can have tons of different things that we could add to our ingredients, right? So now I have a variable for ingredients and I have a variable for order. Now, what I want to do is I want to place my order, and now I want to say, okay, now that I've ordered this stuff, well, I want to add, my order, the stuff that I've ordered to my ingredients. And hopefully this makes sense to you, right? So I have ingredients. And now I've went ahead and ordered some stuff. So now I have ingredients plus the stuff that I've ordered, right? And so this is what we talk about, again, like doing operations. What I've done is that I've taken some information that I've had, and I've gone ahead and I've added it to the other stuff, right? So now if I look inside of my ingredients should be more than just what I had before, which was just these 2 items, right? Now my list has gotten bigger because I've went ahead and I've added stuff to the list, right? Now I have flours, I have eggs, and I have milk inside of it, right? And so if I go ahead and I print this out, I'm going to go ahead and run this. You should see at the bottom, hopefully you could see this, right? It says now inside of my ingredients, I have apples, I have sugar, I have flour, I have eggs, and I have milk, right? And so really quickly, we've seen how we can create variables using things like, one just this one just holds a string of stuff, right? It just holds the name of something. And then this one actually holds a list of different things, right? So again, we've been able to add additional stuff to our list. So those are variables, right? Like variables are things that we could use to store stuff. Let's talk a little bit about functions, right? And why functions are important. Okay. Let's type functions really quickly. Functions, I'm sorry for the all caps. Now, functions are great when we actually want to let the computer know, hey, I want to go ahead and carry out a task, right? I want you to go ahead and do something for me, right? And of course, I can very easily like just type it out here if I wanted to, but maybe I want to be able to run a particular task or operation more than one time. And in that case, it might be good for me to create a function around it, right? So let's go ahead and create a function called recipe. So in Python, we create functions like this, right? I'll use the def keyword, and then I'll say recipe, right? I'll put a colon there at the end. And then now inside of, the indented area, right? Notice I had to come over a little bit. Now inside of here, I'm going to say, well, what are the steps that I actually want to do inside of this recipe, right? Like, how do I actually bake this pie, right? Like, how do I make this thing that I wanted to bake? Well, the first thing that we got to do is that we got to give the recipe the ingredients, right? Right now, our recipe knows nothing about our ingredients, so we have to give it ingredients. So what I'll do here is I'll type ingredients in here, okay? That means that whenever I'm going to run this function, or whenever I call this function, the function needs to have some information about those different ingredients that we ordered earlier. And now inside of my recipe, now I could start putting my cake together, right? So let's say I want to make like a pie, right? So if I want to make a pie, well, that means that, well, I need another variable, right? I need a variable to actually hold my result. And my result should be that pie. That's that thing that I want to make, right? And now inside of my pie, what I want to do is go over every item in that list one at a time. So first I want to look at the apples and sugar and eggs and so on and so forth. And I want to put them together, right? I want to put them together to make my pie. So how would we do that? So it turns out there's these thing called loops. right? And looping is a way that we could, again, iterate over different lists of things, or look one at a time over a collection of things and say, well, hey, let me look at this item, and let me look at that item, and let me look at the next item, and get that information out of there. So for instance, let's say I wanted to get all that stuff out of my ingredients. I could say for item in ingredients, right? And so this is how I'm going to go ahead and look through those different items that are inside of here. Items in ingredients, I want you to say pi is equal to pi plus item, right? And that makes sense, right? Because that's how we make a pie, right? Like we add all of these things together, right? And so I'm going to go ahead and I'm going to run this now. And what I'm expecting, well, whenever I run this operation, what it's going to do is going to say, okay, inside of my ingredients, inside of my recipe, I have all these items. I'm going to add them together, and I'm going to make a pie. Right? Now, if I go ahead and print this, now this will be at the end of the function. I'm going to go ahead and print this. And if I print the pie, what I'm expecting to happen is, well, I'm expecting for this thing to, well, let me know what's inside of my pie, right? So that makes sense. Now, I'm going to go ahead and run this. But notice when I run this, well, nothing happened. Well, where's my pie, right? Like we just got all these ingredients and we wrote this function. There's no pie here. Well, it turns out we actually have to run the function. We have to tell the computer to run it. Again, remember, like I told you before, like computers are dumb. They only do what we tell them to do. So even though we created these variables and we created this function, we actually haven't told it to run it yet. So we need to do that first. So what I'll do is I'll go ahead and I'll call recipe, right? That makes sense, right? And I'll run this. Oh, and it looks like I got an error. It says missing an argument ingredients. Well, okay, well, that makes sense again. Remember, computers are dumb. We have to tell them what to do. So even though I called recipe, it doesn't know what ingredients exactly I'm giving it, right? I actually have to take what we defined here on line 8, and I have to pass it into the function, right? I have to provide information to the function so it'll know how exactly to do what we did, what we need. So then I'm going to go ahead and type in ingredients here. Oops, not that one, right? I'm going to type in ingredients. And now if I run this, what I'm expecting to happen is, oh, we got like a really weird word there. I don't know, apple, sugar, flour, milk, eggs, something, right? Like it's all garbled together. Well, that doesn't look like a pie, But again, computers are dumb, right? Like we didn't actually tell it how to make a pie. We just told it, well, hey, you have all these ingredients. Like, go ahead and pop that stuff together. And well, all it did was it took those variables and it really just it just mushed them together in another variable. So probably what we want to do is something a little bit different, something a little bit more intuitive, right? So let's make a change really quickly inside of our code, right? So I'm going to go back inside of my Python function, and instead of just adding all my ingredients together, instead I'm going to do this. I'm going to print out some instructions. And what I'll do, I'll print it out and I'll say something like add item to mix, right? So again, I'm going to add all of my items to the mix. And all my items, again, being eggs and things of that nature. And then after I'm done looping, right? Remember, my loop is going to go through each of these things one at a time. After I'm done looping through all these things inside of the list, now I could print another statement. I'm going to say something like put mix into the oven. Right? I think that makes sense. Right? So let's go ahead and run this. And now this makes a little bit more sense, right? Like we think about what it takes for us to make a pie, right? I want to add apples to my mix. I want to add sugar, flour, eggs. I want to add milk. And then I want to put my mix into the oven, and then I want to bake it, right? Now, what we've done here, in addition to one, we saw how we could create a function, and two, we saw how we could, create loops. What we actually did was we created an algorithm, right? And an algorithm is very important, regardless of whether you're doing Python or .NET or Java or JavaScript or whatever programming language you're using. It's important to understand algorithms. And algorithms are the instructions or the methods that we use to let the computer know, well, hey, this is how I want you to do this thing, right? So if you think about it, well, they might be different ways of like looking through a phone book. They might be different ways of doing gardening. They might be different ways of, turning on and off the light bulb in your house. You know what I mean? And when we talk about algorithms, and particularly when we talk about algorithms in computer science, it's about finding what are some of the best, most efficient ways for us to really make the computer do what we want to do, as efficiently as possible. And so again, we used our yeah, we created using an algorithm to go ahead and create this. Now, I'm going to head back to my slides really quickly. Now, it's more important for us to think about not just how we can get the computer to do stuff, but it's also important for us to think about how it does it, right? If you remember what I said earlier, like computers are for people, right? And without people, then, the computers aren't really that useful. But then we can also think about, well, people kind of need people too, right? So, without other people, like what is software really for? And what is really the point of us like making and building all of these things? I can give you an example. Imagine that you're building a house and it's like an amazing house and it has all these bathrooms and bedrooms and it has tons of great stuff in it. And you invite your friends over and your friend comes to your house and your friend is unable to come through the door of your house. And I mean, they feel really bad. Now they want to spend time with you. Now they want to come inside. But the thing is, you built this house, but you didn't think about some other people. You only really thought about yourself at that moment. When we start thinking about other people, the importance of thinking about these algorithms is us really understanding, well, how could we, how does this best serve everybody? How can I make a door that my friends could come into regardless of the shape of their body or how tall they are or how short they are? You know what I mean? We think about a lot of machine algorithms that may favor people that, look or speak or behave a certain type of way. Well, we need to really take the time and think about, well, how can this support and benefit everyone? And so this is where I have the term empathetic algorithms, right? And these are some of the things that as you become a computer scientist and as you start digging into the world, like these are some of the things that you could really need to think about. One of the things that a lot of folks always ask is, how can I become a better tech person? Like, how can I become better? And, just like I spoke about before with the empathetic algorithms, we really need to care about what we're doing. You need to have the passion for whatever you're doing. Because when you have a passion for something, when you care about something, that's when you're really going to put the time and effort into doing it, right? So for instance, I try to use an example where, hey, I know a lot of folks are ordering stuff. How can I make ordering more efficient? I know a lot of folks are home and you might be baking and cooking stuff. How can I share recipes with everyone more efficiently? How can I take what I've learned in my life and have computer science apply to that and help it make me and my life and my family's life a lot better, right? And these are some of the things that folks really need to think about as they go on. So I do have some homework for y'all. I know that was super quick and we kind of rushed through it, but here's what I want you to do. I want you, as you're going through your journey and you're understanding this world of technology and computer science, really think about how does computer science affect the lives of everyone that's around me? How can I use technology to make our lives better? And what are the things that I really care about and I'm really passionate about to really help push this thing completely forward? Now, thank you all so much. I really appreciate y'all joining me. I got to go now because I know there's some other great speakers that are here to talk to you all. But Seth and Don, I'll kick it back to you, and I hope everyone has a great time and enjoy the rest of the conference.
Well, that was fantastic. I had a good time learning Python with Cecil. Someone in the Twitchers, is that how you say it?
No.
Someone in the Twitchers said we should clone Cecil so he can teach every computer science 101 class in the universe.
I like that.
Yeah, I feel like we can do
Yeah,
that.
can Python do that? Cecil, can Python do that?
Can
Hopefully.
Python clone him?
Yeah, can Python clone you? I don't know anything about Python other than white spaces matter. Forget this language.
No, it actually is kind of cool. I mean, there was also some comments about, there's other languages to do scientific stuff. Absolutely. My particular suggestion to everyone is use what makes you happy.
Yeah.
And solves the problem, right? But in that order. Use what makes you happy and solves a problem. You know what I'm saying?
Yeah. No, I know what you're saying. I also like Cecil's homework a lot, which is think about the world around you, identify a problem that you're facing either in your life, your home, your work, and figure out how to build a tech solution to solve that problem. Learn the language you need to learn to solve the problem. So if it's a website, don't learn C++, like I tried to. So don't do that.
You try to do C++ on a website?
Of course I did. I'm like, C++ solves everything. It doesn't.
Earlier I said I don't like cleaning up after myself. It's because, and the reason why it's a funny joke, and I was like, oh, maybe I should explain that joke. It turns out that programs basically are not super smart. They basically allocate memory in, and then those little boxes that Cecil was stuffing stuff into basically stores it. In certain languages, like once you store a variable there, it will automatically take care of removing the memory, so it's free. You don't run out of memory. Programs like programming language like C++, you have to allocate the memory and deallocate it.
Yep.
So basically, it's like you have to clean up after yourself. And so when I'm saying, hey, Donna, I would like C++, but I don't like cleaning up after myself, that's the joke. Is it still funny if I explain it?
It was not funny the first time also.
No, I think it's funnier now that I explained it. I mean, let me see.
Are silent.
Let's see what the Twitch
The
folks
Twitters
say.
are silent. They're like, no.
Yeah,
No.
I got an LMAO. I think that's laughing my
You can't say it out
took
loud.
us off.
Wow.
LMTO is what I'm going for. Thanks for that, Seth. Someone was excited that I explained it to me. That I explained it to them.
Your programming joke. Okay, so let's take to the Twitterverse because we've been getting some tweets from you.
All right, so let's go over to the tweets here.
See what we got. Start dev change. Azure. Hi, Azure. So by the way, Azure, that is her real name.
What?
Yes.
Does
Azure
she work
McFarlane.
with us?
No, she doesn't.
What?
But she is an amazing Power Automate expert. Hi, Azure. And she got voluntold into this, of course. And she's going to be doing a killer session on Power Automate, which is business process writing with like low code tomorrow. So tune in to see Azure session. She is very funny, and you will really, really like.
We will literally be selling Azure tomorrow.
A little bit, but she said you should be nice to computers because
That's true. She said,
movies.
my mom says please and thank you when asking Google questions to be on their good side.
Yep. So what else we got?
All right, so let me scroll down here.
So Logesh is diving into the Twitch. Hi, Logesh.
Look at this one.
Thank you.
Tuning into Start Dev Change, listening to Cecil Phillip talk Python. I'll be hanging out in the Twitch chat, so come say hi. Let's just do that right now.
Okay.
Hi, Kim.
Hi, Kim.
Hi, Kim.
Hi, Kim.
Boom.
It's
Hello.
us. It's
Very
us.
nice. Oh, Twitchception. Can't do that.
Don't do Twitchception again.
Here's another one from Mari. Turned into Cecil Phillips' talk on computer science. I love how he's breaking down computer science concepts into simple terms. Computer science doesn't have to be scary.
No. How many of you, and here's a question that we would love to hear an answer from on Twitch or Twitter. How many of you have ever taken a programming or computer science class or boot camp or any sort of thing and walked away feeling stupid because it just was not taught very well?
Basically, all of grad school for me was me feeling stupid for 4 years.
That's fair.
Yeah, and I remember sitting in class, I'm like, are they trying, if you, no joke, if you read like an academic paper, there's actual strategies on how to read them to understand them. And I'm like, shouldn't
You just read them?
the author of the paper like use strategies to help us understand them? And if you ever run into like, and I'm guilty of this too. So if you ever run into someone that's usually using overtly like flowery terms that seem a little esoteric, sometimes it's just that we feel like maybe we need to overcompensate for not knowing. Look, I lived in Spain for 2 years, and this dude I sat with him, smartest guy I ever met. He's like, Seth, it turns out that knowledge is like a piece of paper. The more you know, the more edges there are of learning. And so the smarter you get, the dumber you realize you are.
I agree with this.
Yeah.
Because you realize how much you don't know.
Yeah.
Like when you're young, you think you're very smart because you don't know what you don't know, which is a lot. There's so much to know.
I know.
But anyway, we'd love to hear the answer to this question because I failed my first computer science class. I roll up into first year of college, CS class, never coded in my life. And the professor's like, okay, we're going to learn bits and gates and binary language first, assembly language second, C++ third.
Whoa.
Let's start. So we started with binary, University of Michigan, Go Blue, very serious about their programming languages. So my first language was binary for a semester. You can
What?
imagine how badly I failed that, so badly. But 60% of people failed it, and it's called a weeder because it weeds people out of the degree if you don't want to be there. But I didn't think that was a very kind way to welcome people to computer science.
Why are you going to weed people out?
Now we're like, weed people in, join the industry. Okay, by the way, we'll keep talking. And in fact, Chris Noring is queued up next. He's going to teach us all about a topic Seth was interested in, Node.js. So stay tuned for Chris, if he's here. Otherwise, you get us somewhere. Oh, there he is. Hi.
Thank you, Seth and Donna. Hello, everybody. My name is Chris Noring. I'm a cloud advocate with Microsoft. You can find me on Twitter at Chris_Noring. We're here today to talk about Node.js. What is Node.js and how could I be using Visual Studio Code with it? Well, let's find out. So first off, what is Node? I mean, it's JavaScript, right? It's JavaScript on the backend. So Node is an open source server environment. It runs on all the platforms you might possibly have, such as Windows, Linux, Unix, Mac, you know the drill. So Node.js uses JavaScript on the server, and that's important to emphasize, JavaScript. I'm about to show you a lot of code examples, so you'll know by the end of this presentation how you could get started and how you could actually learn to test your applications, because you do test, am I right? No? All right. One of the first things you want to encounter or play with as you start with Node is something called a REPL. Now, a REPL stands for read, eval, print, loop, and it's essentially a built-in piece of software that allows you to evaluate different statements that you type. So you know what's going to work and what's not going to work. But hey, don't I need an editor for that? Well, you can use the REPL instead while you build out your knowledge when you're super young and super fresh using Node. Here's what it looks like. By just typing Node in your terminal, it starts the REPL. First thing is that the REPL is going to tell you, hey, I'm this and this version of Node. This may vary depending on your computer. Once you do that, you get this prompt and you can start typing different statements such as 1 + 1, and you can see that evaluates to 2. Makes sense. It's not lying about arithmetic, am I right? Another thing you can do is to actually define a variable, and then you can echo that variable out and make sure that it's been correctly assigned just as you planned it. One thing that I use a REPL for is actually regex, or regular expressions. Those are really, really handy. You might have used those in other code languages or platforms other than Node, but essentially regular expressions allows you to pattern match different things, and it's super good if you try to parse through a text file and yank out that piece of data, or just switch this for that. So here I'm typing one of these patterns, and I'm able to say like, hey, if I type AABB, does that match anything in the alphabet? And the answer is true. So this is probably my first use case. So even though I'm a pretty advanced Node user, I actually start a REPL on occasion. This is not just for beginners. So use the REPL if you just want this quick test and you don't want to fire up a full Node application. Right. So let's say I'm not using this REPL. Let's say I'm actually a developer who wants to start using Node. How do I start? Well, a good place to start is by creating a file. Here we've named it hello.js. And we type some code here on the right saying console log hello world. That's as simple hello world as it can get in Node. Next part is that I want to start this application because I have created an application at this point. I mean, maybe you've tried, I don't know, Python or Java or any such language, and you think like, hey, no hello world is that simple. I always had these using statements and these other things. Node is super simple. Look here in the bottom, you see the terminal. The only thing I do is to call this executable node, but instead of just node with nothing, like I did with the REPL, I have to give it the hello.js as the argument. So that means node is treating hello.js as an entry point to our application. And when it runs hello.js, it outputs hello world just as our console log statement is saying. So that's as simple as it gets. This is how you start. This is how you keep on building your knowledge. Okay, so what can I actually do with Node? How much can it do for me? Well, Node is a complete system, right? So imagine that you have an experience working maybe with .NET or Java or any such things. You're used to having a set of core libraries. And it's the same thing with Node. Node allows you to work with input and output, allows you to work with path. It has a set of utility functions. You can do assertions. You can work with processes if you have those. And of course, you can encrypt and decrypt different statements or maybe passwords. And you can work with HTTP. And I will show you more about HTTP as we go on in this presentation. And one other very important primitive is that of streams. This might not be the first topic that you encounter when you work on Node, but knowing that you can work with streaming pieces of data, ones and zeros that come in a continuous stream is a very powerful thing. So people build big things using Node.js. It's not just a toy language. It's a big framework, and it's definitely a really good option for your backend. There are tons more APIs here at the bottom right. You can go to actually nodejs.org/API, and you can see the full list of all the APIs, all the capabilities of Node. Okay, so you started with an application. You want to move on pretty soon from an application to a project. So a project consists of several files, and not only several files, but it has some kind of file, some manifest file that keeps track on all of those files and tell you how they fit together. And once you have this project up and running, you can do more things, such as adding external packages that has their own capabilities. So you can easily extend your Node application, and with very few lines of code, you can have a web server up and running, or a command line application, or what have you. Okay, I said project. Okay, in my mind right now, I'm seeing hello.js. How do I take that and for it to become a project? Well, we need this manifest file, as I said. This manifest file is called the package.json, and there's also another manifest file called package.lock.json. Those are the two files that are kind of added to your project and makes your application turn into a project. And inside of those files, it has meta information on the project, such as the name, description, keyword, maybe what GitHub repo it is persisted in, but it also tells you what packages that your application needs to run. Let's have a closer look. So this is how you would be scaffolding your Node.js project. You would type npm init -y, or you type npm init with no flags. So npm init -y is a way of doing this initialization process really fast. What it will do is to answer the default answer of all the questions that comes up in a wizard. This is the way I start, because I usually don't want to go through a long wizard and answer this and that question when I don't have the answer. So I just say, hey, give me this package.json file. I type the -y flag, and suddenly I got a few things. So below here, I've just echoed out the content of the package.json that it generates for me, and it tells me things such as the name. It takes that from the directory it's in. It gives me a standard version. It gives me an empty description. I need to fill that in at some point. And it tells me what the entry point of my project is. For now, it's hello.js. That's all we have, but we can change that at a later occasion. And then there's the scripts tag, and in there it has a command called test that does nothing. We need to change that at some point as well. And it also has keywords, author, and license. License is a thing you can be changing as you go along as well. A very popular type of license is, for example, MIT, if you want people to freely use your library, if what you're building is something that you want to share. Now, so as I said, meta information, scripts, and keywords, author, license. Now, npm are two different things. npm is the command line tool that comes bundled with your Node.js application, and it allows you to add packages from a global registry, and that one is called the npm registry as well. So two things: command line tool for managing your dependencies, and also a package registry at npm.js. And this makes Node super powerful, that all of these packages exist that other people have written, so you don't have to. Now, you would add a package by typing npm install and the name of the package. And then it goes to that registry, that global registry, and say, hey, do I have a package like this? If it does, it's going to download those files and place those into a node modules directory. So at this point, you've actually gained the capability, but before you start using it, you actually need to require in that dependency so that you're able to use it in your code. There are two types of dependencies. One is the dependency that you need for production. So when you build your app, you might need a web framework for it to run, but some libraries you might only need during development, such as testing frameworks. I mean, you don't want to ship a testing framework with your application, but you definitely need it if you're going to author tests as you build out your app. So npm install Jest, for example. Jest is a testing library. -- save dev, that will ensure that what you download ends up in dev dependencies. Were you to type npm install without that flag, it would end up in a dependencies property instead. So just remember here, there are two types of dependencies, for production and for development time. Okay, test. I mentioned test over and over again because tests are a very real part of what you do, regardless of whether you're building something in .NET or Python or Java or Node. You need to have a test framework because you can't really prove that your code works before you have that. Good news for Node is that there are a lot of test frameworks and test runners that will help you make this work super easy. So the first thing I do is to configure this script section here. So I say, hey, I want to run Jest when I type test, and I also want to run or define this command called test watch that will run Jest in a mode so that it sits and listens for changes from me. So when I would be using Jest watch all, it would actually run all the tests and it would wait for me to edit the file and hit save. At that point, it says, oh, I need to run again. So that's the difference between these two commands. Here at the terminal, you see how when I run npm test, it's actually going to execute this Jest action, and it will start looking for files that matches a certain type of pattern. Now, how do I actually get started with writing tests? Well, Jest is quite forgiving when it comes to what I name things. So one good pattern that you could be using is actually to have this __ tests directory as a subdirectory to your application. So here you can see at the top level of my project that I have hello.js, which is my application file. And as a subdirectory, I have this tests subdirectory, and under it, I have a file called hello.js. Now, if we're looking at hello.js here at the top right, I see that I have defined something called the suite. I see that because I'm using the describe keyword. And inside of that suite, that group of tests, I have one test defined. And inside of that test, I have an assertion made. So I start out here with saying, hey, I have a group of tests. Then I define a number of tests within there. And for each test, I need to define some kind of assertion in which I say A needs to match B. If it does, then the test passes. If it doesn't, it fails. As you can see here at the top right, it will fail because I expect 1 to be 2. And well, we can see that that's not going to work. Running this, we see that we get a failure here on the bottom right, and it's telling me exactly what I need to hear, which is you need to adjust your code so your test passes. Okay, so how do we fix that? Well, we go into our test and we actually change that expectation to be 2 to be 2. And suddenly I run my tests again and it passes. That's how it works. And I could be running the secondary action. I mean, so far I've been running npm test, right? But and one thing to know is that there are certain actions in Node.js where I don't need the run command. I can actually omit that. So I could either start my test task with npm run test, or I can omit the run and just say npm test. Here I'm testing my secondary test action in which I want Jest to become in this listening mode, right? So once I call npm run test watch, it runs Jest with a flag, and it sits there and waits for me to change the code. And once I hit save, it reruns it, and that could be quite powerful. You want to improve upon this test experience as much as you can, even though Jest is quite good and your terminal looks quite nice, you want to make it better. As part of VS Code, you can extend it with extensions and make your VS Code environment as good as you want it to be and to fit all of your needs. One extension I highly recommend is the Jest Runner. Have a look at that. Almost 90,000 people give it a thumbs up and say this is good stuff. You should be downloading that as well. So what does it give me? It gives me the ability to actually right-click on a test in Suite inside of my editor, and I can actually see a specific test run. So that's all great, right? So instead of just controlling the behavior here via the terminal, when Jest runs, I can actually do all of that from my coding environment, and I don't have to go to a terminal. So it's quite good. We're going to skip that video. If you want that, I'm sure we can distribute this slide deck after the fact. Okay, so let's move on. We know that we have a testing framework. What do we want to do next? Well, we want to learn how we can build a web app as easily as possible. With Node, there are many libraries that covers each and every single use case you might possibly have, regardless of whether you're trying to build terminal applications or you're trying to build web apps or APIs or anything like that. There's so many options. One very popular option for building web frameworks or APIs is Express. So what you do is that you hit npm install Express. At that point, it has downloaded the Express framework to our machine. Next thing you do to actually use Express is to type require Express. So once we've done that, we have access to the Express code, and we can just call it as we do here on the second line. And what we get in return is an application instance. Thirdly, on line 3, we can set a port. Once we've set a port, we can start defining our routes on line 5. So on line 5, we're saying app.get to a default, and we can just simply say, if this route is being hit, we're gonna return back some kind of text. All good, right? So require to get Express, call Express itself to get an app instance, define a port, define our routes, and finally, we start to call app listen. And this is a very simple API, but you can build this out with different HTTP verbs as you see fit. So what does a more advanced example look like? Well, you can keep on adding routes here. If you're looking at this web application here, you see that one of the first things we do is to call require body parser. What we do at that point is to instruct Express to handle any posts coming its way that is of type JSON. So what we're saying is to Express is that if someone posts a JSON, make sure you listen to that full message, pick it down, turn that into something that I can use within my application. And my line 4 there is saying let products. And this is a products array containing a bunch of products because we are creating an in-memory database. Now, looking at app post, we see that we define a /products route, and we can also see that we have this rec body. And this is a request object that is being sent to us as soon as someone tries to post towards our API. What we do at that point is to try to dig out a name property, and we create this new product, and we can put new product inside of our array. So it suddenly contains all of those items plus this new item. And the very last thing we do is to call rest.json. We instruct a response object to return this new product that we just created. And then we see that we have app.get /products, and we can see that we are returning the entire products list. And the app.get products /ID. This is an interesting one because it's using something called a wildcard. Now, a wildcard is simply a parameter that we don't know what it is before you tell us. So products /ID would match any kind of thing that I would type after product /. So if someone were to type /product/1 or /product/100, it would match this route. And looking at the implementation, we can see that it goes to products find and try to find that particular product item that matches this ID that we are sending in. And we have the app.get that returns hello world. We had that since before. And app.listen is the one that starts up our app. So we can see that we quite easily can build an API in almost no lines of code. Very impressive. Going to skip that one. So far, I've shown you how to do testing with Jest, but you might not see how you can transfer that knowledge of using Jest to a web app, because it's different, right? It's not just sending in a 1 and a 2 and it does a calculation. This is actually on the web and it uses a port. And how do I even do that? Well, the solution again is NPM. There is a framework for everything, right? So you definitely want to be testing get/products. You want to test get products/1, and you want to test post. Now we're actually going to jump to VS Code, and I'm going to show you how we did this, and because I've already prepared this bit. So in here, we have the app.js, and I've used something called supertest. So supertest is something that you can definitely require, or you can type npm install supertest, and supertest is a framework that is capable of testing a web application. So what do? We require in supertest, but we also need to require in our app that is situated 2 levels up. So our app is simply our web app, this one. And what we need to do inside of our test is simply to say, hey, I expect I have some kind of app. And the thing we need to do is to send in the app inside of supertest. And now supertest knows all about our application, what port it runs to, and so on. And by doing so, I get this request as a response. And once I do that, I can start defining my tests. So at this point, I use this request to actually try to go towards my API and do /products. And then I get some kind of asynchronous response back. Note how I use async and await. And I can just check, did I actually get a 200 status? Do I get a body back that consists of products? And here we have another test in which we are sending in /product/1, and it's pretty much the same MO. But I'm testing it towards one product because I am filtering, so I only get one product back as a response. And lastly, here I have this post test. So here I have my request. I post my request to /products, and I'm giving it a payload, a product. So I send in this product. I check its return status is 200, and also that the body it gives me back is an actual product that it has created. And the last thing I want to do is actually to try to do a new query, because this time around, I expect my products list to contain one more item. Remember, I've actually called this post route that should be creating things. So instead of just getting 2 items back, I expect 3 items to come back, and then I assert on that as well. And that's as simple as you would actually write these tests. So as you can see, the level of complexity, whether I'm testing that 1 + 1 = 2, or I'm testing a web request, it doesn't become so hard because NPM is really helping us, and in particular, the supertest library. I mean, these tests are pretty easy to author. I wouldn't say they're easy. Easy is not a good word, but I think you get my drift. It doesn't get more complicated than that of a single function that would do a computation. Right. So in summary, I have talked about what Node is. Node is JavaScript on the backend. I've also said that if you don't want to run a full Node function, you could be running something called a Node REPL by just typing Node in the terminal. And it can help you evaluate different expressions, such as a regular expression that could help you with pattern matching. I've also talked about how we go from being a Node application to a Node project. We do that by calling the npm init, and we can call npm init with a -y flag for having all the defaults filled in, or if we don't type the -y flag, it will prompt us with a long wizard, and we can type in the name of the project, the different commands, and so on. So npm is both a CLI, a command line application, but it's also a package manager that resides on the web that contains a lot of packages that you definitely want to be using. You can extend your application with packages. Jest is a good recommendation for a test library that you can use to run tests. And there are some great extensions to Jest as well, as I showed you, that you can use to make your Jest testing experience even easier if you don't want to use the terminal and just right-click in your coding environment. Web apps can be built with a ton of different frameworks, such as Express, Koa, and a lot of other ones, Nest.js being one. Supertest is the library that I showed you that you can easily test your web apps with. So Jest and Supertest, those are two really good libraries in combination with one another. And that was all, folks. So over to you, Seth and Donna, and take it away. And thank you very much for listening.
Back. So that was a lot. We're following you in the chat, and you're saying, yeah, that was a lot of concepts. And was that beginners? And here's the thing, where nothing is ever beginner, or everything can be considered beginner, right? I learned Node.js recently, maybe for build. Actually, it was for build. So in May, and it took me a few tries to figure out what is NPM, how do you set up the server thing, how do you send requests, how do you do tests, how do you make sure that your environment is up and running with basic tests before you start writing code against it. So don't worry if you didn't catch all of that on a first try. Chris has been doing this for a very long time, and he explains it in a way that he understands and the way he resonates. So what we highly recommend is you rewatch this, pause, go try it, pause, go try it, pause. That's how I do it. And just so you know, all of the recordings, all of these videos, they're all recorded. They're all going to be live on the Microsoft Developer YouTube channel. And I think we've posted a bunch of stuff in the Twitch, like where else you can get it on Learn TV and all of these things. So rewatch them. Take your time. It's kind of hard to pay attention to code while following a Twitch and just doing it all in 25 minutes. So don't worry about it if you're getting lost. The whole point is for you to understand that these are things that exist in the world. You don't need to learn all of them right now. It's to give you pointers to find them later. What do you think?
Yeah, so like I said, doing stuff in modern JavaScript terrifies me. The first time I did a JavaScript thing, no joke, it was my very first website. It was on this thing called GeoCities, which was a free, like you could make your website. And my first JavaScript was an image rollover. And back then it was simple.
Yeah.
It was super simple, right? But then now there's things like TypeScript, there's like things bundlers, there's things that minify stuff, there's like hot swappable reloady things, there's like a flux capacitor. I'm making stuff up now.
He's just making
there's
stuff
like
up.
7 DeLoreans in there, and sometimes I have a hard time. But there have been times where I've had to do stuff in JavaScript, like either write an Azure function or write a front end something.
Yeah.
And there's always like parts of it that is happening that I'm not altogether sure what's going on.
Yeah.
But it still works, right?
Yeah.
And I'm okay with that. Hanselman's talk at the beginning, Scott's, was very good. What level of abstraction do you want to live at?
Right.
And in this particular talk, there's a ton of amazing things. I caught a couple of things, and I'm like, hey, this is awesome. But if you don't catch everything, that's okay too. I mean,
It's totally fine. Often when you watch the same talk again after you've been working in this space for maybe like a month or two, you realize, oh, now I get that second layer of abstraction. I know what he's talking about, and I know why he's doing that thing. At the beginning, you're kind of just emulating, following along, doing what he did. This next level, you start to understand why he did it. And the third step, you start making your own variations to things and saying, I'm just going to change this code to do totally different things because I now understand the why.
It's like when I was watching Star Trek and finally understood why Captain Picard was so awesome, and how the Jedi integrated in the whole Star Trek fandom. I'm not doing this right, am I?
No, I don't think. I don't know, but something about Star Trek or fandom.
Yeah.
So one of you can school me and Seth, because Seth and I don't know anything about Star Trek Wars.
I will. No, actually, I walk in the morning, and I started watching the Star Trek The Next Generations because they're like exactly 45 minutes, and it makes it so I can walk like 3 miles. So I'm sitting there
Do you
watching.
walk like that?
Yes, of course. So like I didn't get to because I had to get here early today, so I'm just gonna like fake walk 3 miles here at the desk. So someone else mentioned that it's not called the Twitchers. I was old man saying it on purpose. What is the actual term for the people in the Twitch chat?
Yes.
Is
all of you in the chat.
Is it people?
Twitchers?
Okay, well, hold on, wait.
We'll find out.
The Twitch chat. So collectively, y'all are just the Twitch
But
chat.
the individual people. Say we want to call out to you. Hey, people in the Twitch chat. What do we call that?
Twitchionians.
Twitchionians? Like Twitterverse, we say Twitterverse.
Twitch
Hello,
chat.
Twitterverse.
Viewer.
Viewers?
Like, that
viewers?
probably is the smart.
Viewers.
Yeah, he full on went. It's just viewers, Seth.
Yeah, just viewers.
Awesome. Hey, chat. It's just called chat. It's either chat or viewers. Twitchers. Someone says I could still use my old man term
You
for
can
it.
use your old man term. See.
Delegates in a formal voice.
Delegates.
Hello, fellow delegates. Welcome. Oh, is it time to wrap up? He's telling us to be
please
quiet.
Shut up. So, by the way, all right, we're now going to our friend Laurent, and he is going to teach us all about introduction to cloud computing. You know this thing where there's all the jobs and everyone's always looking for talent? That. So, over to you, Laurent.
Hey everyone, hey Seth, hey Donna, how are you doing? It's so nice to see you even from so far. Don't you, everyone, love when Seth is trying to be cool? I love when Seth is trying to be cool, and especially when Seth is failing. It's so nice. All right, so we are going to talk about cloud today, and this is a hello cloud computing world, and it's kind of a play of words on the hello world, which is like you saw earlier on in Chana's presentation, when you saw how you start coding in different languages. And of course, once you start coding in different languages, then you also want to have an environment in which you want to put this code. And this is where the cloud computing can be a good solution. Of course, you're all going to start by running your code on your local machine. And then in many cases, you're going to put your code in a server, which is often running in the same enterprise or in the same location than you are. And this is what we call on-premises when we try to use, some lingo to make us feel smart. So on-premises, is something that is very frequent, but now more and more people are using something which we call the public cloud. And Microsoft Azure is one of the public cloud providers. So welcome in my living room. My name is Laurent Bugnon. I'm a cloud advocate. And I'm going to show you a few things about Azure. And then we are going to do quite a long demo, a little bit of code. So first of all, why is Azure interesting to put your code? For multiple reasons. There are really a lot of places where you can put your code. And that can be really interesting when you want to put, for example, a website as close from your users as possible, because you want to try to avoid having a long response time. Okay, we call that the latency in our lingo. And again, I apologize for that, but you're going to hear quite a lot of new words in this presentation. I'm going to try to define them as we go. So latency is really literally the time that it takes to respond to a request, and it's going to take some time. And even if you have no obstacle at all on the line, you're still going to go at the very least at the speed of light, okay? And even at Microsoft, we didn't find a way to go faster than the speed of light. We tried and we failed. Maybe we shouldn't have asked Seth to do that. Anyway, so speed of light is always a given. So just by moving your application and your data and everything closer to your users, then you're going to reduce this latency. And this is why it's interesting to have many regions, but also because like this, you can have, like, for example, I'm based in Zurich right now. As you can see, it's quite dark around me. It's, I don't know, 7:30 p.m. here. So, even in Switzerland, we have two regions. We have one in Zurich and one in Geneva. And that allows me to have safety because I'm going to put my data, for example, in the Zurich region, but I'm going to put a backup in Geneva. And then like this, if something happens in Zurich, which I really hope not because this is where I live, but maybe a meteorite, strikes, or there is a thunderstorm or whatever, and the data center goes black, then it's going to automatically fall back to the Geneva region, which is why it's important to have multiple redundancies if you want. And you may ask, why do you want to have a region in Geneva? Why not just put it in Germany, for example? Well, because sometimes you can't. There is some data which has to stay on, regional soil, local soil, national soil. And this is why it's important that we have those regions like that. So here you can see that we have, I remember in the days we were trying to say exactly how many regions we have. We totally stopped doing that because it goes so fast and it grows all the time. So we have 60 plus regions, okay? And if you go into a data center, an Azure data center, it may look like that. Actually, it may probably not look like that because here you have someone who is walking, and very often those data centers are just completely empty. Very much of the operation is automated. And this brings you security, because if you don't have anyone on the floor, the risk that somebody unauthorized enters is even lower, okay? So you have higher security. not just from a software standpoint, but also really from a hardware standpoint, where we avoid that people are going to go and steal, hardware. And I gathered a few numbers because I thought it was interesting, but we calculate that using Microsoft Azure can be very efficient from an energy standpoint. And in fact, we talk about 98% more carbon efficient than an on-premise data center. And why is that so? It's because Microsoft is really committed to compensate quite a lot of this carbon. You know that data centers are using a lot of electricity. That's true, but we also invest a lot of money into building renewable energy plants, for example, with wind or with solar or with all kinds of things. And this allows us to have really also a carbon bill at the end, which is good. And there are a few things. Microsoft has been carbon neutral since 2012. We are committed to be carbon negative by 2030. And in fact, we have also a commitment to remove the carbon that we have emitted in the atmosphere since 1975 by 2050. So there are really quite a lot of engagement there. In fact, one thing which was really interesting, I don't know if you saw that, but we even tested putting some data centers underwater. And one thing which is interesting here is that if you put your data center underwater, it's going to take less land. And as you know, land can be a problem, all right? In Switzerland, we have a lot of mountains where we cannot really put infrastructure there, so that can be tricky. So I thought it was interesting to mention that this data center, you see that there is a lot of algae and all kinds of like shells growing on it. It's been 2 years underwater. So if you're interested, check the news. There is a lot of things here. Now, somebody in the chat earlier on mentioned acronyms, and yeah, oh God, do we love acronyms, And unfortunately, we have a lot of acronyms in the cloud. So we have things like IaaS and PaaS and SaaS and FaaS and what? Well, I even use here. I wanted to use a 3-letter acronym which starts with W and ends with TF, but I didn't because it's recorded, so I didn't do that. Hey, ma'am, you see, I didn't swear. So IaaS is really something we call infrastructure as a service. And this AAS is always as a service, all right? And later I'm going to have a coffee as a service, hopefully. So IaaS, infrastructure as a service, is something we have in the cloud. It's really virtual machines, essentially. Virtual machines is something that you may have used already before. Okay, you have a computer somewhere, and then you have another computer which you use to log into that computer using, for example, a remote desktop client. And, virtual machines are really an easy way to put things in the cloud because just like you would put an application on a desktop computer, which is in your office, you can do the same in the cloud. It's exactly the same. So a lot of people use that as a first step to the cloud. But one issue that you have here is that it also means that you have a lot of responsibilities. You're going to have to take care not of the hardware, that's Microsoft's job, but you're going to take care of the operating system, for example, of patching it for security, of putting an antivirus on it, of taking care of the networking, like securing your network with firewalls, etc., taking care of the disk. And this is why we often encourage people to move to the next step, which would be PaaS, platform as a service. Things like a web application, for example, where literally we give you the platform, it's a web server, but you don't have to worry about what is around it, like the operating system. You're going to select, okay, I want Windows or Linux, because we support Windows or Linux on what we call app service, which is essentially a web application, a web server on Azure. But you don't have to patch it. You don't have to worry about antivirus, et cetera, et cetera. You can just concentrate on putting your code there, and then it's going to run. Things like SQL Server, for example, we have Azure SQL Database, which is essentially a database, a base of data, okay, a big collection of data in the cloud. Or we also have things like Cosmos DB. Some of you may already have heard about those open source databases, PostgreSQL, MySQL, MariaDB. MySQL is very famous. It's the M in the LAMP stack, okay? Linux, Apache, MySQL, PHP, which is used in a huge number of websites around the world. So we can host that on Azure as well, and that would be a platform as a service. The next one is SaaS, software as a service. And here I'm not going into that, but basically think about Office 365. If you have ever used, for example, Microsoft Word in your web browser, or PowerPoint or Excel in your web browser, it's something like that. Meaning that your provider, your cloud provider, in that case, Microsoft, but you have, of course, other, Google, etc., take care of everything, including the application, the software that you're using. And you're just responsible for the content that you put in the application. And then we have something fast, or function as a service, that we also call serverless sometimes. There is actually a server. It's just that you don't have to worry about it. And here we have different solutions on Azure, for example, functions, as well as Logic App. And we'll see how the time goes for the demo, but I'm going to try to show you that. So without further ado, let's see a demo. All right, so what I'm going to do is switch, or try to switch, to my other desktop. Here we go, it worked, fantastic. And here I am in the Azure portal. It's a website, all right? So you just go to portal.azure.com, you log into your account, and then you are presented with a number of things. And for example, here I have what we call a dashboard. Dashboard is a place where I can put my application, some shortcuts to my application if you wish. For example, here I selected, okay, I want in my dashboard to have a virtual machine, a website, my personal private website, a function application, and a Logic app. And at any time, I can go and change that. So I can say, all right, I want to move this here. For example, I want to make it a little bit bigger. And then I can save. And as you can see, this is saved. So you can customize your desktop like that. So let's start with the virtual machine, because I told you this is kind of where people tend to start first. So here I have a virtual machine, and it's running Windows 10. And you may wonder, why do you even use a virtual machine with Windows 10? You seem to be presenting from a Windows 10 machine. Well, the reason is that it allows me to install things that I wouldn't install on my private machine normally, or it allows me to have a totally different operating system. For example, Linux, all right? I can totally run a virtual machine with Linux in Azure. So here, this is a Windows machine, meaning that I'm going to use remote desktop to connect to it. That would be just like you do if you want to connect to another computer which is running in your office. For example, I'm going to request access. This is kind of a security measure that we have, where we say, okay, from my IP address, can you please give me access? And here I was granted access, so I can download the file which is allowing me to start the remote desktop connection. All right, I'm going to enter my credentials for this machine. Here we go. And then like that, I can connect. As you see, this is starting a brand new client. All right, it looks like a brand new computer, but it's actually the computer that I have in the cloud running as a client on my private computer, which is here at home physically with me. And now, why did I do that? Well, because right before you had Chris explaining to you everything about Node.js, and me, I'm totally lost when it goes around Node.js, because I'm more of a .NET person. And recently, I had to run a website which is running on Node.js and do some things with it. And this is a website that we have here in Visual Studio Code. But I didn't really want to install Node.js on my private machine, because it's kind of a big install and I'm almost never using it. So it doesn't quite make sense. So I just did a virtual machine here. And then I decided, all right, I believe that if I type npm Uppsala, I'm going to go a little bit higher. Okay, clear is always a good idea. And then I'm just going to type npm start, and this should start the website. No, it doesn't. Because I had the C, which is remaining from before. Here we go, npm start. And basically it allows me to run a full-blown website in Node, even though I didn't want to have Node on my machine. And so that's one of the advantages of having a virtual machine like that if you want. And of course, there are other advantages to that. For example, if I have multiple clients, if you're in a consulting firm and you have a lot of clients, you can have one environment per client. You have one machine for client A, one other machine for client B, and one other machine for client C, etc., etc. There are really a lot of reasons why people like virtual machines. But like I said, virtual machines are a little bit heavy to manage and to use. And this is why sometimes we prefer to go to platform as a service. And when it comes to websites and web server, for example, this is here my personal private website. and it is running here on Azure in what we call an app service. And so here it means that I selected, when I created this new web server, I said I want it to run on Windows because it's still an ASP.NET application. It has to run on Windows. If I had a .NET Core, I could run it on Linux as well, but I'm kind of in the process of migrating it, and I'm not quite there yet. So one thing which is really nice here is that even though I don't own the operating system and I don't have to worry about it, I also have a lot of monitoring possibilities. For example, here you see, this is my actual website, and you see here, for example, the number of data in. You also see the number of HTTP errors, which is quite annoying. I need to go and check what is going on here. You see that right here, I had 3 errors. And so I have a whole lot of things that I can monitor. Another thing that I can do is that I can take those graphs and put them to my dashboard. Remember the dashboard that I showed you before? So I can say, all right, I'm going to put those 2 here to the dashboard. And if I go back now, then you have the graphs. And basically, this allows you to build some visualization for your boss, for example, quite easily. But even better, we have even better visualization possibilities. And so let me show you that a little bit more. So for example, here I can set up all kinds of things. I can say, if there is a lot of demand on my website and I want to have more power, I can set what we call scale out, which means that instead of having 1 server running, you see here, I'm going to say, all right, I want, for example, to manually scale to 5 servers. And of course, it's going to cost me more money because I'm running 5 servers, but it means that I'm going to respond to the demand. And so I'm also going to make more money, okay? Or you could say, I want to do a custom auto scale, which means that, for example, if on one of my servers, the CPU, the processor goes higher than 70%, then I want to start another web server. And starting another web server is almost instantaneous. So the risk that you lose some requests is very low. There are all kinds of advantages like that to platform as a service. Another thing is the monitoring. So if I go here into application insights, this is our monitoring solution. Here I have lots and lots and lots of data. For example, I can check live what is happening on my website. Just taking a second to connect. So if I'm in a project, I could run this, for example, in a big project room, on the big screen in my project room. And here you see really in real time what's happening on my website, how many percentage of CPU is used. Here you see the traces which are going on. So people are actually hitting my blog apparently. And I see that really in real time as this is happening. There are tons of things you can do. You can also check the failures. And so like I told you, I had a few failures here. So I will have to go and investigate. And here I see that some of the failures are probably due to people hitting links which don't exist anymore. And so I can handle that by saying, okay, I'm going to do a redirection, for example, etc. So there are a few things that are happening here which I will need to go and check. So again, a lot of really very nice features here, including also things you may have heard about continuous integration, continuous deployment. We totally support that, meaning that you can, every time that you commit something into a GitHub repository, this is going to be deployed automatically. So that's cool, but it's still relatively complex. And a lot of people like to start in something that we call function applications. And function applications mean that you don't even have to worry about the server at all. You just worry about your code. So here I have such an application. Right now, it is completely empty, all right? I don't have anything. I'm going to click on Add, and then I'm going to say how the application needs to start, okay? So this is what we call a trigger. For example, I can say, all right, this is a recurring trigger. It's going to happen, for example, every morning at 8 a.m., all right? For example, if you want to do a backup. Or every Friday evening at 5 p.m. if you want to do some reporting on sales data. Or I could do an HTTP trigger, which means that every time I hit an HTTP, meaning a URL in your web browser, then the code is going to be executed. And as you can see, we have a lot of those different triggers that you can do. So let's create an HTTP trigger. And I'm just going to set this to anonymous. It doesn't really matter. And then I'm going to call that say hello, all right? And let's create a function. And as you can see, it's going to create code in my web browser. Now, this is not how we usually work. In production, we go into a development environment. Visual Studio Code is great for that. Visual Studio, the full-blown Visual Studio, what we call it sometimes, can work great as well. But here, if you just want to try things out, a quick function, you can do that here. And you're going to have code directly into your web browser. In this case, I selected .NET as an environment. It's more my thing, but you can also use Java, Python, even PowerShell, JavaScript, etc., etc. So here I have something. You see that what it's going to do, and again, it's still code, all right? So you still need to understand the code. It's going to get a name parameter from the query string. The query string in a URL is what comes after the question mark, all right? And then it's going to give me here an answer saying hello name, all right? And this code is already actually ready to run. So I can just go and take the URL, okay? I'm going to paste here the URL in my new web browser. I need to get out here. And the first thing it's going to tell me, the HTTP trigger worked fine, but you see you need a name in the query string. And this is exactly the code that I have here, which tells me that, all right? So now I can say, all right, now I'm going to put here, I'm going to say hi to Seth because I was a little bit mean to him. So now I want to say hi. Now it says, hello, Seth, all right? This is cool. And now I can go and change the code. I can say, hello from Zurich, all right? I'm putting something in my code. I'm going to save. I don't need to deploy anything. It's already in the cloud, okay? So it's basically the meaning of serverless code, meaning that I don't have to worry about the server. And then after that, I'm going to go here and refresh. And now it says, hello from Zurich, Seth, because Seth, you know I love you, right? And so hello from Zurich, all right? Cool, so this is a serverless function, but you know, it's still code. So I thought that I would show you something which I'm sure Donna will love. It's basically how you can do an application without any code. And this is what we call in Azure a Logic App. Logic App is another class of application. It's also serverless. And here I created one. All right. And as you can see, there is a designer, meaning that I'm going to do some graphic programming language, if you want. I'm going to put some blocks together. And so here I have something which is called Microsoft Forms. And Microsoft Forms is something that I can create. You have other such forms who exist as well. You can also connect to those. And here you see, this is, I thought I would help Cassie, who is one of the organizers of this amazing conference. Hello, Cassie. Thank you so much for organizing, by doing a registration form, okay? And so when you have a registration like that, where people go and say, hey, I want to see your stream. And I know here you didn't have to do that, but let's say that you wanted to do that. Then after that, I can get the response detail. And one thing I can do, for example, I can say, all right, I want to send an email. So let's connect to Outlook. And here I'm going to say, all right, I want to send an email. So I'm going to here take the block, which is called send an email. I'm going to sign in into my Outlook.com, into my Microsoft.com account, all right? So this is going to take just a second. And you see how easy that was, right? If I did that in code, I would have to handle the whole authentication mechanism, which would be very, very complicated. And then I'm going to send an email, for example, to myself, let's say. So I'm going to say elbunion@microsoft.com. And then probably I would have a series of people, including Jenny and Cassie, who are the organizer. And then I would call that, for example, registration, all right? And then after that, I can say, hey, I want to add, for example, the name of the person who registered. And here you see I have this has already been parsed by the Logic App. So for example, I have your name, which is one of the questions that I had. And so your name has registered. And as easy as that is going to send something, we could even do some things really fun, like for example, say that every time that somebody is registering, I'm going to post a tweet, all right? And here again, I'm logged into my Twitter account, and I can say, all right, I'm going to, for example, add some text, and the text should be, for example, this person. And so again, I go back, I take your name, has, or says hi from Zurich, for example, whatever, okay? You can just enter something. And then as soon as you're done, you can save that, all right? The Logic App is complete. Now I can say, all right, I want to run it. So basically, I want to wait to see what's going on here, all right? And then I can go to my form. This is my trigger. And then I say, Laurent Bunion, all right? Organization, Microsoft, this one is optional. And then, are you attending? Yes, I will be attending. I'm sending that. Immediately, the Logic App is going to detect what happened, all right? Everything worked fine until the tweet. But no problem, I can always go and debug what happened because I have everything here. It's forbidden. It's probably because I was not authenticated properly, but at least the email was sent properly. And like this, you can build a whole registration system without having to worry about code. If you want code, you can add, for example, an Azure function in the middle of that. But if you don't want code, you don't have to worry about that. So you see that even if you don't know how to code, there is something for you on Azure. If you know how to code, then definitely you can also expand your knowledge here and you can have a whole full-blown environment like that. So if you like this presentation, I want to encourage you to continue learning, all right? You need to keep learning. This is what I do every day. I keep learning all the time. And the best place to start is to take the Azure Fundamental Learning Pass on Microsoft Learn. This is the second link that you have here. Also, if you want to check our documentation, this is here on top, the first link. And if you want to get the slides as well as all the links, you can scan the QR code that you have on the screen or just go to gslb.ch/startdevchange20. All right, I think the QR code is easier. Thank you so much for attending this session. I hope this was helpful. And I'm going to say in the chat, or you can also ping me on Twitter if you want. My DMs are open. Thank you so much for watching. And I think it's back to you, Cess and Donna. Thank you so much.
Hello and welcome back. Laurent is a good friend of mine. Chaque fois que je veux pratiquer le français avec lui, il est très généreux avec sa temps. Ah, you see that?
Something about speaking French well.
I said French in French every time because when I'm in Paris and I try to practice my French, they always like answer in English, and they're like, "Good try." But Laurent is super nice. He always like answers me in French, and I feel like I'm doing the French thing. So Laurent and I go way back, so we rib each other all the time. Now, a couple of things. One thing that I want to bring up, and Donna, maybe you have some thoughts on this. We had two options when we did Start Dev Change. And incidentally, let me throw out this. Like, you're seeing me and Donna, we just show up and they tell us what to do. Yeah. Cassie Breviu is the one who came up with this, got everything together. Yes. So if you see her in the chat, tell her thank you. Yes. We didn't do anything. Nope. We just show up and
she gives us a piece of paper and says, read these words, and we vaguely do.
Yeah,
Not well, also. See, that's the piece of paper. But Cassie Breviu put this on. Jenny from our team. You're seeing people in the chat. Jenny M Events, Cassie Breviu, Joe Camp, maybe. So these are all folks on our team, and they actually, I came up with the idea of the event, found all the speakers, got all the content together, and they have just done a phenomenal job because putting on a virtual event that caters toward lots and lots of people, keeping attention is very challenging. It's really hard.
So think of this, because they could have gone one of two ways. They could have said, let's just pick a technology and let's just like go through it. Or let's have like a cheese tasting, right? Because at home, usually I can go through a whole block of cheese myself. But wouldn't it be better if we had little morsels of cheese so that we could find out which block of cheese we want to eat? Is this not working?
Well, other than your Velveeta block of cheese situation. No, but it's true because the whole point of a conference for learners and beginners is people struggle with step 0. They don't know what to do first. But once they understand step 0, they're able to find step 1, step 2, step 3 on their own. Because the whole point is you start building a thing, whatever that is. It could be a website, it could be an Azure, instance, it can be a Power App, it can be a C++ app, whatever you want to build. You start building it, and then you realize you have 100 questions. You know how to ask those questions because you understand the basic language and the basic lingo. So our goal is to just show you step 0 of a bunch of stuff, depending on what project you want to take on. Does that make sense?
Yeah, hopefully it does. And by the way, if you're hearing my nervous tick, like I'm literally clicking this pen. Cameron already told me to stop. Yeah. Surly Dev, I'm sorry, but this pen is a fountain pen. And now every time I write, I feel like I'm like signing the Declaration of Independence. So it's like everything I'm writing now, this is like real ink. So I'm sorry if I keep clicking on my pen, but every time I write something, it feels like super important now. So, but I will stop clicking. If I do, literally just shout at me.
Stop.
And I think we landed on like everyone is like the official thing is you say, hey everyone in the chat.
Twitch links.
I think for us, it's Twitchlings is what we've decided, right?
You've deemed yourselves Twitchlings. Hello, Twitchlings.
Yeah,
like
now,
that.
and everyone's like, I didn't notice the pen, Seth. Thanks for bringing it
Now
up. Here,
everyone
I'll do it.
notices the
Shh,
pen.
I'll do it so you can hear it. Is it really that loud?
It's so annoying, Seth. Seth, it's so annoying. Seth,
Okay, but I need to catch up. I
I'm
want
going
to
to
see if they
socially
think it's annoying.
non-distant throw something at this
But
man.
maybe now if they know it's like a special pen, it's okay.
It's not, no, it's not better. It's still annoying for everybody.
Oh. I thought it was it was my restless leg syndrome. You know, me and Donna were talking last night about how, like, at a certain age, like, you can get injured. Hey, how'd you hurt your shoulder?
Oh.
I slept wrong.
90% of our injuries happen. I slept wrong.
Hey, Seth, why are you walking like that? Did you hurt your
wrong.
back? Yeah, this morning I stood up.
No, it's like that. The other day, I couldn't even move the shoulder at all. People are like, "What's wrong? Are you okay?" I'm like, "Yeah, I slept wrong." People are like, "Oh, it's a old person, 40-plus-year-old issue." We're like, "Is that really a thing?" And I think it is.
Yeah, and like when you measure like a snack, and your measurement is happiness versus heartburn, and you have to make that measurement in your head, you know you've reached a certain age.
Wow. Okay, now that Seth has made us sound so old and irrelevant, let's go to someone actually relevant talking about new things. So next up is our friend and colleague, Jen Looper, talking about static web apps. Over to you, Jen.
Thank you so much, Seth and Donna. It's a pleasure to be here at Start Dev Change. I remember when that very first tweet went out about, is anyone interested in talking about, career switching and getting into tech? And everyone was like, yeah, that sounds like an amazing conference. And here we are. So this is a really exciting moment for all of us. So thank you all for tuning in. I'm coming to you live here from a beautiful day in Boston. I'm here in my office. This is my closet that I retrofitted into my office because my husband teaches right on in the other wall. So if you hear any yelling, that's him. But I'm here to talk to you about something I really enjoy using. I use it all the time. And whenever I have to build a website, this is my absolute go-to. And I just want to share this kind of open secret with you all, is how to build a website the easy way using Azure Static Web Apps. And this is a product that came out. It came out at Build last year, so in May. And actually this past year, and everybody just went gaga because we're a bunch of JavaScript developers and we needed a really clean and easy way to develop our websites on Azure somehow, one way or another. And there have been ways in the past, but none was as awesome as this one. So I just want to kind of walk you through how you create your websites now using Azure Static Web Apps if you're a JavaScript developer. So this is the demo actually that I'm going to show you, but I'm going to blow past this. And we're going to make an affirmation app. But first, I want to talk to you about the architecture of how you build these apps. So what are Azure Static Web Apps? Well, let's do a little exploration. Like I said, it's a new-ish service from Microsoft. It's been around a little while and people have been enjoying it for a little while and putting it through its paces. It's a slick way to build and deploy and host your modern web apps. And when I say a modern web app, I'm talking about all of those JavaScript developers who are out there building Angular and Vue.js and React apps. I'm a Vue developer, but I'm coming also from the Angular world and I dabble in React a little bit. So it's a real pleasure to have a way to build what we call a SPA, a single page app, which is a way to build web apps using these modern JavaScript stacks. It's a clean way to manage your app and to manage its API. Thanks, Cecil. And it has a real nice ecosystem. It's a nice product team that will be able to help you if you have any questions. So let's talk about how you can use Azure Static Web Apps to build your app and its API. So who am I? I'm a JavaScript developer, like I said, and I need some options. I love options. I need some options to quickly develop my website on Azure and deploy that thing. So what if the website also comes with an API? So before I came to Microsoft, I've been developing mostly on the front end, but also in the database tier for maybe 20 years. I need to get rid of these notifications. I'm just going to take 1 second and pause and quit Teams. There we go. No more distractions. Okay, so if I'm a JavaScript developer and I need options for using React or Angular or Vue to build the static web app, it's awesome, I can do this on the front end, but what if I also need an API? So this interface that might interface with a database or a data set somehow that I can use within my app. So before I came to Microsoft, I'd never in my life made an API. And lo and behold, here we are bashing through creating APIs using Azure Static Web Apps, because it's all bundled together. You have your app in one folder and your API in another folder, and you can just easily, as much as that is a tricky word to say, but honestly, it's not that bad to create an API and an app all together in one place with Azure Static Web Apps. So prior to Azure Static Web Apps, you were able to use app services, maybe with cobbling together an app service with Azure Functions, but this is all brings it together in one nice clean package, and that's Azure Static Web Apps. So what does it look like as you're building your app? What kind of folder structure are you looking at here? So as a Vue developer, I use the Vue CLI to scaffold myself a nice Vue app, and that creates something in an app folder. So that's as far as I'm going to get with my Vue CLI. So I would say Vue create app, and it would scaffold for me everything that's in this app folder. So it has, it's public folder where you keep your static assets. It's source folder where you're going to be actually writing your components that will feed into your app. It has your package JSON file that contains all your dependencies. And then you also have an API folder. So your front end is going to go into the app folder, and your back end is going to go into this API folder, which I should have probably changed the slide here, but the API folder contains the back end, and it contains all of your functions that you're going to be using via your app folder and via those components that you put in your source folder. So this is your basic architecture. You have your app and your API, and then you have some GitHub actions, and we'll talk about those in a little bit. So you have decided you're going to build a nice website. I decided I would build for you an affirmation website. So I have a bunch of hard-coded affirmations in my API folder, and those are brought in ad hoc via the little function that I have in my API folder in my app folder. And so that is brought in and displayed on the front end in that app folder. So here's one of my components, and all it is displaying an affirmation with a nice looking background color. And so this is a very basic app that I built. It just has 2 pages. So it has its home page, and then you click a button and it'll take you to your affirmation page, and it'll pull from the API a random affirmation. Right now, those affirmations are just a hard-coded array, but you could use your functions to query any kind of database. I've hooked up my API to Cosmos DB, which is one of our nice free NoSQL databases that you can try. There's a nice free tier. You can give it a shot. You could use it to use things like PlayFab. PlayFab is a nice service for if you're building a game, and it's a terrific engine for games. Works very well. That's another nice service that you can try. And all of this works beautifully in Visual Studio Code. So I hope that a lot of you have been taking a look at Visual Studio Code as your IDE, your integrated development environment. And the reason it's integrated is because it has a lot of extensions that you can use. And one of those extensions is the Azure extension. And one of those Azure extensions is the Azure Static Web Apps extension, which you can use to deploy and to manage your Azure Static Web Apps right from Visual Studio Code. So it's really, really a clean and nice experience. You build up the front end, and then you need to enable some routes. So you need to add one file called routes.json into your, for me as a Vue developer, I have to put it into a static folder. So it goes into my public folder that I showed you in the slide prior. You put this and you list out the routes that you need, so that your SPA, your single page application, will understand the concept of routes. And that's always the sticking point with trying to deploy SPAs or single page apps into these kind of services, because routes are tricky in these things. And it's not like you're going page to page with a huge refresh. You're actually taking a page and you're injecting code as you use the router that's integrated into your app. So you need a nice way for your single page application to understand the concept of routes. So you need this little file, and that is out there for you. At this point, you can start building up your backend, and here's where you're going to use this generalized structure of Azure functions within your API folder. So remember, we have our app folder with the front-end code. In the API, you can put a whole bunch of functions. Mine just has one function, and it's called, I believe it's called get affirmation. And all it does is it pings this array, this constant, which is an array called affirmations, and it's a long list of affirmations. And then it just says, I'm going to grab a random one of these 46 affirmations, and I'm going to display it. So it sends it back to the front end. So my front end is querying this local API and bringing it back in to the front end so that you can see. So every time you refresh or you go back and forth and click the button to get a fresh affirmation, this function will run again, and you can have a nice experience for your users. So the nice thing about this whole development experience is that, like I said, you're using Visual Studio Code, and you have a lot of tooling that's integrated into Visual Studio Code because it is a nice IDE for any kind of developer, especially a front-end developer. And I would strongly advise you to install the Azure extension into Visual Studio Code so that you can leverage the magic of deploying Azure Static Web Apps using this extension. And the other thing that it allows you to do is within the Azure extension, there's Azure Functions functionality, and you can use this debugger right here, the little bug. You can just click that and you can start running your API locally. And it will start listening on port 7071. And then, so that'll basically fire up your API so that you can start working with it. You'll start another terminal window for your front end so that you have your backend and your front end both running on localhost. Backend will be running on port 7071. Front end for me as a Vue developer, it runs on 8080. I think for other front end frameworks, there's other ports that are running. But here you can see that it's running on port 7071 on localhost. It hits the API folder and it looks for affirmation. So the name of this function is affirmation, and it's just grabbing that affirmation out of this large array. So like I said, you can build something way more complicated than this. I actually have a pretty serious app running against Cosmos DB. I have a couple of them. And these are really great. It just is a very seamless way to use the various SDKs that are available to you as a JavaScript developer to be building your backend API and your front end, all using JavaScript and all within the same integrated development environment. I really like it. It really works nicely. And it's kind of comforting when you open up your IDE and you know where everything is. So that's really cool. So once you've got your backend running, you're going to fire up your front end on localhost. So like I said, for me, it runs on port 8080. You can see that in the URL, and you'll test your app this way. So you would open up a new terminal and use your app's CLI to run. For me, it's run npm run serve, and that fires up the Vue CLI and allows me to run my application. So I would encourage you, if you're completely new to front-end development, take a look at Vue.js if you're interested. It has a reputation as having a nice learning curve so that you can get into it. I'll give myself a little shout out. I am the founder and CEO of Vue Vixens. So if you're someone who identifies as a woman, we have workshops for you. We rebranded to be Front-End Foxes. So you can find us on frontendfoxes.org. We have a nice Slack channel where you can find mentoring and people who are like-minded people who will help you in your front-end experience. We have React developers, Angular developers, Vue developers. I think Svelte is coming along. That's another front-end framework. JavaScript people love to launch front-end frameworks as a hobby. We have, but those are the three big ones. And if you would like to join us on Slack, you'll be able to find front-end folks to help you in your journey. So that was a little segue. Just wanted to mention that. So frontendfoxes.org. Anyhow, so you're going to run your front end on localhost to test your app using your CLI, your command line interface, which you can do right from within Visual Studio Code. You can just type npm run serve, and I'll show you how this works. So here's a little kind of grainy video. But what I am doing here is when I'm ready to deploy, I fire up that famous Azure extension for static web apps, and you can see static web apps preview. You can see that extension right there. I'm going to go ahead and give it some instructions on where I want it to be deployed. So I'm going to say, okay, it's going to walk me through this wizard. So here it's asking for the path of the build output. For me, it's build. I'm in Boston. I want it to be deployed on the East Coast, so I set that to happen. And then I'm telling it which subscription to go to, giving a name for my new static web app. And I'm going to associate this web app with something I've already pushed to GitHub, which is called test app, I think. And then it's going to start asking me for some information on where it's going to find the code. And this is an important step because as you deploy your app on Azure Static Web Apps, it's going to create for you a little file that's in a .github folder, and that's going to launch your deployment scripts. So that is another thing that's taken care of for you as you start deploying using Visual Studio Code. So this is a beautiful stack, right? You have Visual Studio Code, everything is kind of like bundled up together, it's all in one place and taken care of for you, thank goodness. So we are all set as front-end developers. So why GitHub? Well, it's important to have your code hosted in GitHub because that's where Azure Static Web Apps is looking for your build scripts. So it scaffolds out for you a little website for you to host your deployed app, and it gives you a little file that is being run in GitHub Actions. So in that little tab in GitHub where you have your code hosted, there's a little tab called Actions. And you can look at this and you can see all the deployments as they're happening. If there's any failures, it'll tell you what was wrong. Usually it's because it can't find a folder or something. Or you can be happy and you can look at all your successes. And it's kind of cool because everybody can see this, so they can all see all the changes and all the history of your app as you're deploying and deploying. So this is a really cool area where all of your build process is managed, and it's all done via GitHub Actions. So there's a beautiful integration between Visual Studio Code, GitHub, GitHub Actions, your front-end code, your back-end API. It's really a nice ecosystem. I love it. So this is what that little file looks like that's scaffolded for you. It's a GitHub Actions file. And every time you push to GitHub, your API and your app are going to be rebuilt. This file is going to kick in and a build process will launch. So, and you can control that experience a little bit with this file, but you can always look at this file to see what exactly is going on in your build process, and you can tweak it a little bit. If you want to try the app that I built for you, it's at aka.ms/my-affirmations. I think in this pandemic, we all need affirmations. Even my cat needs affirmations. You know, I pat her every evening and I tell her she's a very, very good cat, because she is. And she needs an affirmation too. So I call those catformations, but that's beside the point. So building, hosting, deploying, GitHub Actions, all that good stuff, that's nice. But wait, there's more. So excitingly, there's more bundled up in Azure Static Web Apps, and you can see these on the Azure portal. So you can check out the side nav bar. There's a configuration settings. There's the ability to launch custom domains. So when you're ready to truly launch your website, you handle it there. Your functions, as you develop them, are going to be listed out. Your environments are all set up here. So you could have, if you would have a push to GitHub from a branch, that would create a development environment that then you would delete when you delete the branch. So it's kind of like a nice way to test if you don't want something to go right to production. There's role management for handling the people and the things that they're doing in your application. And there's some other stuff, box and export template. But the cool thing that I really enjoy and I really use is this configuration piece here. You can store tokens in this area. So in this example, I have my View App PlayFab secret key. So this was an app that was connected to PlayFab, which is that game environment that I talked about. So here, I don't want to release all of my API keys and all of those secret things that people really don't need to know. I don't want to release those into the wild. I don't want to put that open in GitHub. So I store them here in Azure Static Web App portal. I pop it into here, View App PlayFab secret key. You're not going to see that hidden value because it's hidden and it's secret. And that is pulled in to my View application. It's process.env open bracket View App PlayFab secret key. And it knows, because it has this connection to Static Web Apps, that that's where that secret token is. So that's a really nice thing to keep all of your secrets actually secret. Very helpful. But wait, there's even more. I feel like I'm advertising, but I'm not advertising. I just really like this service. One of the nastiest things that front-end developers have to do is handle authentication. It is not something I enjoy doing, but it's actually not too bad. It's pretty easy using Azure Static Web Apps with a little bit of code, because it has built in an authentication routine. It has social auth built in. So you can have folks logging in with Twitter and storing a token, logging in with Facebook, Google, and it works nicely. I have this working very well on a different app. This is a archive that I was building, and you're searching a database and saving your searches. And you do that by logging in, and you can see a sidebar. But it's really just a few lines of code here. All it is you're using this auth method, which is built into static web apps, and it's really not that much to get this moving. So it's a great way to authenticate your users. I really like it because I hate writing auth scripts. One more thing. I was mentioning this before. This is your environment management area, so you can manage all of the deployments that are being handled by your scripts. So when you want to scaffold a staging site, you would create a branch and push that with its own action file, and that will create a staging site, like a temporary staging site, and push it to GitHub so that you can test your changes. You can get rid of the branch, you can get rid of this environment, but just in case you don't want something to go straight to production, you can have a branch, and that will be viewed on this separate site, kind of temporary staging site. Very helpful when you're just not quite sure that everything's going to work the way it's supposed to, which happens 24/7 with the developers. So this is something that's very helpful. So at this point, I will scooch over, and maybe you can, let's see, there we go. Maybe you can follow along with me. If you go to aka.ms/my-affirmations, you can get your very own affirmation. Let's see what my affirmation looks like. You make a difference in the world by simply existing in it. I feel good. It's nice. Let's get one more. You know more than you think. This is perfect for this conference because I know all of you know a lot more than you think you do. So it's a lovely affirmation for you. I'm proud of you. I'm proud of you for making a career switch, if that's what you're thinking of doing. I actually was trained as a French teacher, so I made a career switch about 20 years ago. I miss my classroom, but I'm on the academic team and I still get to deal with students. So sometimes you can bring your passions from your previous career into your technical career. So that's a really kind of powerful place to be. And I wanted to slide on over to this area because this is how I have that app running on localhost. So you can see here it's running on 8080. I have two terminals here that I fired up prior to this talk. So that's the front end, and here's the back end. And you can see every time I was hitting that route to get my affirmation, it would notate that here in the in this area in the terminal. And this is the extension. This is what it looks like. So you have your static web app extension. It has all of my subscriptions here. I could create a new function within my app. I could refresh the whole thing. I could create a new static web app completely, and that would scaffold all of the pieces for me that I need in terms of the deployments. So that's really helpful. So that is the Azure. I can just show you how the folder structure goes. You've seen that already. So this is the API folder, and here is the functions. This is that affirmation function. And all you're doing is editing this index file. And here's those, how many is it? 46 affirmations. And they're just hard-coded in here. This is the simplest, dead simple example, but you'll probably create something a lot more complicated. This is just for demo purposes. So that's the API folder, and the app folder has all of this good, nice view content here. So here's my source folder with my assets, not much going on in there. And affirmations is where all of the magic happens. So this is that ribbon class that you saw with the affirmations. So home route, affirmations route. Here's that routes JSON file that I mentioned earlier. And I just want to open up the GitHub workflow file. So here it is. And you can see how all you have to do really once this is scaffolded for you is just verify that it is properly selected the app folder as your front-end location and the API location as API, and your artifact location to dist. So for me, as a Vue developer, dist is my final destination. I believe for Angular, it's something like prod. It's been a long time since I've talked to Angular. But lots and lots of good stuff here. You can add things to this. This is not locked down in any way. You can, it's watching for pushes. So every time I push to GitHub, we'll get some building happening. Whenever there's a pull request, things are happening. And just overall, it's a great development experience. And let me go back. Okay. So honestly, the bottom line is that Azure Static Web Apps are a web developer's dream come true. It gives you easy and free deployments. It gives you this beautiful GitHub integration. It works really nicely with the modern JavaScript stack. And I've been blabbering a lot about the modern JavaScript stack. But as of Ignite, we had a new product release, and this is really exciting. So you can also write your API with Blazor WebAssembly and .NET functions. So this is very, very nice in case you don't want to write your that middle tier that's talking to a database with JavaScript. You can use Blazor, WebAssembly, and .NET especially for that API. And I would just encourage you to visit SWA Framework, aka MS SWA Frameworks. There's a really excellent Learn module by my colleague John Papa, and you can pick. It's kind of choose your own adventure. You can choose React, Vue, Svelte, or Angular. Go through this Learn module, and it's a great way to learn static web apps. So I just encourage you to hang out with us and ask questions. I'm sure you've been doing that all today as you learn from Microsoft developers on a variety of tech concepts. Lots to listen to on Learn TV. If you listen to Cecil a couple talks ago, he is going on Twitch tomorrow, I believe on the Microsoft developer channel. Double check with me on this, maybe not, but he is talking about Azure Static Web Apps as well. So if you want more information about this, he's going to be talking about this live. And you can always grab that free certification with the Cloud Skills Challenge. So I wonder how many folks are doing this Cloud Skills Challenge. It's a great way to learn. You are going to be able to live stream on October 20th on Twitch for Azure Fundamentals, and then Power Platform Fundamentals on October 27th. So getting close to Halloween there, but it's not scary at all to do a Cloud Skills Challenge. And I'm proud of you. I want to just affirm that I know that you'll have an awesome career. Tech is a really cool place for all kinds of people, not just, you don't have to love Star Wars. You don't have to love the kind of typical tech things. You can be that fashion designer. You can be that French teacher. You can be all kinds of a person and find a place in this field. I think it's a terrific place. It's certainly been good for me. So thank you so much for listening, and give Static Web Apps a try. Static Web Apps, there you go. Here's a different route, but SDC/Static Web Apps, and just do the Learn module for me and tell me how you like it. So thank you.
We are back. Hello and welcome. Hopefully you learned a lot from Jen about static web apps. Now listen, if we can go to my screen, she did make a call out to something called free certifications with something called the Cloud Skills Challenge. Join the Cloud Skills Challenge and complete to receive a free Microsoft certification. Microsoft experts will be available on the 20th for the Azure Fundamentals. I know some people were talking about it in the chat about it. It's not the chat, it's just chat.
We're learning the terminology.
See, we all learned something. So the live stream on Twitch for Azure Fundamentals is on October 20th. The live stream for Power Platform Fundamentals is on October 27th. You can learn, compete, and win. I don't know what you win. Oh, certification vouchers. Now I know everything. Now we know everything.
Yeah, it's a really great way to first learn skills, 2, test out your skills, and 3, it's a very good resume builder. These certifications will set you apart from all the other people who are job seeking. So we highly recommend you go to each one of the certs. All the learning paths are below. It'll tell you, do these modules, do these, learn modules, study these docs pages. So they'll tell you exactly what to do to actually go do the certs. So by all means, do it. It's good for you. It will set you apart.
Yeah, and one of the questions that I saw in chat, I'm going to say Twitchlings. One of the Twitchling Legion said, there are so many things that are being dropped right now. Where do I even know where to start? What language should I use? Here's my suggestion, if I would pick a thing that you want to do, it's like, I'm finally going to start my blog.
Right.
Great. Or I want to build something that, like, I want to build something on a Raspberry Pi. Great. I want to build a machine learning AI model because that's where everyone should start. You don't think so?
No, I don't think so.
I think you can, though. I mean, it's not a difficult, it's not a super difficult thing to grok, right? Especially with some of the services we have. But basically, pick the thing you want to do, and then see how everyone else is doing something similar. Because if you do that, you'll get a lot of help with things that other people have written or things that other people have done. For me, like, I'm terrified of like front end. But I just picked something, and since I know Jen, among others, I picked Vue because it was the easiest thing to do for me. And then I learned a framework called Nuxt.js, which it made everything a lot easier. I don't know how it works exactly, but I actually got a thing done, which was pretty cool.
It's fun to make a thing so you can actually say, like, I made this. It doesn't matter how bad it is. Like, we believe in... Does language matter at this conference? No. We believe in the shitty first draft concept. If you're an author, you know what shitty first draft is. It means you can edit a shitty first draft. You cannot edit a blank page. So create your first thing. You can always improve it. You also don't need to show your first thing to anyone. You can make it for yourself just to learn. And, you know, it is your hello world. It can actually just be hello world in some language, or Raspberry Pi blinks at you 3 times, and that is hello world.
And here's the secret, and I'm just going to say this
Loudly.
because no one's here at Microsoft right now because everyone's at home. Nobody knows what they're doing.
Nobody.
I'll give you the very first, let's see how much time we have. We have about a minute. The very first piece of advice I got, I was still in college, and I was like a consultant. And back then, they charged for my time. I didn't get paid this much, but they charged for my time $130 an hour. And I remember walking in, right? And I was like, Bill, it was my boss. I'm like, Bill, dude, I don't know $130 an hour worth of stuff here when I show up. And he said, Seth, listen to me. I'm like, yes, sir. They don't pay you because you know everything. They pay you because you'll figure it out faster than they ever will. Changed my life. Changed my life.
True. This is true. And the reason you'll figure it out is because that's your job. Their job is to do the other thing. If they really want to focus and spend all their time on this, they would have done it by now.
So the most important skill you could ever have when you're starting out is learn how to figure things out, because that's all we do all the time. All right. I think we're out of time. Coming up next, we have Sarah Guthals talking about an introduction to GitHub. Still frightens the heck out of me. I rebased one time. I felt like a genius.
It's the social media for devs. Let's learn it. Let's deep dive. Over to you, Sarah.
Thank you so much, Seth and Donna. Hi, everyone. My name is Sarah Guthals, and I'm really excited to be here to talk to you about GitHub. Quick little bit about me. I now work at Microsoft, and I love teaching and learning code and tech. Prior to this role, I was at GitHub as a manager for how we integrate GitHub into client applications like Visual Studio Code. GitHub is super fascinating to me, and I'm really excited because it is a tool that I think every developer, especially when you're first starting out, should leverage, because it's not just a tool, but a community as well. And we'll talk a little bit about that. So today I'm going to mostly be doing demos. This deck is really just for my agenda. And we're going to start out with a little bit about what are the GitHub tools that I personally recommend. You can follow along if you would like. And afterwards, there is something that you can engage with to try out GitHub for the first time without it feeling stressful, like you're going to be on someone's real code base and give it a try. So I'll direct you to that. After we explore some of the tools, we're also going to go into what exactly is Git and GitHub, and I'll kind of demo how it works. We'll go through the GitHub flow, which is actually different from Git, and I'll explain that. And then I'll touch briefly on what open source software is, or OSS. All right, so let's get started. First of all, this is what you might see if you log into github.com. So if you go to github.com, you can sign up. And when you log in, the first time you log in, you probably won't have a lot of this. But as you start to use it, this is what the home page of a logged in GitHub account looks like. And what is GitHub really? It's really just a place to, like at the bare minimum, it's a place online to store your code. It's much more than that, because rather than just it being kind of a blob storage or just like a place to put code, it also tracks the changes that have been made on the code. It's useful for individuals as you're trying to build something. So you can kind of say, this is a point in time when I've added this feature, I know this works, and then you can kind of make a marker there, and then you can keep experimenting with the next part of your code. And if that doesn't work, you can kind of just delete and reset to over here. You can kind of think about this. We have the same kind of thing in like Word docs with track changes, right? So you can have lots of people also editing the same code or the same doc and tracking all of the changes that they make. And you can accept some changes and not others. So you can kind of think about it like that. It's a place where if you're working by yourself, it's still a great backup place for your code. And if you're working with others, it's also a really cool place to work with other people. So on the side over here, you'll see different repositories that you might be working on, that might be yours, that you might be contributing to. GitHub has teams. We're not going to jump into that today, but you can check that out. Over here in the center, we've got kind of what's been happening on the repositories that you might be engaging with or that you might own. And so that's kind of just a feed over here. And if you want, you can also look through some of these other high-level menus. Explore will take you to some of the more popular repositories based on your interests or based on topics that you might be interested in. So if you've been attending some of the like web dev sessions from earlier, you might be interested in checking out CSS. I don't know, I'm not a web dev person, or Flask. I'm more in the Python realm, and so that would be a good place to start. Also, we've got your profile page. And one really cool thing that we have that has recently come out on GitHub is the ability to create a README for your profile page. So there's instructions on how to do that, and I'll also link to some. But basically, if you create a repository called your username and you just create a README file, you can create this kind of high-level README so that people, when they come to your profile, kind of know what you're about and what you're interested in. Let's keep kind of going through. You can see repositories on people's profiles. If they're public, you can check them out and go see what they're working on. And one in particular I wanted to bring your attention to is my Talks with Dr. G repository, where, for example, and actually I'm on the wrong README. If you go into my Start Dev Change, you'll find this session. And in this session, you'll find a README with a bunch of additional resources that you can follow up with. So that's a little bit about GitHub. It's basically this like web browser where you can store your code. A repository is kind of like a folder. Inside of a repository, you have files. I work a lot in Markdown files as I do a lot of documenting, but you can have any kind of code there and it kind of keeps track of that. That's all what you can do in the browser, or kind of that environment in the browser. But there's also some tools that I highly recommend on any platform. So whether you're on Windows, Mac, or Linux, I highly recommend GitHub Desktop. Actually, maybe it's just Windows and Mac now. I can't exactly remember. But GitHub Desktop is this really great application. And let me zoom in. For some reason, this page didn't get zoomed in. It's this really great application, which I'll show you in just a second, that allows you to take the code that's stored up in the browser, stored up on the cloud, and bring it down onto your local machine. Okay, so you can kind of imagine it as code is being saved up here on GitHub's servers. And then I'm going to create a copy of it, bring it down to my local environment, and I'm going to modify that code. And that is just modifying it here in my local environment. And then when I'm ready, I'm going to push all of that code back up to GitHub so it can be saved up there and accessed by other people if I want it to be. GitHub Desktop allows you to do that fairly easily with some just like clicks of buttons, and just kind of allows you to track your code this way. It's got a lot of features for checking to see, like, if I had pulled my code down and made some changes and someone else had made changes while I was doing that, before I just kind of throw my changes up there, it'll have me pull those changes down, make sure everything looks good, make sure I know what I'm adding and changing, and that helps out a lot. And we'll show that in just a minute too. The other application that I use a lot is Visual Studio Code. Visual Studio Code has GitHub integration into it to do like the basic Git things associated with your GitHub account. So Git is the basic like clone your code, make changes, save those changes, push those changes, things like that. And GitHub allows for things like a pull request, which is complicated and we'll get into in just a minute. So Visual Studio Code has some integrations with Git and GitHub that allow you to just work in this environment if you'd like. I prefer to have desktop and VS Code mainly because my brain gets a little confused. And so I like to write code in one place and like manage code in a different place. Even though I could do it all in VS Code, I like to have that separation. I also just wanted to highlight that VS Code also has this Learn to Code site that does have some packaging. For example, if you're a Java coder or you're a Python coder, it has some packaging for you, as well as some tutorials and things that you can follow along with. I just wanted to kind of plug that. Okay, this is very similar to what you might do in this introduction to GitHub learning module on Microsoft Learn. And you can find it at aka.ms/intro-to-GitHub. It's also linked on my Talks with Dr. G site, so you can see that over here in the intro to GitHub right here. So you can find that module linked right here. But let's actually just do it. So we're going to first go to GitHub. And at the very top, I'm going to click on this plus button and I'm going to click new repository. And I don't need to use a template, but one really cool thing is that on GitHub, you can actually make a repository that's a template and then many people can kind of have that same template. We're just going to have this be a simple one. I'm going to call this one Start Dev Change Demo. And I'm going to make this one public, but you could make it private if you wanted to. I like to always add a README file because I think that like a repository, basically that folder of code, should always have a front file that just kind of explains what it is. You don't have to put in a ton of detail at the very beginning, but I highly, highly recommend having that. The git ignore is a really great file. You can always add it later, but basically it's a list of all the types of files that you don't want to include. You don't want to have saved up inside of GitHub. And the reason is sometimes depending on what language you're using or what operating system you're on, they might create files that help that operating system or that local environment understand kind of how to use your code, but they're not relevant to everyone's local setup. So if you're doing something complex where those types of files are being added, you can add it to a git ignore. We're not worrying about that right now. We're just going to do Markdown. So, and then another really neat thing is choosing a license. So there's a really amazing resource right here, maybe if code wants to load or pages want to load, that explains about how to choose licenses for your code. And it doesn't look like it's loading right now, so we're not going to worry about it. But basically, choosing a license allows you to pick any of the common licenses that GitHub already has in there for you. Or you can kind of walk through on this learn more. Again, not sure why it's not working right now. It might be me. You can walk through what license might be good for you. And this is, for example, maybe you want people to be able to use your code and whatever they want to do. Or maybe they're allowed to use your code, but they have to always push their changes back to what you're doing. Or maybe you say, you know what, you can use your code, my code, as long as you use it for free. Basically, it's giving you the control over how other people use your code. I'm not going to worry about this right now because this is just a simple demo repo. So I'm going to click on Create Repo now. And this basically creates that folder called Start Dev Change Demo inside of my GitHub user. And it created that README file for me, which right now is just nothing. Up here, you can see this kind of square blue box with my name on it that says initial commit with README. This is where the list of files would come in. So for example, if I wanted to create a new file, I could do so all in the browser. I could call this sarah.md. MD stands for Markdown. It's basically the programming language that allows you to format your just writing. So I could say like, my name is Sarah, welcome to my talk. And I can create this folder or this file. here is where we are doing that, like save that file thing. So it's called commit in GitHub. Commit is basically saying, I've made changes to this file and I am ready for these changes to be represented in my official kind of repository. When you do an initial commit, if you're on the GitHub browser, you can commit it directly to that branch, to that kind of file, which is what I'm going to do here. But you'll see in a minute when we go down to the local environment, there you will have to commit and then push those changes because you're only committing in your local environment. So right now we're in the browser. So commits happen for real in the browser on our code. When we're in our local environment, the commits happen locally. And then we have to tell our cloud supported code, stored code, that we've made those changes. It's always a good idea to have really good titles and descriptions for your commits. In this case, it really is just create a new sarah.md file. And my description is demoing how to create a markdown file in the browser. These are useful because, again, if you're heavily using commits, if you're saying, hey, this is a part where I've made some changes and I'm confident that these work, then if you go on to do the next bit of stuff, it's okay if that stuff doesn't work because you can always just revert and delete all of that stuff you just did and just focus on the last commit that you made. So having good titles and descriptions for those commits helps only you, because if you've made a few and then you're like, oh, I need to backtrack like 4 of them, you know where you want to go back to. So we can commit that file here. And then now you can see that it has not only the README, but also the sarah.md. You could also create folders in here. I'll show you that in just a little bit. Anytime you're within a folder, the README, anything titled like readme.md will always be displayed down below, or you can click on it here. Okay, so now we've created this repository called start dev change demo. It's got 2 files in it, one called readme.md with just this title and one called sarah.md with the stuff we just wrote. Now let's actually get it down to our desktop. So again, with GitHub Desktop, this is super easy. You just click open with GitHub Desktop and that'll just open GitHub Desktop, which will take us here. And it'll automatically kind of put the URL in there and offer up a local path. So I'm actually going to change this one. Let's just go ahead and put it on our desktop instead of putting it in the Ignite folder. You can also click choose here and choose where you want it. And I'm going to click clone. So what clone does is it takes all of the code that was up in the browser and it makes a copy of it down local below. Now it's called clone, not like reference or something, because it is an actual copy of it. So things that I do here won't immediately be reflected online until we push those changes. So we can open this inside of Visual Studio Code. And let me bring that up here. And now what you see is I've got my start dev change folder and I've got my README file with just that title. And I've got my sarah.md with what we wrote. So we can change this one, for example, to look a little bit more like this. Oops. And welcome to my demo repo. I can save the changes here. So this has officially saved the changes. However, we have not made those changes like up into the browser. So it's saved those changes. We can see in GitHub Desktop that I've made a change. This is the change that I've made. I've deleted this line and I've added these 3 lines. Now we didn't really delete this line. We just kind of changed it, but because we changed kind of the majority of the line, GitHub is going to recognize that as like, look, you basically just got rid of that line and added in a new one. Okay, so if we go back over here, nope. Where's my, oh, I know where it is, here. We can see that those changes to the README didn't get updated. So for example, if I refresh the page, there's no changes here, because we didn't actually push those changes. So we've saved them. Now we're going to create a commit. So updating the README file, added a welcome message to the README. And I'm going to commit to main. Still, this is all local. Okay, so if we were to go back over here, we're still not seeing these changes yet. And that's because all we've done is save changes to our local file on our local machine, made a commit, so said, yes, this is a point in time that I'm confident of my code. Now we need to actually push our changes back up to the repository. And you can do that either clicking up here to the push origin or clicking here. So I'm going to click push. Once that is done, again, depending on how much code you've changed or manipulated, that may take shorter or longer. Now, when I head back over here and I refresh the page, we see that it changed this to what we had over in the code. And we can see the same type of thing. Make sure you check out the talks with Dr. G repo too. And then I can commit changes for the purposes of speed. I'm just going to commit them without changing the title. So now I've added this in here. And if I head back to GitHub Desktop, I can say fetch to ask desktop to go up to the browser and say, or to the cloud and say, hey, have there been any changes? And when I say fetch, it'll say, yes, there has been one change. You might want to pull that down. I can pull those changes down. And now when I open up in Visual Studio Code, we see those changes here. So that's high level overview. I did want to also go over how pull requests work. So we're going to go back into my talks with Dr. G. And inside of the intro to GitHub folder here, by the way, you can get to this aka.ms/talks with Dr. G. And if you go there and then you click on Start Dev Change and you click on Intro to GitHub, that's how you will get here. And here you can see that I'm inviting you to contribute to this repository. So what GitHub allows you to do is a couple of extra things. Number one, we can fork this repository. So for example, I have a friend of mine, Megan, and she forked my repository. So we can actually go over here and see that she, under her account, has a Talks with Dr. G folder or repository. So she made a copy, but this is called a fork because anything that she wants to push back will always come back to mine, okay? So she's going to fork it, and then she's going to make her changes. And then what she's going to do is create what's called a pull request. And a pull request is where she's requesting that I pull her changes into my repository, okay? So when she creates a pull request, she adds a title, she adds a description, and then I can also see all of the files that she changed. So she created a new file in the notes folder called megan.md. And this new file, she wrote this stuff here. I can approve these changes. Thanks for joining the talk. I can submit my review. And then I can merge these changes into my code. And so now, if I go over into my code and I head down into Start Dev Change and I go into Intro to GitHub, in my notes folder, I now have megan.md. And what's really, really cool about this is if you wanted to go in and do this, all you have to do is fork my repository by clicking this fork button up here. Then once you're in yours, so it says your GitHub username here with Talks with Dr. G, head over to this notes folder, click add file, create new file with your name.md. When you make those changes, it'll walk you through the process of like, hey, do you want to commit this back up and make a pull request? You'll say yes. And then when they get added, when I merge them in, you'll get added to this share board here. So this was my note to all of you. And this was Megan's note right here. So she added in a little GIF and she said, hey, it's me checking in. So everyone who's attending this talk or watching this later, you are welcome to kind of join us in this fun little experiment. All the instructions are here and feel free to reach out if you have questions. I know I've only got like, I think 2 minutes left or so. I did want to touch a little bit on OSS, open source software. So, sorry. Where am I? Oh, there we go. Okay. So software that gets built on GitHub publicly is often open source software. And so what that means is basically that they're not only building their code publicly, but they're also inviting you to contribute to that code base. Those contributions can be made in the way of creating issues, not creating problems, but issues are basically ways to say like, hey, I think there's something wrong with this. This is what like I ran into when I did these steps. So can you help me? And it can also be in the way of like adding features. One of the most important things to remember with open source is that the folks who are maintaining these projects are often doing so on the side. They're often not getting paid to do it. And or, for example, with the case of VS Code, which is an open source project, there are paid people working on this, but they are also working to build certain features. So every single of these like over 5,000 issues may not get addressed. So they also have a community of maintainers that help them out. That means that you want to be respectful whenever you're working with folks. So I just wanted to really quickly walk you through what it might look like. Number one is if you head over to an open source project, you can go over to the issues and you can click on labels here. Oops, sorry, I did not mean to click on that labels. You can click on label here and you can sort by something called a good first issue or help wanted. I usually like to go to good first issue. If you click on that, you're going to be taken to all of the issues where the team has marked those as these are great if you don't like if you're just getting started with the VS Code code base and you want to try to become a contributor of this project. So for example, we can head here and one of the issues that I discovered was this one. And it's been closed just recently because I just opened this one. But basically, this person said, hey, I've got this issue. This is how it happened. And then this person who's a community member said, hey, I want to try solving this issue. And then someone else said, sure, like this is where I would start. And they had a good conversation about how they might solve it. And then we can see that this person opened up a pull request. So remember, a change to say, I think I've got a solution to this. Do you think this works? And if that does, then that would end up closing out the issue. So we can see that this fix did actually close that issue and contributed back. So I know I'm pretty much out of time. Oops, wrong direction. The last thing I just wanted to say is, please head over to Microsoft Learn, follow aka.ms/intro to GitHub for that Learn module and also other modules. Make sure that you ask questions. I'll be hanging out on Twitch for the next 30 minutes. Make sure you check out the free certifications that we're offering with the Cloud Skills Challenge at aka.ms/startdevchange. I'm also part of the Reactor org, which we do live streams and pre-recorded videos. You can check us out, MSFT Reactor on Twitter. And finally, this is me at Dr. Guthels. Follow me on Twitter, ask me questions, I'm there. And also check out aka.ms/talks with Dr. G if you want to contribute to our share board. Thank you everyone so much for your time, and I'll see you in the Twitch chat.
That was cool, right? Community coding. It's fun because you don't have to know everything, and it's awesome. People who are good at front end stuff, make them do UI. People who are good at database backend stuff, make them do it. It's great.
Do you want to hear my horror story of finally committing to source control?
Yes, I actually want to hear this.
So I was an independent consultant, and I wrote some code for a company. They used it for like 20 years, right? It's crazy. Yeah. And I had an automatic code generator, and obviously not source control. So I hit the automatic code generator, and it generates the code for me. But it generated it in the wrong folder, and it deleted all of my other code. And it was at that moment, nearly 10, 12 years ago, that I decided I am always going to use source control for the rest of my life.
Very good.
And that's why GitHub is super important.
That's why it's super important.
Save your stuff, even your mistakes, because your mistakes of right now might be your, oh, I should go do that again of the future. You know what I'm saying?
Also, mistakes are a snapshot in time. So you make a mistake, you move forward, you make worse mistakes, you want to revert to last known good state. It's actually revert to last known least effed state. So that's really what it is. You know, it's like this ancient rule of debugging is go back to the last time it worked. We're like, go back to the last time it failed less than it's failing now. So This is you're getting a real behind the scenes on how people think and plan and debug and build. And yeah, it's not perfect because dev life, not perfect. There's a lot of mishaps. It's actually, I would say 99% mishaps and things work maybe 1% of the time.
Yeah, when it works, it's just like
I'm a genius. Yeah.
that feeling when you make something work for the first time after literally thinking you're an idiot forever is absolutely glorious.
The dev mood swings are a real thing. You go from, I am such a dumbass, I should never have a job, I don't know how I exist this long, I should quit this industry and go live under a rock and like take up moss collecting. That's like Monday morning. And then Monday afternoon, you like get a thing working. You're like, I'm a genius. I should start planning. I'm going to spend my billions. Is it on many yachts or just a single yacht? Monday evening, you're like back under the rock collecting moss again. It's just normal.
And the thing about it is you get good at like knowing like, honestly, like once you become good at tech, you basically start to get good at knowing that part's going to be a problem.
Yeah.
Right?
Oh yeah. And you learn resilience. You learn how to bounce back from the bad because you know it's going to be over at some point. You know how to learn, you know who to reach out to, and you know how to just keep it together and just work through the problems. So speaking of working through problems, I don't know if you heard during Sarah's talk about code spaces. She talked about that a few different times. And I saw a few of you Twitchlings chiming in and asking about code spaces. What is code spaces? So our next session is all about code spaces. We're not going to give away the surprise because it's an interesting concept and something we think all of you, especially the Twitchlings, are going to really like. Is Chris on the line? So Chris is not on the line, so we're going to attempt to find him.
So we just like stare awkwardly into the camera?
Just stare at you, no.
thumbs
Actually, just
up.
kidding.
He
Chris,
gave us
we
a
found
thumbs
him.
up.
He is found. Chris is here, and he's going to talk about code spaces.
All right. Well, good morning, good afternoon, good evening, depending on where in the world you happen to be. My name is Christopher Harrison. I'm a senior program manager inside of Microsoft Cloud and AI. And today what I want to talk about is Visual Studio Code and this upcoming release called Code Spaces. Now, the reason that the reason that we have Visual Studio Code and the reason that we have code spaces is partly because obviously we want to make it easier for professional developers, but also because of the fact that we want to help make learning code less intimidating for new developers as well. That one of the things that we hear quite frequently from students and from educators is this very common theme that what needs to happen is they need to go grab different tools to do different types of operations. That if I'm going to do JavaScript, I need this. And if I'm going to do Python, I need this. And if I'm going to do Go, I need this. And that gets a little bit annoying that we have to remember, oh yeah, if I'm going to be doing this, this is the tool that I'm going to need. If I'm going to be doing this, this is the tool that I'm going to need. Nobody wants to mess around with that. On top of that, there's oftentimes going to be different tools that need to be installed. And I don't want to have to go looking around for all of those different tools. I want to be able to get up and running as quickly as possible. And last but not least, I want something that's going to be modern, I want something that's going to be fast, and I want something that I'm going to be able to personalize. I want something that I'm going to be able to make my own. This is what we hear from learners. This is what we hear from people that are trying to code. And what we hear from educators, the people who are teaching the students how to code, is really a lot of those exact same things. That they like the fact that the courses are real world, they want to be able to use real world tooling, but that real world tooling can sometimes be intimidating. That you can have things where I've got all of this power, but unfortunately, a lot of times with great power comes great complexity. And so now what the student is stuck with, what I'm stuck with, is not just learning how do I do something in Python, but I'm also now stuck learning how do I use this tool. And that's a problem. And then on top of that, We want something that's going to be free. We want something that's going to be inexpensive, that I shouldn't have to pay $1,000, that there shouldn't be an entry fee for me to be able to become a developer. I want something that's going to be easy for me to install. And then finally, last but not least, is I want a tool that I can use to be able to collaborate. So that way, when we're working on group projects, or maybe I'm just stuck, and what I want to be able to do is to show my code to somebody else, that I can do that right from inside of the tool that I'm using. So one of the terms that I'm now going to introduce you to is, it's one of my favorites. It's this little term called rubber ducking, where what you do is you talk to a rubber duck. That simply the process of you saying something out loud will help you think the problem through, and then in turn help you be able to better resolve that problem. But of course, rubber ducking can only go so far. That sometimes you need to be able to show somebody the code, so that way they can get a little bit more insight as to what it is that you're building. And so fortunately, Visual Studio Code is able to do all of that for you. Visual Studio Code is available for free. Visual Studio Code is lightweight. Visual Studio Code will be able to grow with you, so that it's one tool. And this is a professional tool. I like to at least pretend from time to time that I'm a professional developer. And when I'm pretending to be a professional developer, this is the tool that I use. It's lightweight, but it can grow with me. And you're also going to notice there's a bunch of great extensions that will be able to make it easier for me to do all of the different things that I need to be able to do with my code. And what's also great is the fact that out of the box, it does sort of the bare minimum. It does what I need it to do and nothing else. And then when I go, hey, I really want this feature, where I really wish I had an extension, a plugin that did this as well, fortunately, I can go ahead and install that into Visual Studio Code. So it can start off very basic, but it can grow with you. One tool for all languages, for all types of applications that you might want to be able to build, and it's the tool that professionals use. Now, one of the catches with Visual Studio Code is the fact that this is still going to require a local install. And it's also then in turn going to require that, like if I'm doing Python, that I install Python, or if I'm doing Node, that I install Node, or whatever else it is that I might need here. And I, of course, need to install Visual Studio Code. Well, this is where GitHub Codespaces comes into play. Now, I want to highlight the fact that as of right now, GitHub Codespaces is in a private beta, but you can go in and sign up, and with a little bit of luck, they'll select you and give you early access to this tooling. And what we're going to notice is the fact that we're going to get Visual Studio Code, the exact same experience, but just inside of a browser. So that way, everything that I've learned about Visual Studio Code, I can now take with me into the browser, or I suppose vice versa as well. So that way, it's the exact same environment, regardless of where I happen to be. And that's fantastic. Now, if you're anything like me, and I know I am, you're probably going, okay, Christopher, all of that's wonderful, but I really need to see this. I really need to know how this works internally. Okay, cool. I'm glad you asked, let's get in and let's take a look at how all of this works. So what I've got right here is I've got my copy of Visual Studio Code up and running. And I want to highlight a couple of different moving parts here. So the first thing that I want to highlight is over here on the right-hand side, what you're going to notice is that I've got a little spot where I can see all of the files that I'm currently working on. One really cool thing about Visual Studio Code is that it allows me to open up a folder. So right here, this is actually showing me the folder that I've opened. So I don't need anything special here. All that I did here to get to this point is I simply opened up a folder inside of Visual Studio Code. And by the way, you could be able to do that by hitting File and then Open Folder. In fact, here, let's just File and then Open Folder. And now I can navigate to wherever that folder happens to be. That's pretty slick. And you'll notice that I've got my tabbed experience here. So I've got all of these different little files open, and I wind up behaving a lot like browser tabs. So I've got a little app.py file. I've got a little requirements text file. I've got a little gitignore file here. I've got my little welcome screen over here, which I don't actually need, so I can go ahead and close that out. So inside of my one editor, I can see all of those items right here. And if you've used a browser, this starts to feel a little bit more natural because after all, in a browser, we're going to have different tabs for different pages, different files, if you will. And I get that exact same experience here. And you can even start to do really kind of fun things that maybe I need two files side by side. Cool. Then you can actually just click on one of those tabs and then just move it off to the side here. You're going to notice that little gray space. And then when I click on that, poof, now my app.py is over here. And then I've got another file, happens to be my gitignore file, over here. Pretty slick. So now I can see both all of that side by side. And I can even like start to do all sorts of weird and fancy things here. Come on, there we go. Like I could put one file on top of another and so forth and so on. So you've got a lot of great control over how this is now going to work. Now, a couple of other things that I want to highlight while we're here. You're also going to notice that I've got a search button. So if I've got multiple files, maybe I've got a large application that I'm working with, I can then go in and do a search across all of those. If you happen to be using GitHub or Git, which if you've attended the prior talk with my teammate and one of my favorite people, Sarah Guthels, she talked about Git and GitHub. You get great integration right here inside of that tool. So you've got a lot of great power here already built in. Now, what's also pretty slick is, again, the fact that I can, of course, start writing code. Now, what I want to do here is I want to create a Flask app. Now, if you're not already familiar with Flask, let me bring this up real quick here. There we go. Cool. So here is Flask. Now, you don't need to know anything about Flask to follow along with what it is that I'm doing here. But in case you're curious, Flask is a Python-based web development framework. Okay, what does that mean? What that means is that by using Flask, I can start to create websites, which is pretty slick. So that's what I want to be able to do in this demo here, is I want to create a Flask application. So I've gone ahead and I've said, hey, Flask is going to be a requirement. Now, like I highlighted, I'm going to be doing Python development here. And this editor is going to give me full support for that. So if I make sure that I install this, I'm going to say pip install our requirements.txt. There we go. And again, this is a very common Python thing. Oh, what are you? Oh, sorry. Forgot where I was for a second. There we go, pip3. Now this will install. See, I'm really coding here. See, these are things that happen to actual developers. Actual developers, real developers make mistakes. So I made a little mistake there. I just typed in pip instead of pip3. Okay, so what did this do? This installed Flask for me. So now I'm able to now use this package, which is fantastic. So now I could go over into my app.py, and now I could start to add in my code. Now, I happen to know what the code is supposed to look like off the top of my head, because I've been doing this for a while. But I don't necessarily always want to type in everything that I'm going to need. There's a friend of mine who loves to say, we're not launching rockets here. And the point that he's making when he says that is whatever it is that we're doing, somebody else has already done it. Somebody else has already struggled with it. And in today's community-driven development world, chances are somebody has already created a tool for us that we could go ahead and use. And in Visual Studio Code, those tools are going to be known as extensions. Remember what I was mentioning before about Visual Studio Code being able to grow with you and you being able to add on different things that you might want? All of this is done through extensions. And I can search for extensions right here. And so I could go in and do a search for Flask, because I know that this is what I'm going to be doing. And then now this is showing me all sorts of great little extensions that I can now use. Let me get rid of that little item right down there. That way we can see this a little bit better. So here are my, my Flask snippets that I can now use. All right, well, what's a snippet? A snippet is a little snippet. It's a little bit of built-in code that I can basically just call whenever I want. It's sort of like an advanced copy and paste. So what this extension will do for me is it will give me a lot of these great snippets. So this way, I don't need to keep writing that same bit of code over and over and over again. Instead, I can just count on these snippets. So let me go ahead and click install locally. Let that do its install. Tells me that it's now enabled globally. I might have to close and reopen Visual Studio Code. We're going to see here in just a second. It doesn't say that I do, but a lot of times you do. So let's see. I'm going to type in HW. Cool, I don't. Now, what you're going to notice when I type in HW here is right here on the little bit of IntelliSense is I can see that HW there that's now in blue. And then I can see this little piece of paper that's being torn at the bottom. That's what that icon is designed to represent. That is a snippet. And so now I can go ahead and just choose that. Let me just click on that. And then poof, there is all of my code. So just like that, I was able to get all of that code built right in. That's pretty slick. So in 2 letters, I wrote out, what are we going to say, 7 lines of code? That's wonderful. So now let's go ahead and let's just test this here. So I'm just going to say Flask run, which is going to start this. There we go. And let me click on that little link right there and let that open. Get a sip of water. And there is Hello World. So this is now an official programming demonstration. We did Hello World. Okay, now we did all of that locally. What happens though if I don't want to install all of this locally? What happens if I want to be able to do all of this through a browser? Well, I'm glad you asked. So what I've done here is I've just gone over to GitHub. And again, Sarah talked about this in her prior demo, but if you're not familiar, GitHub is a place for me to store code. And what I do is I store code inside of what are known as repositories, which are sort of like fancy folders. So if I click on code spaces here, and I click on create my first code space, it's going to ask me to choose a repository here. And I'm going to say start dev change. There we go. And code spaces. That's the one that I want. I can see there's a lot of people doing start dev change right here. That's fantastic. That's wonderful. And then my default branch, oops, I don't have a default branch yet. Not a problem. Give me 2 shakes here. Let me just create a brand new file here. Readme.md. Okay. Boop. There we go. By the way, sound effects help. You have to make sound effects. All right. Start dev change code spaces. There we go. Cool. Now let's go ahead and click create my code space. So here's what's happening. This is like pure magic. This is now in the cloud setting up a Linux box for me with Visual Studio Code. It's going to have Python. It's going to have Node. It's going to have Go. It's going to be all set and ready for me to go. So I'm just going to give this another moment here to finish out. So just chugga, chugga, chugga. And hopefully I can stall long enough for this to, there we go. Come on. Perfect. Wonderful. Okay. So now I can literally do exactly what I did earlier. So I can go in and start creating brand new files. So let me create that requirements.txt file that I had earlier. And let me add in Flask just like I had and do the exact same install. So pip3 install r requirements.txt. This is exactly what I did locally, did the exact same thing here. Cool. Now let me go in and create my app.py. Now, one of the things that you're going to notice here is this is a brand new install of Visual Studio Code. So it's going to go, hey, wait a minute, I need something to be able to help you out. So do you want to go ahead and install, in this case, Python? Well, yeah, as a matter of fact, I do. So I'm going to click install, installing, and then it is now installed. Okay, and that one I'm not too worried about. And now I can go ahead and just get rid of that. And I don't really care about that. Okay, cool. All right. Now, if you also remember, I used another extension here. I used a Flask snippets extension. So what you're going to notice is I'm going to be able to install that right here. So I'm going to click install. And that is now installed just like before. Oh, and by the way, you remember all of those cool things that I was able to do with moving files around and having them side by side and all of that? I can still do that right here. And if you want to go in and, change your theme, so let's say you're, more of a dark fan or whatever it is, that you can still go in and do all of that inside of here, which is fantastic. And so now, if I type in HW, again, you're going to notice, I don't care. Again, you're going to notice that I get that little snippet. Again, you're going to notice that I can just choose that. And then poof, there is all of that code into letters. You're also going to notice if I run this, just like I did before, Flask run, that I am going to be able to view this remotely as well. Now, this does do a little bit of port forwarding and magic and all sorts of other things to make this available, because none of this is running locally. All of this is running in the cloud. And oh, by the way, if you remember that little thing that we were mentioning before about being able to share things out, one of the things that's really cool here is I could click on Start Read-Only Session here. Come on. Why are you not working? This worked 2 seconds ago. Oh, that's funny. Okay, in any event, what should happen here, I'm not sure why this is not working, but that's all right, is it should then give me the ability to share out my copy of Visual Studio Code. In any event, what we saw there is the power of Visual Studio Code. And so now, what are your next steps? Your next steps are to go check out Visual Studio Code. You can download this from code.visualstudio.com. You can go sign up for that Codespaces beta so you can have all of this in your browser by going to github.com/feature/codespaces. And then finally, down there at the very bottom, you can learn more about Visual Studio Code on Microsoft Learn by following that aka.ms link. Hopefully you picked up a little bit about Visual Studio Code. Again, this is the tool that professionals use. This is a tool that will grow with you. It's a tool that you can add extensions to. It's a tool that you can use regardless of the type of development that you're going to be doing. I'm going to head on over to the Twitch channel with everybody else, and you can come say hi. You can come ask questions to me over there. Again, my name is Christopher Harrison. You can find me on Twitter at Geek Trainer. And thanks for tuning in. Enjoy the rest of the show. Enjoy the rest of the show.
Clean. No link. Hello. So it's just me. Our microphones died or something happened. I don't know, technical difficulty. Can you hear me now? I'll check the chat.
I'm still here too.
Seth is here, but no one can hear him. So this is a blessing that we all asked
cut my
for.
mic.
Yeah, so Seth's mic got cut. Okay, so that was a cool presentation by Christopher. Thank you, Chris. Codespaces is in preview, as you saw. And Chris also said the most dev statement ever, which is, "This is amazing, it should work. Why aren't you working?" in a fit of rage. So if you haven't done that at least once, you're not really living the dev life. But the first time you have that moment of why aren't you working in a full-on rage at this device that's supposed to make your life better, in fact, it's making it worse right now, that's when you know you've reached peak devdom. So we are coming up on our next presentation, and I'm really excited about this one because one thing that every app and every website and pretty much anything you build needs is going to be a data source of some sort. Now, a data source can be something as simple as here's an XML sheet and you pull information from it and display it to the user. Or it can be as complex as, like any data source that you've heard of, like SQL or Salesforce, or all of these are all data sources that are used in the world. And our next presenter, Jasmine, is an expert at databases and data sources, and she's going to walk us through an introduction to what that looks like in a few minutes. So we'd love to hear what you think of this event. So many of you are chiming in on Twitch telling us that this is interesting, this is complex. Keep giving us the feedback. As you know, Start Dev Change, this is the first event we've ever had of its kind here at Microsoft, specifically for beginners, learners, people who are students of life, but not necessarily students in school. So we are really enjoying this event. We're learning a ton, and we hope that you are as well. So if you are enjoying this, if you're not enjoying this, give us feedback. Send us feedback via the Twitch links or via Twitter or whatever other communication channels you have.
I'm still here too, just FYI.
So Seth is yelling that he's also here and we're continuing to not
I'm
listen
trying to
to
get
him.
into the mic somehow.
He's loudly yelling, so hopefully he'll be heard. Okay, so anyway, Jasmine is here with us to teach us all about data sources. Over to you, Jasmine.
Brooklyn, New York City. So I am on Eastern Standard Time. So I am so happy to be walking you through some introductory database concepts and databases. So we're going to go ahead and get started. So today we're going to cover why data is such a precious resource, why it's so important today, why folks love to use it in the cloud. Then we'll go into some specific types of ways data is managed. First, we'll look at databases, first relational, then non-relational. Then we'll look at some other ways data is represented in the cloud. Then we'll continue with a demo, and then we'll wrap up. So you've probably seen this photo before, but this kind of speaks to how precious of a resource data is. So normally when you need to store data somewhere, it's usually stored on a server. But many companies and other platforms and applications rely on things called the data center, and these are just basically facilities, just like a building, which manages all the hardware for you. So the server is usually that piece of hardware where the data will be stored. So because if a server has, if there's a lot of data in a company or a company managing a lot of data, it's a lot to maintain on a server in a house or in a company. So they rely on data centers to manage this data for you. So in this picture here, one of the things about data centers is that they take up a lot of resources. We're talking power mostly, and also just space. And so what this experiment here that Microsoft researchers went to kind of look at is how to reduce the carbon footprint in these data centers. So this was taken, I believe, around this summer, and this is off the coast of Scotland. And what they did is they took this data center and put it underwater to test for 2 years. And I believe this was done in 2018, and over 2 years, they kind of measured performance. And this is them taking it out, and they realized in their findings that this was a really great, efficient way to manage a data center. So what that means is that it'll be very interesting to see how data centers evolve over time now this experiment has come out. So data is, again, an important research source, and it's so important because so many of us are on the internet. In fact, 2/3 of the population are on the internet. That's 4.6 billion people, 200 million emails per minute. Out of all those, out of that population, 3.7 have active social media accounts. So that's about 480 tweets a minute and 60K Instagram posts per minute. And out of that, 2 billion people shop
1, 2, 3, 4, 5, 6, 7, 8,
online.
9, 10, 11, 12,
By
13,
2040,
14,
that 95% of all purchases will
17,
be made
18,
online.
19, 20, 21, 22,
And finally,
23, 24,
by 2025,
25,
keep in mind that's 5
26.
years from now, it's predicted that all this data that is kind of moving around the world is going to reach 175 zettabytes. I've never heard this measure before, so it sounds pretty huge to me.
What's that?
And it's so huge, in fact, that it'll take at least
And you can leave the camera on when
1.8
it's not
billion
working. That's
years
fine too,
to
dude.
download. So that's a very, very long time.
Yeah,
So as you
what's
can
hilarious?
see,
Everyone
data is
thought it
all
was
around us.
hilarious.
It's in abundance, and we have to know ways and have ways to be able to work through it, sort it, and analyze it efficiently. So one of the ways that a lot of people rely on is the cloud to store their data for them. So the story of storing data in the cloud also starts with the data center. And what is so great about having someone else manage, or another way to manage your server, is that any devices and machines, they need maintenance over time. So think about your cell phone. Whenever you need to make an update to the firmware or the operating system on your phone, you have to run an update. So normally I have an iPhone, and normally the way that works is that I have to wait for it to install and then restart. And so same case with a lot of our computers and any other devices that we use, and the same thing with the server. But the benefit of using a data center or specifically the cloud is that these things happen automatically. So any software maintenance, any hardware maintenance happens automatically with the intention of no interruption. So say that someone might be accessing data somewhere on a server, and maybe somebody who's working in a data center is doing some updates or fixes to hardware in that data center. The people who are using that data should not realize or not notice any interruption. And in the same way, when things are going wrong, fault tolerance, this term that we use to talk about managing disasters or when things go wrong, is supposed to be able to support situation where these things go wrong. So for example, if one of these data centers were to go down, you should have a copy of your data in another data center, either somewhere else in the data center or in another data center, so that end users, including yourself, are able to access your data without any interruptions. This also is great for when you have high traffic situations. We call that scalable. So this data is able to reach the demands of either from 1 to million number of end users. Also, when you are trying to access a file of a different type on your phone, for example, let's use Excel. So in Excel, you usually use the Excel app either in the browser or on your computer, and say that you want to look at this spreadsheet on your phone. So you could look at it in the browser on your phone, or you could download the Excel application onto your phone and be able to look at it through there. So in the same respect, a server will need different types of maintenance and also different configurations to be able to support different data types. And the benefit of the cloud here is that all of that is managed for you. So all you have to do is pretty much pick the service in the cloud that will be able to host and hold and manage your data for you. So on that note, we're going to go on to the first type of data storage that we're going to talk about, and that's databases. So relational databases organize data into rows and columns, and this data lives in a table. Now, the schema is essentially the blueprint of how this data should look in a table. And in some cases, these tables have some sort of relationship with each other. So on the right here, what we're looking at is an entity relationship diagram. And what it's doing is describing this, the relationship between these squares, which are the tables. At the top of there is the table name. And then in the white part of the box is the columns or the fields. And it's explaining and it's describing the database of a library. So you'll see normally entity relationships diagrams when usually there's a huge system, kind of like a library and things like that, to really describe the relationship between tables in a database. Now, there is a case where some of these tables will not have relationships, and that's okay too. But the way that these relationships are set up are through things called keys, and those usually reference a specific column that two tables have in common. So to kind of summarize relational databases, databases store tables, the tables store the columns and rows, and the schema defines how the data will look, and that includes the columns and how the rows will look. And the rows are going to be the individual piece of data that represents the columns. So whenever you want to grab data from a database, anything, like that could be all the data, or that could be a specific piece of data, you're going to use a query. And this is just code that you write in a specific language, depending on the database, type of database that you're using to grab this data from the tables. So on the right here, we are looking at a screenshot of SQL Server Management Studio, where the database that we're using is called Microsoft SQL Server. And here we're running two queries on some customers and some orders. So here, this is a little bit of a more involved query, but you can see at the bottom here the results of these queries. So the first one, that first set of rows is that first query, and the second set of rows is, or second query is that second set of rows. So this is being run on a desktop computer, but also you can also run these in the cloud. And some common databases are going to be MySQL, again, SQL Server, which is also called Azure SQL in the cloud, and also Postgres. That's only just to name a few. So another type of database is called NoSQL databases. And this is for data that won't traditionally fit into this row and column format, but will usually take on a hierarchical view in a set of collections. And the individual piece of data are going to be called documents. So on the right here, we are looking at an example of a document. So a collection will hold a set of documents, and those documents will have keys that describe what kind of data should be in that key, and that points to that type of data. So on the right here, that first key there, first name, is holding the value Paul, and then we can also add some additional information. And one of the really great things about NoSQL databases is that they don't really follow a schema. So if you need to add additional key here, so for example, say that there was a key for the person's address, you could essentially add it right there into the document. But in the example of a relational database, you're going to have to add another column. And sometimes that can add some complications depending on how the database and the table itself were built. So let's talk about some different ways that data is also represented. Databases are not really the only way that you can manage and store data. So data can also be files. And in computing and cloud computing, we typically call this blobs, and that stands for binary large objects. And so a blob could be an image, video, or spreadsheet, pretty much anything that really wouldn't fit into any sort of database. Another type is semi-structured data. So if you have ever worked with JavaScript before, you've probably seen JSON, which stands for JavaScript object notation. XML and HTML is also a version of semi-structured data, because HTML is, yes, a document, and so that's data, but also inside of an HTML file, you have the structure of how the document should look on the web. So semi-structured data has some sort of structure, but it usually does not fit into a database. Now we're going to continue on to the next slide here, and this is going to be the demo. So this demo is going to be a guest book. So for those of you who might not know what a guest book is, this is, if you've ever been to anything like a wedding or an event, or even stayed at a bed and breakfast or a hotel or even Airbnb, usually there'll be a guest book around. And what a guest book essentially is a way for visitors to write down their name, where they're coming from, and maybe a message in the guest book as well. And this is just, for, safekeeping, just kind of a way to kind of record someone's moment, a special moment in time. So when I was when I was younger, starting to use the internet, I remember guest books as one of the most, aside from chats, as one of the most easiest ways and coolest ways to interact with the website, because you're kind of leaving your mark on the site as if you were leaving your mark on a guest book. So what I've done is I've made a digital guest book of my nostalgia to kind of illustrate how databases work in the cloud. So if you go to the short link here, you can also chime in and sign my guest book as well. So now we're going to go on to my guest book here. And if you end up running into any issues, if you get any errors, be sure to just go ahead and just give it a refresh. So the way this is working is that when you enter your name, so you can see I've been doing a lot of tests here. I'll just do a test here. Hello, SDC. And I'll put my name in here. And if I'll decide to insert it into MySQL. And looks like it's a little buggy, and that's okay. So if I refresh this page here, let's see if I can see if anyone has sent any messages. And looks like there's lots of messages in here. I've forgotten about all about desk books. Thanks for taking me back 20 years. Oh, hey, thanks, Joseph, Surly Dev, Arnav. Hi, everybody. Oh, this is so exciting. I love this. So this website I've deployed on Azure, and it's using a technology called WebSockets to give me real-time updates on my guest book. And notice that depending on what entry you make, it'll tell you if it's coming from MySQL or Cosmos DB. So let's look at this in the cloud. So I'm going to just refresh this here. So let's give it a refresh. Actually, it should be fine. I'll just refresh it here. And I'm opening the Data Explorer. Now this service is called Cosmos DB, and it's a way for you to manage NoSQL data. And one of the coolest things about Cosmos DB is that you can decide on what type of API you want to use. So one really popular NoSQL database is called MongoDB. And that's what I'm using here. So MongoDB has this setup of keys and values, and you can see this is kind of what my data looks like in the cloud here. So let's see another example of this in the cloud, but I'm going to use another SQL management studio here called MySQL Workbench. So I'm using, again, as I mentioned before, I'm using MySQL as my relational data and Cosmos DB as my NoSQL database. So what I'm doing here is I'm just going to run a query here. Notice that my select star from guestbook query here is really simple. So what this is going to do is show me all of the entries inside of my guestbook that I have here. Woo! Wow! Awesome! Oh, it works! Yay! I'm so happy. Thanks y'all. Thank y'all for helping participate in my demo here. I'm so excited. Awesome. So one thing that I want to just mention about databases in general, like things like MySQL and SQL Server, is that there are ways for you to set up your database to be transactional. What that essentially means is that, say that maybe you're inserting a large number of rows into a table, and say that something goes wrong, there are ways for you to kind of roll back all the work that it did, so that you don't have anything like data overlapping or any data loss. So that's another really cool thing about databases in general. Another thing, really interesting thing about the cloud is that these data centers are in, all over the world. So, and one of the coolest thing about Cosmos DB is that it puts your data closer to where you can set your data closer to where your users are, and that kind of helps with things like latency. So your data approaches either you or any users faster. So that's it for the demo. But I just want to go back to the slides here and kind of talk to you a little bit about the resources that I have here. So in here is a link to the demo that I did, and it's a repo where you can kind of deploy these databases yourself and run it locally. It's built in Node, and it's still a little bit of a work in progress, so it might be a little buggy. So if you decide to fork it or make a copy of it or clone it, just be aware that I might be making some more updates to it. Because as developers, we're always trying to make things faster and more performant and improve on it. So yeah, and if you have any questions or or if you notice a bug, please feel free to add an issue in that repo. There's also more resources in there for you as well. And if you're interested in learning more about databases in general, and specifically, this link points to a relational database in the cloud that's very popular on Azure called Azure SQL, and it will walk you through kind of how to work with the Azure SQL database. So definitely check that out if you are interested. In addition to that, you probably have already heard about the Cloud Skills Challenge, but I would highly recommend that you definitely go and participate, because you can get prizes, and you can also get certifications, and you also can and you can also learn more about either the data or whatever is of interest to you in the cloud. And I will be on Twitch in a little bit here to answer any questions or concerns or comments that you might have. So definitely check out the Microsoft Learn TV, and also check out the Microsoft Developer Twitch. And I will see you there. And I just want to end with the 2 links that I was mentioning earlier. And my handle is Paladeep. That is on Twitter and on GitHub and on Twitch. So you will see this handle on Twitch in a little bit. So thank you so much for participating in my demo and for coming listen to this talk. It's been an honor. I always love interaction with you all. So please feel free to leave an issue on my repo or leave or chat with me in Twitch. So bye. Thank you so much.
All right, is my audio working again? Apparently my audio was leaking.
Mm-hmm. First it was cut off, then it was leaking.
So FYI, I was counting because they were like trying to fix. I'm so glad I didn't go off like on a rant or something. That would have been really awkward.
Yeah, he's like, I hate events, I hate tech. Blah.
Yeah. So Can I tell you something that happened? I'm a database. I love databases, and I was sitting in a restaurant one time, and there was this other database administrator in another, like just right next to me, and he came up to me and he said, "Hey Seth, do you think we can join tables?"
See, as soon as he starts up on a story, you know it's going to end in a horrendous joke. So Twitchlings, please. Do not encourage him. You're all encouraging him.
That
this
was
is why
awesome.
This is so bad.
Everyone walked into that story
So
and was
bad.
like, "This is going to be the greatest story
No,
I've ever
except
heard."
like we're cringing here in the studio because we know Kel horror
No,
is
they
about
like
to happen.
it. The Twitchlings like it.
Wow. Okay.
By the way, if you did not get that joke, it turns out that I'm going to explain it because we got, 7 minutes?
He's not going to explain it, but you're
So
really gonna
basically,
explain this.
in relational theory, the reason why you would join tables is to get better. Like, for example, you might have a database full of dogs, right? And you might want to have another table that has like the breed of dog because you don't want to repeat data. And when you join those tables, you basically get the dog and the breed. That's why when I was at the restaurant, the guy was like, "Hey, Seth, should we join tables?" I think it's better the second time.
Okay, so you all are enjoying the conference. You're enjoying the content. Thank you for all your comments.
Hold on, someone tell him to drop it.
Drop it. Drop it.
Get it? No, like
Stop.
drop the table.
Stop.
Because they did
No,
all
I
caps.
get it. I get it. Stop. This is bad. This is bad.
There you go.
There you go. Oh my God.
I love databases, by the way.
He
It's one of
does.
my
He does love databases. So I think what's so fascinating about today is we're covering all of these aspects of computer science. If any of you have ever tried to study computer science or studied computer science, these are all intro classes in college, and they're really, really very, very dry there. And it's all done in this professorial, academic, textbook, read like. This database course that Jasmine just taught in 25 minutes, I swear we covered for 6 months out of a 700-page book. What about you, Seth?
Yeah, so I'll be honest with you. And I'm not going to tell you what school I went to, but I was in grad school, or the professor. The professor, because our good database teacher, she left, right, to NYU. And so I was a TA for this dude, and he's like, "Hey, TAs, I'll be honest with you. I don't know anything about databases, but I'm teaching the class." And I'm like, So basically I had to write all the assignments myself and grade them. And one time I showed up to the class, literally 300 people, 300 people. And I'm sitting there and I'm like, okay, let's get into relational theory and blah, blah, blah. And I'm doing on the chalkboard, you know, a professor. And they're like looking at me like I have two heads.
Yeah.
And I'm just like, do you not understand any of this? And they're like, no, the guy just reads out of the book.
Yeah.
I'm like, oh, jeez.
Uh-huh.
All right, so what do you understand? And then I went to the beginning and literally started like going through
This
all
is
of
a
it.
table.
Just like Jasmine did,
Yep.
but better.
But not better.
No, but she did it better.
Yeah, she did it better.
She did it better.
She
That's
did
what I'm
it-
saying.
yeah,
Jasmine did it. Like,
she did
because
it better.
Not only did you all like get to participate and see multiple styles of data, it was legit, right? And so I'm pretty excited to be her colleague, incidentally. She's awesome.
So is computer science being taught differently in schools nowadays, in universities? I don't know. I haven't been in so long. So if any of you have done computer science or are doing or thinking about it, please chime in and tell us. Are they still teaching it boring in a way where people leave the industry, or are they actually making it compelling, a group project where people collaborate? The way it is in real life, by the way, no one sits in an office and codes alone. That has not happened to us, like what?
I'm getting here, it's beyond boring.
Oh, it's still beyond boring?
I don't know, where I taught,
No, you have to learn
where
it
I
yourself.
taught, we had our, like the seniors in like the college seniors, because I was in grad school, I was a TA for a class where we literally put them in groups and they had to build a video game. And that was awesome.
That's cool.
That was awesome. And one time, no joke, I was doing a Channel 9 thing at Build, and so the guy that does WSL, he's sitting there and he's just looking at me and he's like, "Seth," I'm like, "What? You were my TA in that class." And I was like, "What?" Don't tell everybody that was awful.
Wow.
Because we're on TV right now.
They're like,
he's like, okay.
Seth's
and he's like, "But
TA.
Seth, it's not real TV, it's internet TV."
Internet TV.
So.
Okay, so let's have a look at the Twitterverse to see
All
what
right,
you've
let's do
said
that.
there. tweeted us, #StartDevChange, to show up on the Twitterverse so we can talk
From
about
Jenny.
it. Hi, Jenny.
Tech difficulties or virtual dance party?
Yes.
You decide.
That was us. That was us. Tech
I don't know.
difficulty.
I feel like if we broke out and dance. Sorry if I'm interrupting you. I can't hear you in my ear.
Oh, it's fine.
I feel like if we started dancing, if it's during lunchtime for you, you might have a hard time keeping it in.
Yeah, this is true. This is true. So let's go with tech difficulties. It's better than virtual dance party.
All right, so let me tell you what's coming up. I'm just going to go down because we want you to stay. There's a bunch of good stuff. We're going to go with Burke Collin next. He's going to do an intro to an API. What is an API? Dude is hilarious. You think I'm funny. He is a little bit less funny, but still pretty funny.
So, Burke, we're going to be really happy to see him. By the way, I have a weird-ish related API story. So I was having lunch with a friend of mine who's a journalist, and it's not tech journalism, it was more in editorial lifestyle. And I asked, what annoys you about tech people or tech in general? And she said, all of you seem to be trying to make us feel stupid. I said, what do you mean? And she said, oh, you'll drop random terms like, oh, I made this API public and I used a connector to connect to it. And I'm like, right, that's what we did. And she said, those words don't mean anything to anyone. In the real world, no one knows what an API is. And I said, how is that possible? It's an application program. She's like, don't define it. It doesn't make it better. So I was really happy that Burke is going to actually put the session on because it's one of those basic constructs that once you learn it, you realize it's everywhere and every company creates them so people can connect to their data and their information.
It's like that episode of the IT Crowd where they're like, so what does IT stand for? And everyone was like, I don't know.
Exactly.
Honestly, I'm the dude in every meeting when someone puts out an acronym. I'm like, what does that mean?
What is that?
Even if I know what it means, I'm like, I don't know what that means. Tell me what it means.
Yeah, most of the time I forgot, so that's fair. Okay, enough of us. Over to Burke talking about what APIs are. Welcome, Burke.
Well, hello, everybody. How's it going? It's just another afternoon in Nashville when we all play our guitars. State law. Well, thank you for joining me today. My name is Burke Collin, and I want to talk with you about the question that I know that's probably been burning in your mind and your soul all day. That question that keeps you up at night. That's not the question. What is an API? I think this is an important topic to discuss because I had a really hard time with this when I first started programming. I was around during the jQuery days when jQuery first came out, and jQuery had an API. And I was working with .NET, although poorly. And it also had an API. And then all of these services like GitHub also said they had APIs. And these are three entirely different things. And it became very confusing to me to understand exactly what an API was. It seemed like everything was an API, but how can everything be an API? If everything's an API, then nothing's an API. It's very confusing. So let's just start at the start. Just begin at the beginning. An API is an application programming interface. It's an acronym. For some reason, in computer science, we can't do anything without acronyms. You'll see a lot of them. It is yet another acronym. This is not super helpful in understanding what an API is. So let's make it worse. What does Wikipedia have to say? I'm going to read it out loud just so you can be as confused as I was. An application programming interface is a computing interface which defines interactions between multiple software intermediaries. They said at a party to look very cool. Now, I point this out because one of the things that I want you to take away from this session is that topics that seem complicated usually aren't It's usually that they're being explained in language that you don't understand. This is a great example of that. And I bet you don't understand it because I don't understand it. So my goal with this session is to break this down into language that you can easily understand. I read a book once called Making It Stick. And the idea in the book is that you need an analogy for any concept, an analogy that you already understand. So for instance, if you wanted to pitch the movie Alien to a Hollywood studio, you could try to explain what it is, or you could just say it's like Jaws on a spaceship. And that's a concept that maybe the studio could understand, and they would make your movie, and it would be terrifying. That movie is terrifying. So let me break it down to a concept that you might be able to understand. Think about how your plumbing works. When you need water, you go to the sink, you turn the handle, and water comes out. You don't really have much of an idea about how the water got there. I mean, you know that it came from pipes that are in the wall or the floor or somewhere, but you don't know where they go or what they look like or how the water got to those pipes or where the water came from to begin with. The sink is the API between you and the water and the pipes and the plumbing. It's how you interact with your plumbing and with your water. So I want to rephrase this whole API thing a different way and define it like this. It's the way that your code talks to other code or services. Feel free to plagiarize that and make me famous on the internet. I would appreciate it. There are 3 types of APIs that I want to cover today. There are your code. Your code's an API. You build APIs. You may not realize you're building APIs, but you probably are. There's other people's code, libraries, dependencies that people have created that you're using. And then there's web services, which are also a kind of API. So those are the 3 main kind of APIs that I want to cover today and look at in depth. Okay. Have we seen enough slides? Are we good? Yeah, I like the steering wheel analogy too. That's pretty good. No, I know that you're not idiots. I'm explaining it. I'm explaining it from the start. Not everyone knows what an API is. And honestly, it did take me a long time to wrap my head around what an API is, and even longer to wrap my head around how to not get text to wrap in PowerPoint, as I'm missing an O. Okay, so let's jump over and take a look at what an API is. So I'm going to start at the very beginning here. Now, let's say that you're writing some code. And let's say, for instance, that you're going to write some code to reverse a string. So maybe we have a variable called message that says hello world, because apparently that's the only thing you can do in demos. We want to reverse that string. The string by default in JavaScript has an API, and this is it. These are all of the different things that you can do with a string. But there's no reverse method. Okay, so maybe you want to create a method to reverse your string. So you might do that. I don't know. How could we do that? We could create a function, right, and call it reverse. And then we could take in some sort of an argument here. Let's say it's the message. And then what's the quickest way to reverse a string? Maybe like this, and then we could split it, right? Which would split it, make it into an array. If we split it like this, and then maybe we could then take this and reverse it, which is an array method. And then maybe we could join it back together. Maybe this would work. Okay. And then we could call this function, right, and reverse our message here. As in, we'd have to change this. This won't work. But oftentimes when you write code, you don't put it all in the same file. What you want to do is you want to split this out, right? And so maybe you create a whole block of code. Maybe it's a different file, right? And let's call that file, I don't know, maybe you call it utils.js. And then inside of that utils, let's say that you create a, let's see here. Let's see that you create a snippet to do that. Let's see, let's grab our snippet. Snippets. Well, it's called utils. Utils. Oh, my snippets are not working. No suggestions. All right. So what you might do is you might do module.exports and then some sort of an object. And then inside of that, you might have a function called reverse, which takes in a message, and then it reverses that message in here. We're going to reverse the string. Okay. And then what you can do then is you can take this and you can import it into your code. So it would be like const utils equals require, and then utils like this. And then because VS Code is so good, we should be able to see that there is now a reverse method on the object. So at this point, we've created a utils method with an API. So this is our code, and we've now created an API. So this is how APIs would be in the code that you write. But there's code that you use that other people write too. We're using JavaScript, so let's open the terminal and let's install something. Maybe like, I don't know, Lodash or underscore, Lodash or underscore. Isn't that always the question? Let's do Lodash. So we'll install Lodash, and Lodash is a dependency that someone else wrote. And in fact, I believe his name is John David Dalton. With the help of many open source contributors, I'm sure. But yeah, Lodash, how do we use that? Well, if we pull in Lodash here, you see that it has an API, and these are all the different things that it can do. And so this is the API that you might use with other people's code. All right. But sometimes, a lot of times, you might use an API to interact with a service, such as a database. MySQL, Postgres, MongoDB. In my case, I have a database. Let me show it to you. It's here. Databases. This is a Cosmos DB database. It's right here. And it's got some products in it. Products and brands. Very, very exciting database. Now, what we want to do is get the data out of this database and create an API to do that. So how do we do that? Well, first, we're going to need some code to get at this database. And so Cosmos DB has an API that you can install. And I happen to know what it is. So we can install npm I, which is short for install. I probably should be specific about that. And then Azure Cosmos. And this is us installing the Cosmos DB API. We don't need quotes. Let's do that. We're installing the Cosmos API here. Blazing fast internet today. I love it. And now we can use that. So how do we use it? Let's bring it in. Cosmos equals require Azure Cosmos. Okay. Now let's start to build this up a little bit. So we need a new client, a Cosmos client. So let's get a client going. Client equals Cosmos. Oh, you know what? We need a new Cosmos client. And you can see we are using new Cosmos client, the API. And the nice thing about the API is that it tells us, what our options are. So let's select the item there. And then it wants a connection string. Let's get that connection string. We can do that. Let's get rid of this. But just right-clicking this and saying copy connection string. Is that not the greatest feature you've ever seen in your life? Copy connection string. I love it. Let's just put it in there, right? Don't look at my connection string. It's private info. I trust you. I trust you. And then let's create a new database here. And again, we're using the API. Maybe we don't know that it's a database, but the API tells us so. And then it tells us the ID of the database. And ours is called Tailwind, I believe. Yeah, that's right. And then we need to pick a container. So let's do that. Let's say container equals database.container. There it is. And let's look at products. All right, we're cooking with gas. Now let's get at these products. How do we do this? We can do container.items.findAll.readAll. There we go. .fetchAll. There we go. That's going to return a promise, which has a response. And then we'll just log out some of the stuff that we've got here. Let's say response dot, I don't know, resources. That looks right. All right, so we basically just use the Cosmos DB API to create a program that will read our Cosmos DB database and spit out all of the products from the products container. Let's try to run this, see what happens. Let's just say node index.js. And boom, there they are. You can get a yellow hard hat with a tool bag pack. Sounds amazing. Rechargeable screwdriver. How about a rechargeable mic with an extra battery, Seth? Okay, we'll let that go. Now, this is how you can use an API to call a service that's, remote and in the cloud. But a lot of times when you're building APIs like this, you don't actually want to do this in your code and then give this to someone. And the reason for that is because they would just be able to see your endpoint. And so instead, what we do is we create web APIs that we can call, and they securely hold information like this. So I'm going to do that. And I'm gonna let you drink from the fire hose today. We're gonna create a new project here, and we're gonna make a serverless project, and we're gonna call it. Actually, let's put it in a folder called, I don't know, what should we call it? API. Let's put it in API, and we'll do JavaScript, and we're gonna create an HTTP trigger, and we'll call this get products. Amazing. Anonymous authentication for now. We might want to implement our own authentication in the future. And so what this does is it creates an endpoint that we can call that might return some data. So what we really want to do is expose all of this via our endpoint. So let's bring this in and just, I don't know, let's just pull all this out. Let's just paste this in. Let's take this line and move it up. There we go. It's starting to look like some proper code. Let VS Code format it for us. Oh, it doesn't want to. Okay, and then down here, instead of doing a promise, what we could do, because we're in an async function, which is here, so we have this special ability to do this. Watch this. We can just do response equals, and then we don't need this. We don't need this. We don't need a promise anymore. And then down here, we could say response dot, and look, there's our resources. All right, so we changed it up a little bit. And it actually, I should have put in a wait here, and I didn't. And VS Code was smart enough, and it was like, nope, 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 that won't work. You want to await. But that's kind of a hard code to understand. So let's change this around. Okay, I think that'll work. Looks like it'll work, right? But my endpoint's actually still in here, which I'm not a huge fan of. So I want to pull this out, and I want to make it a setting, a project setting for my API. And I can do that. No, let's not move that. Let's go to this file, and let's make a new setting. Let's call it, I don't know. How does connection string sound? It's nice and descriptive. There we go. Now we've got an application setting, and now let's use that thing. So I don't need any quotes. We can just say process.env.connection string. Okay. Now let's run this. Let's see how we're doing here. Okay. So this is our function project. So if we want to run it, we need to come to the run item here in the activity bar. And by the way, let me pause here for a second before I run this and we see how amazing it is to see data, products data. It's going to blow your mind. In the meantime, we should address the elephant in the room, which is the fact that my sidebar is on the right. And I know that's probably bothering a bunch of people at the moment. And I want to explain why I do that. So by default, I know this is a sidebar, but just go with me here. I'm going to toggle the sidebar position. So your editor probably looks like this. How many people's editor looks like this? Probably most people. By the way, dark themes or light themes? Let's do a poll. Let's do a poll. There is a right answer here. I'm not going to tell you what it is, though. Yep, sidebar on the right. That's the way to go. So watch this while you're answering with your dark themes, that's the wrong answer. It's only light themes, only light themes. Okay, so when I collapse the sidebar, which you do a lot in VS Code, so watch this, watch me do this. And watch what happens to the code when I do it. You see what happens? See how the code like jumps around? You don't realize it, but whenever code like that moves, your eyes have to follow it and you lose your context. You don't realize it. Your brain's pretty good at resetting, but you're actually sort of tripping over your own feet when you do this. And so who put a pin there? And so let's move it. Let's toggle it. Toggle sidebar position. Now with it on the right, now I'm going to collapse it and watch the code. Just keep your eyes on the code. Look at that. Look at that. Amazing, is it not? Okay, that was for free. You didn't even have to pay for that. That was just for free. So let's run this and see what happens. So I'm going to go ahead and start this up. Yeah, Seth, did you stick a pin on my desk? It's really in my way. Threw it on the floor. All right. It's running here. Give it a second to prime the pumps, get the engine cooking. Yeah, I could use word wrap, couldn't I? Should I use word wrap? Let's wrap it. Wrap. Toggle word wrap. Is that better? Is that a little less hard on the eyeballs? This is a good suggestion. Absolution 183. Okay, let's click on this and what do we get? What do we get? What do we get? We get a JSON response. Okay, so just like that, we've created, and I don't know if this will work. I can't zoom in. Won't work on the streaming. We've created an API, and we can now call this from a front-end service. And let's do this. I'm gonna put a breakpoint here. Let's come back and refresh our page. And let's take a look at this process object and then the connection string. And you can see there is the connection string for the database, which is being passed in from our local settings. Okay, now we could take this project. What we could do is we could take this project and we could publish this to a function app. So let's find a function app. So let's create a new function app. Let's call it My API is awesome. Sweet, that one's free. Node 12, because we're cutting edge. Where shall we put it? Where shall we put it? Where shall we put it? Somewhere close to me, maybe central US. I'm in the central time zone. And now what this is going to do is deploy this application up to Azure Functions, and then it will be available on the web. And then I could write an application using Angular or React or Vue or jQuery. It's still okay to use jQuery. And yeah, I could write this and then I could call this API with that application. Now, the question is always, how do I call the API from the front end? That's where it gets tough, right? With authentication and all that. When we look at, for instance, something like, so let's look at GitHub's API here. There it is. So when we look at GitHub's API, and actually we could just go to api.github.com, and because I'm already authenticated, it gives us back some JSON, which is nice. But this is exactly what GitHub is doing. It's just got some services, just like we wrote, behind the scenes, and then it exposes that for you to use. The only thing that it adds onto the front is an authentication mechanism called OAuth, which is an entirely different subject. We won't get into that. But just know that when you're looking at an API, that's what's going on behind the scenes. Is there's actual code executing. It's just it's exposed to you as a URL. And so we call those web APIs. Okay. So we're finished with our dim. So let's summarize here. An API is an application programming interface. It's what the acronym stands for. And it is how your code talks to other code or services. That's really it. It's more of a concept or a descriptive term than it is a thing. Many things can be APIs, depending on if it's code calling other code. There's three types. It's your code, someone else's code, and the last type we looked at, which was web services. Now, because I love you all so very much, I've created a Learn module where you can do this. So if you go to aka.ms/learn-API, learn-API, give everybody a few minutes to go to that URL, you will get a Learn module that teaches you how to create that API that you just saw, and y'all, how to consume it with a web page using Vue. That's my personal fave, but I'm not going to judge. There's no wrong way to do it. And and you can build your own application that consumes a web API. And hopefully I have demystified the concept of an API for you. If you weren't sure what an API is, perhaps now you feel better about it. I hope so. I think I know what one is. Sometimes I'm still confused, but thank you for having me. Let's see if we've got any questions here. Everyone loves Vue. I agree, Cecil. Vue's pretty rad. You're very welcome. Happy Homemaker. Thanks for being here. I appreciate it. Thank you, Mark. It's always good to see you. Mark's always around. Mark's rad. You are so welcome. Oh, you're misty. That's why, because we're partying, because it's such sweet sorrow. How can you learn to play the guitar like me? Well, hopefully you play it better than I do. It's not good. In fact, legally, I'm not supposed to own a guitar in Nashville. I'm kind of breaking the law. Actually, when you move here, you have to test, right? And if you're not good, then you can't get a guitar license. My favorite Amber Lynn album, Cities. Come on, what kind of question is that, right? It's essentially the Joshua Tree of Amber Lynn albums. All right, thank you, folks. I appreciate you having me here. I think with that, are we ready to go back to the studio, or are we gonna Twitch a little bit longer? Buffalo sauce in his veins. Yeah, I got buffalo sauce. I love wings. Kick it back. All right, Seth. I hope your mic's working. Let's send it back to Seth. Who's ready for more dad jokes? Let's get some.
I stole that camera back from Seth because we're having a dad joke moratorium for the next half an hour. Thank you. Burke, I love you. You're fabulous, but light theme? Really, dude? Really? Because I'm dying. I'm physically and that right side bar thing, no. I understand your logic and reasoning. I just can't. No. But hopefully you're all seeing this random argument we're having. And we tech people are so neurotic about the most strange things. And we are set in our way, ready to die on the hill of dark theme, no matter what. Random. Dark like my soul. Right? This is just like how we are. And that's okay, because we fight over the most weird things.
That's right. By the way, I was also kicked out of Nashville because I did not have a guitar license. I don't know how he's allowed to be there. But like I told you, he is literally a super funny guy, a little less funny than me, of course, but still funny nonetheless.
Yeah.
No?
No.
Cameron told me my audio was really loud, and so he made me move the
turn
microphone
it
down. He's like, can you
turn your audio down?
Can you turn that off?
Maybe a
down?
little
Sorry,
longer.
Seth.
Yeah. Maybe we'll just turn it off for him. Okay, so the next topic we're going to visit is information security. This is a super important topic for everybody in the world, actually, because if you've got a device that is connected to the internet in any way, that could be your phone, it could be your doorbell, it can be your computer, you need to worry about information security. Right now, one of the biggest planes of attack we have is your information through our devices. It happens all the time. You see it all the time. Phishing, hackers, this thing, that thing. And this industry, cybersecurity, is probably the most fascinating, relevant, growing industry out there because it's always changing. The hacks and attacks that we were able to solve just even yesterday are now irrelevant. And we have to now go out and think proactively, think like hackers, and preempt the next set of attacks. So it's like constantly being at war. It's stressful.
I'm excited. So let's do this. There's a lot of you all in the chat or
Twitchlings.
Twitchlings. Sorry. What is something that you have learned today that you're pretty excited about? So I'm gonna let that simmer. What are some things you've learned today that you are pretty excited about?
Yes.
Number one. Number two question, favorite topics so far? Because all the presenters were awesome, but there's some topics that hit us a little more specially than others. So what'd you learn today? Okay. What do we got? Azure, okay. Code spaces, nice.
Code spaces.
What else? Code spaces in browser. Okay, yeah, that's actually pretty cool.
Oh, code space in browser, cool.
I have
API.
learned that your jokes can get worse than the last conference you present. I don't know. I think Donna's jokes are pretty good.
Wow.
Overall, I mean, she's getting better. There's a little refinement in the process. And
Listening
I'm
to
coaching
Seth's
her
pen
through
clicking.
that.
Yeah.
Listening. Oh, am I still clicking my pen?
Yes,
yeah,
you're still clicking the pen. Okay.
Like I said, this is a fountain pen. Every time I write something, it feels like I'm signing an important document. I'm just going to put this
In
over
fact,
here.
he has never signed an important document in his entire life. This is awkward.
Donna, solid burns all the time. Yeah,
There
you
you
should
go.
get that looked at. There's some ointments that you like. Did you? What happened?
No.
Number 1, GitHub. Number 2, GitHub from Happy Homemaker.
I like it.
Let's see what else we got. The Hello World language comparison was good for Pepper Brow.
Creating a virtual machine.
Oh, now we're getting to the important content.
Oh,
what
God,
model of fountain pen?
What model of fountain pen?
This would be a Parker pen, and so literally like the inside of it is just literally like a little tube of ink. Look at that gloriousness. Yeah, I know. And every time I write something, it feels super important, right? And now I know I'm being kind of dumb.
Is Seth teaching us to use a pen?
But think about this. The tools you use, right, make you feel powerful. So like things like Visual Studio Code or the cloud or those things, those tools are what make you feel powerful. Computers like make us powerful devs.
Wrong conference, Seth.
No, I know, but I'm trying to tee it up.
Oh, okay.
Yeah, that was a throw.
To InfoSec?
No, to tomorrow's content.
Oh, to tomorrow's content. Okay, we obviously, as you can see,
we should talk about this
we should probably pregame our content before assuming we read each other's minds badly.
No, we read each other's minds.
No.
It's a wasteland in here.
Oh my God, yeah,
poor woman.
Not much going on.
I put it up on the slide so we can look at it for tomorrow's stuff.
Okay, so tomorrow we have all day tomorrow, day 2. Okay, this is day 1. Tomorrow's day 2 is all Power Platform. Power Platform is low code. Today was all high code. You've learned how to code in like 6 different languages. You learned what APIs are. Tomorrow is low code, where you build apps, websites, chatbots, automation, all this stuff without writing code, using a set of tools from Microsoft called the Power Platform. There's a whole group of people working on it, on that area, and they're very excited to meet you. And our presenters are all people who've either career switched into tech from some other industry, or they've been in Power Platform space for a year. So they're here to teach you exactly how you can learn what they've learned and get jobs like they have. So
Cameron, our director/producer, is giving me the stink eye, which
and
means
saying, shut
it's
up.
time.
Okay, so it's time for Steph to come and take over the feed. Pay attention, because this is a super important topic, lots of jobs to be gotten, and she is a super expert. Hi, Steph.
Thank you, Seth and Donna. Welcome everyone to the talk. This talk is about cybersecurity, and it's an introduction into cybersecurity. So I really do hope that everyone just learns a little bit about the wonderful world of cybersecurity. I know it can be intimidating, but I'm hoping that I can do my job to help you feel a little bit better about exploring with cybersecurity. So today we are going to talk about a few different things, and granted, this is an intro level talk. Cybersecurity is very vast, like much of technology in general. So I can't do it complete justice, but I'm hoping that what we discuss today is going to help spark you to learn on your own and pick up a book and maybe play around with some things. So we're going to go into cybersecurity and what it is, as well as what makes up cybersecurity and the different aspects of it and the different people involved, as well as how cybersecurity affects us, our systems, our networks, and our buildings, and how we can protect ourselves and those around us. So before we get started, I'm going to briefly introduce myself and get on to the craziness. I am a cybersecurity professional. I've been working in cybersecurity for about 4 years. I also am a speaker, as you can see today. I also podcast as well, and I have done a LinkedIn learning course on social engineering. So I've been around the block a few times in cybersecurity. I've been learning cybersecurity since 2012 as well. So I mostly have been self-taught. Some of it has been formal training, but I just want to let you know that anybody, literally anyone, can learn cybersecurity and tinker around with it. I'm definitely not a special snowflake for that. So what is cybersecurity? I was very intentional about using this graphic because I think when most of us think of cybersecurity, we get a little intimidated. Cybersecurity is this big, scary topic where there are attackers and hackers and things like that. And you can kind of sway, kind of hesitate when it comes to playing around with cybersecurity, unlike other technology topics or subjects. So I wanted to use this because it's symbolic of how all of us feel when we think about cybersecurity. However, this is just an illusion or just one of the stories that are being pushed about and surrounding cybersecurity. It isn't the whole makeup. I look nothing like that, and I'm a cybersecurity professional. So, according to the Merriam-Webster dictionary, cybersecurity is any measure taken to protect a computer or computer system against unauthorized access or attacks. So when you think of that, it's no different than protecting yourself when you're going out for a night ride or going out for a night walk. You would carry something with you maybe to protect yourself or keep alert to protect yourself. It's just digital. So I'm hoping that that definition kind of takes away the scaries when it comes to cybersecurity. So when it comes to cybersecurity, there's a lot of things that go into it, but all of the things that go into it center around these three main goals: confidentiality, integrity, and availability. So confidentiality is all about keeping private things private. You want to make sure that you know who has access to a piece of data or a system or a network, and you want to make sure that only the authorized individuals have access to that thing that you are trying to protect. In addition to that, we have integrity, and integrity also is something that you want to make sure that nobody can change data. You want to make sure that nobody can alter it without being authorized or without going through the proper protocol. So making sure that data stays exactly the same, no matter where it's stored, no matter how it's moved, is definitely another part of cybersecurity. Lastly, we have availability. So when you think about availability, you might think about a data center, you might think about servers. Oftentimes, if you go to a data center, they will talk about 99.9959 times availability. And what that means is when somebody needs access to a system, making sure that access is always available. So with these three things, you'll find that most of what we do as cybersecurity professionals and as cybersecurity enthusiasts come from these three fundamental basics of cybersecurity. So when it comes to cybersecurity as a profession or as a job, there are kind of three main perspectives where we kind of go back and forth when it comes to doing what we do. So red team, blue team, and purple team, they're teams in cybersecurity, but I like to call them perspectives. So when it comes to the red team, they have the offensive perspective. It can be internal or a contracted external third party. So these are the people that are going to be performing penetration tests. And a penetration test is also a test where someone assumes the personality or the identity of an attacker and then attempts to attack your systems, not for any kind of financial gain or any malice, but just to help inform you of where your holes are and where you should be focusing your efforts on protecting yourself. So a lot of red teamers are also fluent in penetration testing and the skills that go into that. And they also test the effectiveness of existing security programs. Then you have the blue team. The blue team is mostly internal and they have a defensive kind of standpoint. So they're more concerned about being proactively defensive and preventing any kind of attack from occurring. They might not be as familiar with an attacker's motives and attacker's moves and patterns. However, they are very, very well versed in protecting systems as they exist. And then you have the purple team, which is a lovely mixture of both. They have the perspective of the attacker, but they've also got the tactics and the strategy of the blue team. So they're a nice mix. And I think everyone who works in cybersecurity or plays around with it ends up going to the purple side more often than not in their career. Next, we've got the hackers, which everyone who has heard of cybersecurity definitely has heard of a hacker, but I'm not sure if every one of you knows about the different perspectives of a hacker. Some hackers are actually ethical hackers, which is what the first example has. White hat hackers are ethical hackers, meaning they have the permission of the system owner to search for vulnerabilities or attack or test the system's defenses. When you come to gray, this is one I like to kind of compare to a bug bounty hunter. Basically, someone who might not have the permission to scan or test a person's website, but they also will reveal the information to the system in question and say, I found this bug or this vulnerability or this hole here, and I would like some compensation for that or some kind of acknowledgement for finding this item. Then lastly, the one that everyone is more familiar with, which is the black hat hacker. That is someone who is completely out for personal or financial gain. Sometimes it also has something to do with politics or activism, but for the most part, it has to do with financial gain or personal gain. And they're more bent on destroying a system or stealing information, and probably more centered around cyber espionage or spying. So all that to say, how does cybersecurity affect us on an individual level, on a personal level? We have a whole bunch of threats out there, but why should we as an individual care? And the reason why I wanted to put that in this presentation is because part of being a cybersecurity professional or enthusiast or tinker is also thinking about your own personal security hygiene and how things might affect you on a personal level. And then when you extend outside of that, you'll be more prepared and more in the mindset of, on my own personal level, I lock my phone. So when I go to work, I'm going to lock my laptop as a habit and as you're building up your security hygiene. So here are the ways in which we're affected. I'm going to go over these 3 specific ways in which we might have heard of being affected by cybersecurity. In our systems, you may have heard of different types of malware. One such type is ransomware. So ransomware is malware that will lock your system up and lock your files up until you pay a fee. So a lot of malware comes in and is translated into that. And a lot of people have been affected, including corporations. But even on a personal level, individual people have been affected by ransomware. Also, Trojan horses. That includes malware that presents itself as trusted or harmless, but is really malware underneath. So let's say that you have chrome.exe on your Windows machine. When it comes to a Trojan horse, it would disguise itself as Chrome, but really be a malware application underneath or a malicious application underneath. And lastly, we have viruses, which are pretty much anything that through human interaction will infect your machine. So viruses can also spread through human interaction by infecting maybe your email client or your machine when you send a message to someone. I know I've received Facebook requests with people asking me to click on links, but not knowing. So those are the things that affect our systems, but there's definitely more. For the sake of time, I can only go over a few. When we go into our networks, there are certain things that affect us there, like denial of service attacks. Basically, a denial of service attack is an attack where you basically attack a machine aggressively until it no longer is allowed to do anything, function. It just is so locked up with its resources that you are not able to do anything on the machine. And that affects one of the CIA goals that we have that I discussed before, which is availability. If you can't use your machine, then security has failed in that case. So denial of service attacks are a very popular way of stalling machines or making sure that a machine is rendered unusable. You also can have a man-in-the-middle attack, which is when someone kind of drops in the middle of your connection and intercepts anything that you're sending out. So if you are communicating with your bank, for instance, and you're not using a secure connection, then somebody could intercept your login credentials or your account statement information, things like that. Lastly, we'll talk about our buildings and physical security. Unauthorized access is definitely something that can affect us. Somebody stealing our stuff or breaking into our homes is definitely something that can affect us. As well as property damage or graffiti, that is also something that can affect us. So lack of cybersecurity or lack of security in these particular cases definitely affect us on a level, and it kind of inspires or should inspire us to act and be more concerned about our security posture. Last but not least, I wanted to talk about a really, really fun idea for learning, but also for really seeing what's out there in terms of attacks. It's called a honeypot. So a honeypot is a server that you essentially put on the internet, and you make it intentionally vulnerable. And so when you make it intentionally vulnerable, what happens is people will obviously attack it, but you can study the logs to see how people attack it. And so when I was first starting to learn more about cybersecurity, especially from a red team perspective, I definitely had a couple of honeypots available on the web, and I funneled all of their logs to a Splunk server. And Splunk is basically a log aggregator. So I used that project to learn Splunk and learn how to search and sift through logs, but also how people might attack the server. So, and then setting it up is also a fun treat too, because you have to figure out how you're going to do that as well. This is a great way of learning a little bit of network security as well. So I always make sure that I suggest that in terms of increasing your knowledge when it comes to security and getting your hands dirty at the same time. So with all that being said, I gave you a very, very scary portion of the talk, which tells you about all the threats that we might face on a day-to-day basis, just in cybersecurity alone. And now I'm going to tell you how we can protect ourselves. So before I talked about basic security hygiene, and what that means is practicing good security, basically good security habits that keep us safe no matter what. When you build a good reflex or habit, you don't have to think about it. And half the time, people don't do things securely, not because they don't want to, but mostly because it's inconvenient. However, when you make something a habit, you're able to practice it regularly and you don't even have to think about it. So when it comes to security hygiene, even learning or attending this talk is a way for you to boost up your security hygiene. Also, password management. 81% of breaches happen because of weak or stolen passwords. So when you think about that, making strong passwords obviously cannot help with the stolen part, but the weak part, definitely it can. A lot of major breaches that have occurred and affected major brands that we know have occurred because of weak passwords in the system. So making sure that your passwords are strong is very important. And nowadays we have things like password managers that can store all of your passwords for you and create randomly generated passwords that are intentionally strong and hard to break. That way you don't have to remember it, but at the same time, you don't have to worry about weak passwords being the reason why somebody has gained access into your accounts. Next, we have antivirus scanning. If you have a computer, especially if you have a Windows machine, you know about Windows Defender, which is built into the machine. And scanning regularly, sometimes you find things, sometimes you don't, but having that regular check is a great way of having great security hygiene, because just in case you miss something or you don't think or you click something you download, you have a fail-safe, a regular scan that comes and wipes it clean or alerts you when something is being downloaded that shouldn't be. And last, we have patch management, or updating your phone or updating your devices across the board. Updates, a lot of people do not know that security updates are regularly released, and they're part of the bug updates as well. And so a lot of times when you get a notification that an update is available, nothing's really changing with the application except for closing security holes or repairing security bugs. So I always like to stress that people should update and really be obsessive about it, mainly because updating prevents a lot of things from happening and prevents you from being vulnerable, especially when somebody else is doing the heavy lifting of correcting the code that has the hole in it in the first place. And all you have to do is press a button in the middle of the night so that your phone can update. So I always like to stress that that's a great way of maintaining security hygiene, because you're always knowing that you are up to date when it comes to security holes and it being patched. Another topic I would like to talk about is social engineering. Social engineering is the art of getting a person to do something that they wouldn't ordinarily do. So a lot of times people think it's some really super scary narcissistic personality that goes around lying to people. But in my course on LinkedIn Learning, I talked about how a 6-year-old can actually social engineer you and trick you into thinking that they've cleaned their room by shoving all their clothes in their closet and showing you what you want to see in order to get them to play video games or go outside. I don't know if kids still do that. So things like that are a part of social engineering. And I love to take these topics and break them down on a regular, everyday level, because we like to build them up to be something super huge and nefarious all the time. However, in and of itself, the definition of social engineering is fairly neutral. It's what we do with that is the problem, or how it affects others that is the problem. So social engineering is something that we're also familiar when it comes to phishing, which I'm going to talk about in this slide. When it comes to phishing, emails that are sent trying to get you to do something that you wouldn't ordinarily do. So whether that's logging into a site that looks like your bank site, but may not be your bank site, or has a link inside of it that promises that you're going to have a $5 million gift card or something like that. These are ways in which social engineers attempt to entice you to do something that you wouldn't do. So the art of persuasion, deception, those things are definitely used when it comes to social engineering in the traditional sense. So when it comes to phishing, that's through email. And when it comes to baiting, that can actually be through a number of methods. You can bait someone in person, actually. You can bait someone online by offering something, whether that be a gift card, whether that be saying that the person wants something. All of these different methods can be used to bait someone into doing something or saying something that they wouldn't ordinarily say, but are kind of wrapped up in the thing that they want, or the incentive that you're giving them to give the information. And last, we have spear phishing, which is a very specific type of phishing. It's when you target members of a specific organization in order to gain access to that system. So for instance, if I had some sort of agenda with, let's just say, twitter.com, and I decided I was just going to find folks that worked at Twitter, that would be me targeting specific people and then sending emails to them that they would probably believe, like maybe sending it and pretending to be from a CEO or pretending to be from somebody equally important in that organization to get the person to give me access or give me account information or any other thing. So these are the different things that happen when it comes to common social engineering attacks. Now, when it comes to combating social engineering, which I wouldn't tell you about the dangers if I wouldn't be right if I didn't give you the solution. There's a number of things that you can do. The main thing out of all these suggestions is to just stop and think and slow down. But when it comes to these specifics mentioned here, you can use something like VirusTotal, which is basically a scanner. Like, it will scan your email attachments, it can scan files, and it also runs against different antivirus scanners. So you can, if you are not partial to any particular scanner, it will do all of them for you and let you know what each scanner returns. So sometimes the scanner might say this is malware, and sometimes they might not catch it. So if one fails, the other one comes up. So I use VirusTotal all the time, as well as URL Scan, which is also a sandbox application. So essentially, if you don't want to visit a website, or you're not sure about it, you're not sure it might be sketch, you can put the website URL in that website, and it's going to visit the site on your behalf and let you know what happens after it visits the website. Also, shredding sensitive documents. I also have a shredder. I don't know if you can see it behind me, but there is a shredder here. Shredding important or sensitive documents just ensures that when if somebody decides to go through your trash and look for information, they're not going to be able to make much sense of it without taking a long time to basically put the puzzle pieces together. Also, being mindful of what you post online or on social media is very important. There are some times where people can see certain things in your background and they'll be able to know where you frequent and may use that in terms of gaining more information about you to try to figure out how to gain access to you or to your systems or your accounts. So being mindful of what you post, looking twice at a picture, making sure that there's no information that you don't want out there is very important. And lastly here, multi-factor authentication is also super important. Making sure that there's another layer of defense between you and your accounts is just, it just adds another difficulty for an attacker. If they have your password, but they don't have your second layer of authentication, then they just stopped at the second layer and they can't continue forward towards your account. So a good multi-factor authentication is Duo, where I work. They do have a lot of great authentication tools or services, as well as Google Authenticator. There's multiple different ones out there, but having that implemented definitely helps as well. So I really hope that you enjoyed this talk. I really hope that you got some great nuggets today. It was a lot of information, and I'm very hopeful that this definitely sparks some interest when it comes to the wonderful world of cybersecurity. You can reach me at any of these places and ask any question, and I can point you in the right direction, or I can answer them if I have the knowledge. I am available on Twitter, Instagram, LinkedIn, and I do have a podcast, like I mentioned before, called Coolest Nerds in the Room, and it's available anywhere, but I just put Apple Podcasts there for just being succinct. And in addition to that, there is a course that you can take that's available in Microsoft Learn, and it is geared towards network security. Network security is just as important as any other security, and it's a really cool class that takes you into the introductory level of what network security is and how a network works in general. So I would say that that's a great follow-up to this course, a great commentary after this. And it's also not very long, 36 minutes, and will give you great information to kind of make sure you keep the excitement when it comes to learning about cybersecurity going. Thank you so much.
Wasn't that so good? I love watching your comments, and some of you are saying that was the first session where I understood everything. And that's not surprising because she explains it incredibly well, but also this is relevant for everybody. Not if you're studying to be a dev or you want to be a software engineer, you are one. It's for everybody, especially like the bit about social engineering, 6-year-olds who act like they cleaned their room and shoveled everything in a closet.
I will say that the most accurate representation of hacking I saw ever in a movie was on Ocean's 8. I think it was Rihanna hacked some guy, and it was basically she got him to log in to like a puppy website, and that's how she stole all his credentials. And I was like, I was sitting there with my wife. I was like, that's real hacking.
Yeah.
Rihanna needed to teach us what actual hacking is. Thank goodness for her.
And all of us would fall for that puppy thing.
Yeah.
Also, we would do that.
Don't email me logins with puppy things.
No.
So, yeah.
So, do you want to hear my cyber story?
I do.
Okay. So maybe about 3 years ago, I became fascinated by cybersecurity because I think there's a lot of hackers in the world and lots of things were going on. We kept hearing like, Microsoft cybersecurity has stopped this major attack and that attack. And I thought that is so badass and it's so cool. I wish I had these kinds of skills. And I was dealing with some major imposter syndrome. I was thinking, oh no, I'm a software engineer. I don't have the mind for cyber security, to think about hacking, to be paranoid about vulnerabilities and all of these things. So I went down the spiral of impostoring, and I impostered myself out of learning about it, honestly. I said, no, I don't think I'm smart enough, I'm not talented enough, I'm not paranoid enough. Cyber people are such badasses. They're just so good at anticipating the future. And I'm a dorky software engineer. I don't have what it takes to do this. So I reached out to a few friends and asked them and told them my thoughts. They all laughed at me and said, we grew these muscles by doing this job a lot, just like any job. Cybersecurity experts are not born. They're made by doing the work over and over again. So I started playing with the site that they all recommended called hackthisite.org. I'll drop it in the chat. But it really was this eye-opening moment for me where it was, we're all beginners sometimes. And at that moment I was a beginner and I was feeling this overwhelming sense of impostering and everyone knows what they're doing and I don't know what I'm doing and everyone's going to laugh at me and tell me I'm a dumbass. So it was a real feeling, and it was just 3 years ago after I've been in this industry for a decade plus. So if you're even a little bit curious about this industry, go explore a little bit more. Go learn things. You don't have to be good at it right now. Not all of us can be Steph because she's been doing this for a very long time. And people like you and I may have been doing this for 0 days. So that is my cyber story.
Yeah, that's a really cool story. And like what I'm saying is we all basically have to be terrible at something before we get good at it. I'm probably a really good dancer. No. Sorry. I'm probably really good at some things, but I'm not a good dancer. But if I wanted to be a good dancer, it's something I need to put some time in. And my sense is that these things are not necessarily easy.
No.
But they definitely are doable if you put in the time, right? And that's
right.
I think what the key thing is here. I mean, in my opinion, right?
Yeah. So it's just, like everything, it's you have to put in the time. You have to not be afraid of looking like a moron. And looking like a moron really is like...
I'm really good at that.
Yeah, we're kind of experts at looking like morons.
Look at this.
Yeah. So you have to be down with looking like a moron for steps 0, 1, 2, 3. And one day you feel like less of a moron. And that's a good day.
I know, right? Every day I feel a little less
like a moron.
So let me tell you a little bit about the schedule coming up. We've got some good content all the way till 5 p.m. Pacific time, which is 3 hours from now. We've got Nitya coming up, Intro to Mobile Development.
That's right.
Now, is it mobile or mobile?
It's mobile, Seth.
Not mobile? We don't say mobile?
I mean, you can, but why are you saying it that way?
I don't know. I wanted to sound fancy. What can I say?
You want to be fancy.
Next, after that, how to contribute to open source with our wonderful colleague, as well, Tierney. By the way, Nitya is also our wonderful colleague. After that, working smarter, we don't read that out loud, right?
No.
5 steps to getting unstuck.
Oh, boy. Yeah, that's a good one. That unstuck. You want to stick around for the unstuck one because...
Hey, look, if you're going to
hacks.
dad joke this, you got to let us know, right? Because it's like you're stealing my vibes here.
Oh, my God. This is
so if you want to get unstuck, stick around. It didn't
He's
work.
doing it.
Thanks for ruining it.
He's doing it. By the way, Cameron, our producer, came in here and said, "Why are you making me sound like an evil person? I'm really nice." We're like, yes,
Yeah.
he's very nice. Cameron is really nice to us.
He's like, can you tell them all that I'm really
Not
nice?
Really nice. He is very nice. We're not scared of him at all.
No, he's the nicest guy
very
I've ever
nice.
met.
The nicest. So
after that, confusion, this is so cool, is the sweat of learning. EJ Metz. That's at 3:30 Pacific time, coming up in about an hour and a half. Oh, wait, an hour and a half. Confusion is the sweat of learning. How about that?
So by the way, we end the day with a panel of some of the speakers you heard from this morning and others, and it's about their career journeys. So that is the time that you can ask them all your questions, like how did you get your job? What did you do to your LinkedIn? How did you do your resume, et cetera, et cetera. Also, 2 resources that I forgot to mention, I wrote down, and I completely forgot. One of them is Steph, who you just heard from. She's got a great LinkedIn learning course on InfoSec. So if you're curious about info security, cybersecurity, et cetera, go check it out. Very good, highly recommend. Second, Danny Thompson from this morning, if you all chimed in, he was the chicken fry guy who is now software engineer. He's made a course on how to boost your LinkedIn engagement and how to get recruiters to reach out to you. So that's quite good as well. But 2 fun resources not related to Microsoft Learn or Docs or whatever.
So Cameron now is giving us the nice eye.
The nice eye, saying shut up. So
and let's go to our next session.
All right,
Nitya.
we're going to go to Nitya, who's going to share about mobile development. Nitya is also one of the best artists on the planet. She's a sketch note extraordinaire. Hi, Nitya.
All right. Thank you so much, Donna and Seth. And hello, everyone. Thank you so much for sticking around. And welcome to this introduction to mobile development. My name is Nitya Narasimhan. I'm a senior cloud advocate on the developer relations team at Microsoft. This is the accompanying Learn module. You can also find it on the website, and I'll put a link to it later at the end. But if you want to go check out some mobile development after this, feel free to go there. Also, just a little bit of housekeeping. If you're interested in following up on some of the things we'll talk about today, go check out that AKMS link at the bottom. So it's aka.ms/intro-2-mobile-dev. I'll be putting all the slides and the content that comes in this talk over there, and I'd love to hear from you to see how you progressed. You can also find me at Nithya on Twitter. So quick introduction to me. We're all talking about journeys today, right? So your journey is important. And I've been in the mobile space for a long time. I started out in research actually over 2 decades ago. And at that time, mobile was just emerging. I was working in Motorola Labs. And what really made me fascinated with mobile was this kind of notion of seamless mobility. We looked at the phone and said, this is the one thing the user carries with them everywhere they go. It provides context. It provides identity. It helps us create these seamless experiences as they go from home to car to play. Fast forward a few years, and I started working with startups and as a consultant, building these things, but not as prototypes, rather as products to scale. And I realized that when we think about mobile experiences, we also need to think about mobile web apps and cross-platform apps. The first one allows you to kind of ship across all the different platforms there are. The second one allows you to use a single code base and build targeted apps for both Android and iOS and other destinations. And last but not least, I'm an advocate on the cloud, on the Microsoft Developer Relations team, but I've also kind of been an advocate for the longest time in community. And what I'm really excited about right now is dual screen foldables. If we have time, we'll go look into that later. And let's talk about your journey today. The roadmap for this talk actually is in 3 parts. First, we're going to set the stage. Why should you care about mobile? You've heard so much today. Why mobile? Second, and we'll spend the bulk of our time here, we're going to talk about how you can get started building your very first app in Android. Something really simple. We're not going to be able to build everything, obviously, but what you'll achieve is 2 things. Hopefully, you will learn to get your development environment set up, and you'll learn what the workflow looks like. Last but not least, to continue your journey, I'll share some resources. So let's get started on the first and most important question. Why should you care? So I have some stats for you. The first motivation for you should be the fact that mobile app usage is growing. It's growing 10% year over year, and it's been 35% since 2017. And it's being driven by the fact that we are all addicted to our phones. A mobile user spends over 3.5 hours on their phone every day. That's not going away. Great, that's awesome, but what about as a developer? Like, is there room for me? It turns out, and for each one of these, I'll share the slides later. The links are at the bottom so you can check out the bigger reports. If you look at the job market, it turns out that in the mobile app space, they're kind of predicting that mobile app developer jobs will grow 30% over the next decade. And in that space, you'll see that Java and Android tend to be at the top. We'll look at why in just a minute. But you can also look at the GitHub Octoverse report on the right side, and it shows that the fastest programming languages that are being learned or skilled up by developers today, in those, the first one, Dart, and the fourth one, Kotlin, both target the mobile ecosystem. So you can't go around picking up a new skill here. So where should you start? Well, there are actually 2 dominant mobile operating systems out there. There's Android and iOS. And if you look at the stats, mobile OS market share actually favors Android. 85% of smartphones shipped worldwide tend to work with Android. And that's because Android has a broader device ecosystem and also targets various kinds of ecosystems from like 5G all the way to like developing nations. But last but not least, if at this point you're like, I bought in, but what can I build? It turns out there are 5 different areas where you're seeing a lot of growth in mobile. Gaming, of course, mobile banking, mobile retail, all your Thanksgiving purchases are likely going through that phone. Video streaming, hopefully you're watching this on a mobile right now, and social, everything from TikTok to Twitter. But what's interesting is COVID is changing a lot of behaviors. So now we're actually doing more on our phone. And what could be interesting is new behaviors and how we would support that. So what are your options? I can't go into all of them because there's so much I want to talk about, but I'm going to hugely recommend you follow through and watch this talk from my colleague, Brandon Minnick. It's called Choosing the Best Mobile Framework, and he just gave this talk at NDC. But if you kind of want to get the big picture, you can think of mobile app development options falling into 3 buckets. You can build native apps. So you can build an app for a specific target platform using their tools. So the Android SDK for Android or the iOS SDK for iOS. What you get is the best tooling, the latest features, and everything you need, but you'll be targeting one market. Or you can look for cross-platform. Cross-platform is where you've got kind of another layer above where you can now write with one code base, but you have tooling that helps you build those apps for multiple markets. There are trade-offs, of course. And last but not least, there's mobile web apps. Progressive web apps is a space where they're trying to kind of figure out how can they make a web app look and perform close to native expectations. Things like having offline access, things like having an icon on the home screen. So you can explore that too. And this table also tells you what languages tend to dominate in those spaces. But that all doesn't matter, right? I'd really, if you take one message away from mobile development, know this, that ecosystem is huge. So your philosophy has to be, how do you eat an elephant? And this is a meme, I know, but I kind of like it because what it really is saying is when you have a giant endeavor in front of you, start by taking one bite at a time. Start with a single step, take time to learn the core idea behind it, wait for a second and just enjoy that achievement, pick your next step and go again. And my real hope is that your first small bite of this Android elephant today will be where you will go check these slides later and try to build your first, install the SDK and build your first app. From a broader perspective though, I also want to give you some options. When you think about how you go from having your first idea to actually building it, there is a kind of a roadmap. Let's first ask the question, do you just have an idea? You don't have anything else. You just have this idea and you're thinking, how could I do it? Then start with design. You can look at wireframing tools and design systems. Just figure out how to put the UI flows together and what you need. But what if you're one of those folks who's working at a company, you have data and you want to do something to improve the user experience? Then the next step is to kind of look at just drag and drop solutions. You don't need to learn to code if you can use platforms like Power Platform. Drag and drop solutions with data connectors that let you bring your data into that system. Definitely check out the full day of Power Platform programming tomorrow. But last but not least, this is where you really need to learn mobile development. You actually want to do new things, better things, new features, high performance. And that's where you need to know the development SDKs, toolkits, and design patterns. So over the next 10 minutes or so, I'm going to try to get you through a speed review of building your first very simple Android app. And after you hear this, I hope you'll go and try to do it yourself. I'm going to put all these slides and the videos that go with them at that post that you see there. So what we want to do today is build a very simple Android app. And what it's going to do is, this is an icon, an image from the wonderful Ashley McNamara that features our developer advocate bit. So at the end of this, hopefully what you'll have is a single screen app that shows hello world, but with bit. What you're seeing on the left is what Android Studio looks like. That is the preferred IDE. So what are the steps for this demo? We're going to walk through a few things. And wherever possible, I'm going to have I've recorded some snippets that you can see how that actually works on Android Studio. And then we'll talk about a couple of things in there. First thing is I'm assuming that you will install Android Studio later. I already have that on my machine. That is the default development environment for Android. Second, you're going to click the Create New Project wizard and build a basic Android app. Third, all right, you've gone through that boilerplate and just got a Hello World app, but how do you know it works? You're going to create a new Android virtual device. That will help you set up something called an emulator so that you can test out your app on a virtual device right there on your desktop without needing to have access to the real Android devices for your app. Next, you'll update that boilerplate code to do a couple of small things. In this case, we're going to try to update the simple hello world to show the bit icon. And then last, we're going to look at a few things around how you could fix warnings and then run the updated app. And don't forget to celebrate. So step one, Android Studio IDE. This is what it looks like when you install it. It's the preferred IDE for Android. And I just want to point you to a couple of things that will come in handy. First, its build system is based on Gradle. It's customizable. It's a plugin-based system that lets you customize the entire process from building to testing to deploying, obfuscating code, etc. Second, there's an AVD manager built in. You can create virtual devices for as many Android targets as you want, from phones and wearables, TVs, you name it. There's an SDK manager. We're going to talk about that in a minute. But think that with Android, there are so many versions in the past. An SDK manager not only allows you to kind of target your app at older and newer versions, It allows you to update your tools and your SDKs seamlessly. Last but not least, none of this would work if you didn't have visual design tools, profiling tools, debugging tools, and lots more. All of that is in Android Studio. Every one of these slides will have a link at the bottom with a resource that will show you where you can learn more about all of this. So here, let's walk through our first demo. So this one, I'm actually going to play and then kind of pause it and skip through the various things because I don't want to waste too much time. But the SDK manager, when you finish installing Android Studio, it's probably the first step that you will take. And what it does is it allows you to install various SDKs. So you can see there that the option is under configure. And when you click on that, you'll get to this SDK manager page. And it shows you every single version of Android that exists, the images for those, the system images for those. And those will come in handy even when you're trying to emulate and run your app, so you can test against the actual image. Android goes back quite a few years. I tend to just install the latest and greatest and perhaps one older version, but you can do what you need. So simply go ahead, select, and those are the other tabs that show you what other updates you can get. So simply just select the version that you want to install and click the button. Let's go with, I think I did Nougat, yep. Yep, and then install it, and within seconds, you should be done. So while this is finishing up, let me kind of focus on the image on the right. Why does this matter? Those are all the Android versions since ever. So early Android versions were named after pastries. You might have heard of Lollipop and Marshmallow, right? More recent ones are given numbers. So we're at Android 11 right now. But there are two reasons why you would pick the API level and platform version. The first one is kind of like when you want to figure out what's the size of the device population your app can be installed on. So if you look at this, you'll see that every device out there today, every Android device doesn't run the latest and greatest Android, right? Not everyone updates. Not everyone has the kind of device that can take the latest updates. This lets you kind of look at it. The data is real time, gives you a sense of what percentage of devices in the open market across all Android devices can I target by picking a particular API level and platform version. So you usually use that to pick the broadest range. What you might also do is pick it to narrow it down, because every one of these API levels is adding new features, which may or may not be supported in the older ones. So if you have a feature dependency, for example, I'm doing stuff with foldables, which came about in Android 10. Therefore, I tend to try to work with those devices first, then that might be your use case. So that was installing the SDK. Next, once you've done that, just literally go up and open the Create New Project wizard and walk through building your first boilerplate app. You're going to take a second to showcase the different templates that are available. You'll see two things. First of all, you'll see that there are tabs, one for every device form factor. So you have templates for phone and tablets, for wearables, for TV, automotive, and IoT devices. Android works across them all. In each of these, you'll see what's called an activity template. In Android parlance, an activity is the screen. It's the view that you see. So what you're getting is a boilerplate app that automatically has done the basics needed for that kind of screen. And it kind of covers the basics, right? You'll see a map view. So if you've got an app that has a map screen, maybe that's where you start. Or a master detail flow is usually for when you have a collection. We're going to call it list detail, a collection and detail views for each individual item, and so on. So definitely go check those out. Here's the demo of what that looks like. So when you start, you go ahead and just select start a new Android project. Let's skip ahead. So when you get to this, I'm going to walk through and so let's get to the main part. So we're going to pick the empty activity today for the demo. When you pick the empty activity, you get to this screen. And I'm going to wait for a second and we'll talk briefly about it. You're going to do two things on this. First, you're going to pick the name for your app. That's the name that's going to show up on the icon when you install the app on your phone. Can be something descriptive, something unique to you. The second is the package name. And the package name is what gets attached along with the name to make your app unique in the Play Store or in the market or on the device, right? So for example, if I decided to write Hello World as the name of my app, there's likely to be a lot of people writing Hello Worlds that are different from mine. By scoping it to a unique package name, you've got yourself a unique application instance. Last but not least, you'll see that the language here, and let's play this again. The language options under here are Kotlin and Java. If you're starting for a first time in mobile development, pick Kotlin. Android is going Kotlin first. But if you're familiar with Java, definitely go with that. Either of those is perfectly fine for your initial app. Click finish, and this is what you get. It's scaffolded out a very simple app. And what we're going to look at here is what you see on the left side. So you can see that the drop-down menu allows you to see your code base in various perspectives. If you put it in project mode, you're actually going to see how it is on the file system. But most developers will keep it in Android mode, where they can actually look at it from the view that's most optimal for a developer, as you can see here. And in here, you're going to see that there are top level 4 different areas. And we'll talk about that briefly later, but I want you to just keep that in mind. There is manifest, Java, RES or resources, and Gradle. In RES, look at the activity_main file. So I'm going to just stop this for a second and flip through the 2 screens that you see. First one is when you look at main activity, that's in the Java folder, that is your source for the app. Currently, this one is written in Kotlin. And if you look at this, this is the entry point. It's just like main in any other language. So main activity is the entry point. And all it's saying is, hey, when I'm created, please go ahead. Oops, I moved it. I should not have done that. Give me a second. All right, we'll use this. All it's saying is set my content view to r.layout.activity_main. That activity main kind of looks familiar, doesn't it? Because when we looked at it, under the resource file, there's an activity_main.xml. So first thing you're going to need to know about the Android programming language. There is the source code in Kotlin or Java that is going to be written to control the life cycle of the activity. But the UI itself can be designed and written in XML and stored under resources. And this is what it looks like. And you'll see it's literally just a simple hello world text view, right? So let's keep going. If you look at the Android manifest, we already looked at what the source looked like, just had a simple method that inflated the view. We saw what the view looked like. We're going to look into more detail on that in just a minute. But now let's see what the manifest is. The manifest is a packing slip for your app. It's the place where you're going to define for both the Play Store and for the installer what kinds of components your app has. Remember that term components because we're going to talk about that later. And last but not least, resources are the non-code assets that get packaged along with your app. So when you've got this far, you've got everything, you haven't made a single line of code change. You've scaffolded out a default app. Let's see what that looks like. How can we do that? We can run it on an emulator. So I'm going to first show you what it looks like running on an emulator, and then we'll talk about how you can create one. So all you would do is go into the top of your Android Studio, pick the device that you want to kind of try this out on. You can have different emulators for different form factors. So you can have a tablet device, you can have a phone, etc. Run your app, and then as you can see here, the emulator, when it launches, looks exactly like a real device and shows you what that app looks like. And in this case, it's just a simple hello world single string. Done, right? So when you're trying this out on your own, what I want you to do is explore. Take this little bite of Android elephant and try out the different templates. Can you recognize patterns for apps that you've seen on your phone? Play with it. You can't do any harm. Just play with it. So after that, the next step is to create that AVD. Remember when we ran the demo, the default demo, you were able to see it on a real device, right? How do you create one of those? So AVD stands for Android Virtual Device. And what it is it models the characteristics of a real Android device. So if you don't own one, you can still do this. And it can have emulator skins that look and feel like that instance of the device. So when you actually take screenshots or when you see it, it feels real. Last but not least, configuration properties let you set up what the device state should be and what kinds of behaviors it should show the way you would do on a real device. So I'm going to skip the video for it. When I put the slides up, please check out the blog post. I'll put the video there. But basically, you'd go into the configure screen and you'd be able to set up and create your own device. What I do want you to try to explore here is try creating AVDs for other categories. I've created one for a phone, but try creating for wearables and TVs. You might need to download new system images. So you might need to then flip back to the SDK manager and install a new SDK. Great. Let's now review the boilerplate code and let's talk about what you can do next. So we reviewed the following things. In your code, this is basically the source for your app. The manifest, the think packing slip for your device. The source, the Java folder that contains Kotlin or Java code, which is really the components for processing. Resources, non-code assets that are going to be packaged with your app. So you can think about this, not just layouts in XML, but images, fonts, Colors, strings. I'll talk briefly about things like strings. Why are they a resource? Because now you can do things like localization by putting alternative versions of strings in that resource. And that way you don't need to go back and change your code. It can automatically pick up the right localized versions of the string values for you. So you can do things like that. And last but not least, Gradle scripts. So this is where we are at, right? Let's review core concepts, and then we'll dive into the stage of making some changes in that code. So here are the core concepts for Android. Your programming language is Kotlin or Java. Your package, or APK, is a compiled code and resources. Every app runs in its own secure VM, so you can't kind of like, sneak peeks at other people's data. Think of it almost, it's a Linux system under the cover, so every app is like a unique user. And if you remember just one thing about Android, remember that Android code has 4 kinds of components. Activities, which are the views. Services, which are background processing. Broadcast receivers, which is code that you can use to kind of receive asynchronous events. And content providers to help you access and work with data. How do you communicate between these components? There is something called intents. An intent can be implicit or explicit. It's literally like every app is sending a message to every other app, right? Saying, hey, I need someone who can do a map view for me. Do you have a map view? And if Google Maps is installed on your phone, it's going to get up and be like, I can do it. And now you don't have to write the map view. You can literally take advantage of the fact that Google Maps is installed, right? And if Bing Maps was installed tomorrow, that can wake up and say, I can do it too. And now you have a choice. So implicit intents are when you do messaging by telling you the type of target you want. And every instance that satisfies it is able to like be a possible target. Explicit intents is when you directly message a specific instance. So app manifest we talked about, and I'm going to go quickly because we have just a few minutes left. To edit the boilerplate, what we really want to do is we want to kind of add a new drawable resource, that image that you see, change the design layout so that we can have a new component, a new view, and then fix the warnings. So I'm going to let you watch this later, but let's quickly go through what the steps are. And then I'll walk through a few things and then wrap up. So when you want to make changes to the default app, the first thing you're going to do is go into the XML for the layout. So as you can see, the XML for the layout activity doesn't currently have an image view. So what you're going to do is you're going to go in and you're going to click on Tools and import a resource. Give me a second. There. So if you click on Tools, you see there's this Resource Manager. An image is a non-code asset. So you want to put that into the resource. And when you do that, you get a helper that walks you through the process of adding an image. The minute you add that image into your code, it's now going to show up in your resources directory as one of the drawable resources. Now, all you need to do is flip into the activity main, into the design view, and now you can drag and drop an image view over, which is what we're going to do. I actually moved the text view up a little bit, flipped the fonts, did a bunch of pretty stuff. But then I can import that view, put an image view in, point it to this new image, and now I've added that right in. Again, no code, literally dragged and dropped it using the design view. And I've got that working. So if I were to kind of walk through this, you'll see at the end that, that's kind of, okay. You'll see at the end that this is the code behind it. It's now taken my drag and drop design editor and converted it into attributes that are now being able, that'll allow me to define that layout. That's all you need to do. You're done. When you kind of then go ahead and play this, you will now be able to deploy this updated app directly to your emulator and see it online. So you can see that behind there. So in the interest of time, I'm going to roll through quickly. I'll put the video on, you can see it, but I'll also put the resources on, and there are a bunch of other files that you can use. So I hope you try to make your own version of Hello Bit World. But if you got this far, hopefully, if you replicated this, you'd have installed Android Studio, used the boilerplate code to build a very simple app, created an emulator so you can test it, and then made a few changes to change the view. Beyond this, you need to scale up and do other stuff. So where can you go next? First, you need to know Kotlin. One of the reasons I didn't go too much into the code base of this is Kotlin is a fairly new language. But the great thing is there's a ton of good resources for you to learn. So go to the Kotlin language fundamental site. There's a lot of places for you to go check that out. Next, go to the Android developer site. You can get development guides that will walk you through different features. So how do I send notifications? How do I handle events? How do I create something for a background service, and so on? Then you can think about adding cloud and AI backends. We maintain a really amazing Azure for Mobile Developers page where you can find out examples of how you can do this for Xamarin. Keep an eye out for Android and Kotlin examples coming up soon. And I would be very remiss if I didn't end with the reason why I started doing this in the first place. Why is Microsoft talking about Android? Because, hello, we just launched the Surface Duo. This is one of my favorite devices right now. The Surface Duo is a dual screen multi-posture device. It's thin, and it's one of the new category of foldable devices that has productivity in mind. So you have both M365 apps and the Android Play Store. What can you do with it? Foldables is a now category in Android, but with the Duo, you have not only the ability to have multiple postures, so you can do different things based on the angle of the screen, but you have two screens. So rather than just have a single app on one screen, as in phone mode, and then have a different device for tablet, you can effectively fold this out for a broader immersive spanned layout or run it on either screen. The combination of this dual screen and multi-posture is going to unlock a huge number of capabilities for our devices. So if you're interested in that, here's Hello Bitworld running without a change on the Duo. And there's a whole bunch of code samples for Android Kotlin that you can use to get started. And with that, I just want to thank you very much. Don't forget, go check out the AKMS link. Here's a recap of what we covered: setting the stage, building your first app, and places where you can continue your journey. And I hope you will tag me at Nithya and show me your screenshots. Thank you.
Awesome. I'm all about the mobile development. Yeah, I asked earlier if mobile is the right way or mobile, because everyone says mobile. But I guess it depends, right? If you're Seth or not.
Right. So everyone else is mobile.
It's really cool. Like, I always wanted to do mobile development, but I've never gotten into it because it seemed like there was always so much to learn. But now it's fairly settled into Android and iOS. You can either write for them specifically. There's joint frameworks. There's other things you can do. It's pretty cool. Maybe it's time to wet my teeth again on mobile development. Thoughts?
I think you should. I'm looking at kotlinprogrammingllanguage.org or whatever right now, kotlin.org, and it really is a low-code app building tool, which is great because so much of the reason I don't do app building for mobile devices is because of UI. I hate building UI. It's terrible.
Yeah.
But if so much of it is drag and drop, that's pretty decent. So you're not messing with pixels and trying to like draw a square in C++. If you've never done that, don't do it.
And you've been learning a lot of stuff, like, for example, you learn about static websites, you learn about serverless.
Right.
Like, there's a distinct separation for me. It's like what I'm putting on the phone is basically the UI, and then everything else happens in the cloud. So, again, the worst part of it is that I'm not very good at designing interfaces, believe it or not.
I believe it.
Do you?
Yeah.
All right, well, we got 1 minute, and coming up, we have Tierney, who's going to talk a little bit about how to contribute to open source. He's a very good guy. We also have, coming after that, Working Smarter, 5 steps to getting unstuck. And again, we have another about, we have about another 2.5 hours of content, but don't forget that tomorrow, we have a full slate of amazingness.
Full slate. Yeah.
From folks that barely learned this stuff, but now are experts, right? Would that be fair to say, Donna?
Absolutely. So tomorrow is interesting for those of you saying, this code stuff, this is cool, this is interesting, what else is there? Tomorrow's all low code stuff. So that is specifically work that you would do within a company or a business. So imagine you'd work in finance, operations, legal, HR, et cetera, doing some sort of a tech job, and your work would be more on the low code side, contributing back to business goals.
Cameron nicely indicated that our guest is ready.
And for us to
let's go to Tierney
over
now
to Tierney.
for this good content.
Thanks, Seth and Donna. How you doing? How you doing, everyone? So today we're going to be talking about how to start contributing to open source. So a quick who am I? My name is Tierney Siren. My pronouns are he and they. I am a senior cloud developer advocate at Microsoft. I'm a collaborator on Node.js, which is a JavaScript runtime. I'm a collaborator on Electron, which is a desktop application framework. You might know it from like Teams or Slack or VS Code. I'm a delegate to TC39, which is the standards body, the committee that defines ECMAScript, which is effectively known as JavaScript. I'm a voting member on the OpenJS Foundation Cross-Project Council, and you can generally find me as @BinBang in most places. So let's get into the basics. Git. Git is a version control system that most open source projects use at this point. It is originally started under Linux and then kind of evolved and grew a lot in popularity. Some parallels can be found in Subversion or Mercurial or other kind of similar systems. GitHub is a platform that you can kind of use with Git, or Git is based around Git. It's largely used by open source projects to track their issues, collaborate on features, and kind of have a little bit more visibility or discoverability, as an open source project in a kind of commons or common space. So with Git and GitHub, there's a few primordials. These are kind of the fundamental building blocks of open source in the context of Git and GitHub. One is commits. So these are kind of units of work in the structure of Git. So like if I wrote a JavaScript file, I would commit it, or I would kind of set up a commit that had that file and the changes in it. Or I could change 10 files and have those changes in that commit. So it's kind of a way to modularize your work and kind of push it up incrementally rather than all at once. Issues are a feature of GitHub that can effectively serve as a backlog or as a tracker for kind of anything, whether it's community discussion or feature requests or bug reports, things like that. Pull requests are a similar structure, specifically in GitHub, that are the way you can submit commits to be included in a repository. So the repository is kind of like the project, and you can submit your commits through a pull request to be included in that project. This is a space that allows maintainers to kind of review it and give feedback and make sure all the tests and stuff are working. There's variations of this in other platforms, but the ideas are generally the same. So let's get into the A side, specifically contributing to a project. So in an existing project, you're going to want to look for a few different things. One of them is a code of conduct. Specifically, having a code of conduct present is an indicator of community safety, which is a good thing. You generally want to be participating in a safe community. It's not a guarantee of a safe community, but it is a good indicator that there's some thought and effort being put into community safety. If you go into a project, you're trying to contribute, you're trying to start contributing, read this document and understand it. It'll outline what kind of behavior is and isn't acceptable in the project, and kind of how you can, the standards of conduct, the standards of open source conduct in that project. So the next thing you want to look at is a license. Licenses are pretty important. If a project is effectively licensed in a way that makes it so you can't use it because of some kind of restrictions that you have personally, or in a way that you wouldn't want to use it because it requires something that would be against how you want to use open source, or if it is set up in a way that your employer actually wouldn't allow you to use it. A lot of companies have allow lists and block lists of licenses, and then you can get exceptions and stuff. But basically, having kind of a license allows you to kind of get context on that about usage, and if it allows usage in a way that's not positive to how you want to use it or how you can use it, you may want to skip out on contributing to that project and potentially find another. However, most projects are actually pretty permissibly licensed, so that's generally under something like MIT or Apache 2.0, other similar licenses. Disclaimer there, I'm not a lawyer. Take a look at the licenses yourself and ask your lawyers if you need to. But those kinds of licenses are generally seen as more permissive and more usable and contributable, largely because of how aggressively permissive they are. So, when you're looking at a license, make sure you're actually taking into consideration, can you use it? Can you contribute to it? I had a case where I started an open source project in the package manifest, so in the package JSON for JavaScript. I defined it as MIT, like there's a property you can have that's MIT, but I didn't actually include the license. And at one point, I had a friend from Google reach out to me and say that they couldn't actually contribute because the code wasn't actually licensed, like there wasn't the artifact of the license. So, this kind of thing is like something that people do and is a relative norm, especially for people who are working from their companies and able to contribute to open source that way. The next thing you want to look for in terms of like basics is a contributing.md. So maintainers write this document or write a document called contributing.md. It's often a collection of all of the useful information about how to contribute. So it'll often kind of document the expectations of the contributors and maintainers, and like how people should be contributing here, not in the sense of conduct, but in the sense of like code. So it'll document things like tooling and testing and the kind of basics of that, plus code style. So like, do you use this linter or that linter, that kind of thing. And then it'll also kind of detail how you can contribute, like what kind of things are and aren't wanted, that kind of stuff. So this document is another one that you should go and read and understand. Generally pretty well documented in here. A lot of projects keep this up to date, and it's a good kind of resource to get started contributing to a project once you've selected one and once you've found one that's relevant to your ecosystem. So again, once you've found a project that's relevant to your ecosystem, I come from JavaScript, so I generally look on GitHub for JavaScript projects or something I would want to use, something like that. But once you've found that, you'd want to look for, there's a bunch of different ways you can start looking. One of the good ways is looking for labels, repos, so projects with the label good first issue. So that is a starter label. There's a handful of others. First timers welcome, and there's a few others. Your ecosystem might have adopted a different one. At this point, GitHub has relatively adopted good first issue as a kind of platform specific one. But that kind of issue is going to be, or that kind of label is going to be applied to issues that are good for first timers. So if you're looking to start getting, start contributing, that's a good issue or label to look at. If issues don't exist that are labeled with that, which is common in bigger projects like Node or Kubernetes, where a lot of the issues have been solved, or at least a lot of the starter basic issues have been solved. And the issues are like largely complex, like super deep technical issues. There's kind of other things you can go and look at into contributing. So like, for example, you could like add tests. A lot of projects publish their test coverage. So finding areas where there's lacking coverage and going and writing some tests in whatever testing framework they've chosen, that's a good way to contribute. Translating documentation. So if you know more than one language, or generally more than English is what ends up happening. But if you know languages that the documentation isn't native to, helping translating from the original language to a second language is really, really helpful because it helps get folks from that language or who would use that language primarily into the project and using it effectively. So that's another way that you can really effectively contribute a lot. Triaging open issues is another good one. So a lot of repos have, well, bigger repos, like larger projects have hundreds, if not thousands of open issues, and going through and helping triage those and either getting more information out of people or like out of the people who originally opened it or additional people who followed up, or going ahead and just kind of saying, this is the issue. I've done some work and I found that it's probably related to this thing, and kind of pointing people in the right direction is also something that would be really helpful to maintainers and kind of help you if you do that a few times and kind of build that muscle memory. That's another way to get started, and then you can eventually get to a place where you can submit a pull request, or you can just start off with that. But like kind of triaging open issues, submitting pull requests, that kind of thing is really helpful. Another one is like if that contributing.md file isn't actually fully documented or like up to date compared to your experience with what the maintainers expect, actually updating that and maintaining that is another good way, because it's sometimes hard to balance. Here's how we want people to engage, and this is the work we really need to do to get this thing moving. So kind of helping out with that meta process is also very helpful. And then generally, if like none of those work or none of those are interesting, or if none of those are like available or applicable, going down the path of asking the maintainer. So like if I'm the maintainer of XYZ project, you come and want to contribute, we have 100% test coverage, our docs are fully translated, or you don't know a second language, or you don't know a second language outside of the base language. And like the contributing docs are great. There's no issues labeled good first issue. Asking me, I probably have something on my mind that like, oh yeah, this would be really helpful to get someone's basic input on, or like not even basic, but like someone new, some fresh eyes on, is often a thing that I hold in the projects I work on. And I know a lot of maintainers are generally pretty open to having additional people come on. So that's another way you can approach it. Not all maintainers are, and that's okay, but a lot of them are in fact open to that. So when you go down that path and you start creating issues or PRs, one of the things to pay attention to here is issue and PR templates. So specifically when you create an issue or when you create a PR, there is a there can be, not always, there can be a meta file in the repo called like, it's in the .github / I forget the full path, but it's effectively like issue template and PR template or pull request template. And those files kind of can allow maintainers to set up specific structure in issues and in pull requests for folks to follow. So if you go to create a new issue and it can pop up like, is this a feature request? Is this a bug report? Is this a question? Is this something else? Or is it none of the above? The maintainers can kind of set up templates for that. So if you're going and submitting a bug report through an issue, it's really important to go and fill all of that information out. Or if you're submitting a pull request and it has, does it pass all the tests? Like, does it have a bunch of checkboxes and that are like, you ran this, you did this, and like, what's the purpose of this PR? What does this add? What does this remove? Those kind of questions. Make sure you fill that stuff out because that's really important in reducing the burden on maintainers. And often, if folks don't follow those templates, it generally ends up getting closed just because it's like I as a maintainer or maintainer person as a maintainer cannot actively kind of keep investing time in something that like I can't get this basic info out of. So like I need this info to progress, and if I can't get it after like one or two attempts, I kind of need to move on. So that like that's the kind of maintainer's perspective that I hear a lot. So that's kind of one thing to be aware of, is just make sure you're really aggressively kind of filling out that and giving as much information as you can where it's relevant. Another thing is often bugs and features and that kind of stuff aren't unique. So like you may be coming into this project, 3 years after it was created. 2 years ago, someone wanted the same feature that you want now, or 6 months ago, or even a week ago, someone encountered the same bug that you just encountered. So in that case, or in any case, like whenever you want to go create a feature request or create a pull request, go and search in the repo. So GitHub does have search functionality that allows you to scope it down to a specific repo. And that will allow you to kind of see if there's existing work already. If there is, great. You can add your +1, or you can add kind of commentary or just even thumbs up it to kind of indicate your support or your ability, your interest in it. And if it's an issue and you can figure out a solution, go ahead and submit a pull request for that. As long as the maintainer hasn't said like, we're not going to do this, or we're never going to fix this. This is intended, or something like that. So yeah, be sure you search before you create an issue or submit a PR to make sure you're not kind of duplicating additional or making additional work that they've already done or that a maintainer's already done. So in that context, let's move kind of to the B side, which is maintaining a project. So this is going to be a bit familiar. It's largely the same context. However, it is different. And we'll get into that. So again, very important thing, have a code of conduct. It's fundamental to any project. If you're going and creating your own project, or you're coming into one that doesn't have a code of conduct, having something like the contributor covenant, which is a widely adopted code of conduct, that's a great template So that's kind of a basic template that you can kind of expand off of if you need to. You can modify it and edit it to suit your needs. But yeah, so like that is one example of a template. There's a lot of other templated code of conducts. Feel free to use those. It's worth noting though that in a code of conduct, the key thing isn't having the code of conduct, it's enforcing it. So actually acting on it. If you have a code of conduct but don't act on it, it's kind of useless. So yeah, if you are in a position where you're maintaining a project, either your new thing or an old thing, definitely go ahead and make sure you're actually going ahead and maintaining that effectively. The next thing you want to do is make sure you're licensing your code. Again, most folks can't use code if there's no license, and a lot of folks won't be able to contribute if there's no license. Again, common licenses are MIT and Apache 2.0. Again, I'm not your lawyer. Definitely get advice from legal folks if you feel the need to. MIT, Apache, and ISC are relatively common. There are quite a few licenses that allow various things. So if you want to be able to also sell a commercial license or something like that, there's licenses that allow that. Or yeah, commercial support or something like that. Like there's a bunch of different kinds of licenses. Go and investigate the ones that fit your needs. The next thing is documenting your expectations and contributing.md. So things to include here. Setup instructions, testing instructions, test authoring instructions. So like running tests versus authoring tests, debugging instructions, and issue NPR instructions. Those are all things that are really important that'll help lower the barrier for other folks who are looking to contribute to actually engage. And specifically, this isn't just useful in the context of helping others, but it's also helpful for you in that, at least I found this, when I set up pretty strict contributing guidelines, it's something that is really useful for me in kind of following what I'm doing, or like following what I say once I write it down, and like sticking to that really consistently. It's a very important thing, and it's something that I found really helpful for myself and for others who I'm working with. So that's a good one. Next thing is use labels. So labels are a feature of issues and pull requests in GitHub in general that's pretty important, or pretty effective, I should say. So using labels effectively can get you a lot of things. So to do that, you kind of want to have relevant labels. So for example, in Node, we have a bunch of labels that are specific to Windows, and we have a bunch of labels that are specific to Linux, and we have a bunch of labels that are specific to Mac OS. And those are like different kind of niche things on those platforms. We also have labels for like crypto, because that's a thing that we have to deal with. Very few people can do crypto work. And in fact, like largely it's a couple people that do that work. But when someone who can do that work comes along, it's really good to have a large set of issues, or at least appropriately tagged set of issues, that they can kind of come and help with and improve and find very rapidly. So like if I'm a crypto expert, I come in, and by that I mean cryptography, not cryptocurrency. If I'm a crypto expert, I come in and I want to contribute, or I want to improve Node's crypto. I can go find that label, and I'm good to go. And so like it helps kind of get experts in. It also, however, helps get new contributors in. So again, the good first issue label or similar labels being applied to issues that are good for someone who's just starting is a really good way to kind of help grow a open source community from scratch if you're just starting and kind of contributing yourself. So yeah, that's kind of the two human use cases. There's an additional use case of like labels are really good for changelog building and kind of context when people are going back through and trying to figure out what happened, where, and when. Again, create issue and PR templates. So specifically, I've noted before that these are useful for maintainers, but specifically they allow you to implement basic automation of workflows within GitHub. So they actually do add additional UI when someone's creating an issue. They do lower the barrier to you as a maintainer or as a collaborator getting the required context. And they generally allow you to respond appropriately if required context isn't available. So if someone's like, hey, I have this bug and your application or your tool works cross-platform, it's like, I need to know what platform this bug is happening on. I can't tell, but this is like, it's not happening here. There's 2 other systems. I can't test these right now, or something like that. And they're not able to respond. You ask again, they're not able to respond. At that point, it's like, cool, this is a bug. I'm going to close this until I hear what platform you're using, because I can't really reproduce this. And like what version of that platform and things like that. So they're useful in kind of lowering the barrier to you getting the information you need by not having to ask for it every time. And if it's not present, that's an indicator that you don't really, that you can kind of be a little bit more lenient in like closing, which is good. It's also just, so issue templates and PR templates are also just generally good TX developer experience for users. When someone's trying to ask a question, they might think it's a bug, but like if they're presented with question, bug, or feature request, they might click question, or there's a variety of different things you can do here. But it's generally a better developer experience because it allows you to get to the this pretty quick and pretty easily. So yeah, these templates that kind of set folks up for success rather than failure and lead to a general all-around better experience. So in our last couple of minutes here, we're going to go over the human side. And I'm probably going to go over this a little bit fast, just because this is kind of the chonky side of open source and the side we don't talk about enough. So pumping out code is something that's relatively straightforward and relatively common skill at this point. It's something that we're able to kind of get folks to a place where they can write code that does a thing. In open source, there's an additional factor of like people who aren't in like a corporation with you or aren't in a work situation with you. And so you kind of have to deal with people, working with contributors, politicking around PRs, discussing positive and negatives of shipping something or not shipping something, discussing small core if you want to include everything. There's a lot of different discussions that can happen, a lot of different viewpoints. And all of this involves humans. And I found that those challenges aren't actually substantially different from working in like a company or working in the space. So I actually found that it was relatively good for me starting in open source when I did, to get to the point where I am like relatively comfortable in this space. It may be a lot more comfortable in a corporate space. So if you're kind of transitioning into tech but haven't gotten a job yet, it's a kind of good way to kind of begin to understand the politics that'll happen, and kind of get used to that a bit. My notes are gone. Folks will participate in bad faith. So no matter what happens, there will be folks who come into a project that are not operating in good faith and just want to be trolly or negative and harmful. They will often skirt the lines of like what is acceptable behavior. So this has happened in projects I participated in where they follow the code of conduct, but they're obviously being detractors and not trying to be like beneficial and kind of work together and collaborate. My experience in that is ejecting those folks who are actively participating in bad faith is something that you're going to want to do as a act of help for your community and is in your project. Folks will expect a lot from you for nothing. So you're a maintainer of an open source project. You're going to have people who want things from you for free. It's okay to say no to them. This is one of the most common things that happens in open source. And if desires from others doesn't align with what you want out of a project, it's okay to say no. Folks will be hypercritical. They'll be very rude about your project and your work. It's common and expected. It's not you. It's not how you're performing or what you're doing or the work you're doing. I struggle with this a lot myself. Like it's hard to not absorb it and kind of hold that. But just know it's not you. Technical feedback is definitely not personal criticism, and often personal criticism is unfounded, and really people trying to stretch. Finally, folks will say open source should be apolitical. Folks often try to say that like diversity, equity, inclusion, and kind of efforts around that, like a COC or saying publicly that Black Lives Matter or similar issues are political and shouldn't be said in an open source project. That happens, and open source is inherently political. you got to get past it and go. And kind of those things aren't actually political, right? Like those are the things that open source kind of stands for, or at least in modern open source does. And my experience generally is that whenever this comes up, there's systems available to you to kind of get past it, but there's tools available to you. And if that's a problem that you're encountering, reach out. There's people that'll help. I'll help if you want. Yeah. Thanks, y'all.
All right. We are back.
We are.
You know what's cool about that particular session? Tierney's an awesome dude. He just laid it out. Basically, the majority of problems in tech are all people problems.
It's people misunderstanding, being jerks, etc., etc.
And the older I get, and I'm not too old. I'm like hurt my back when I stand up, kind of old, but not like ancient. I have found that majority of problems that I've encountered in tech have nothing to do with learning to code, have nothing to do with what you can do. It has to do with how you relate with other folks, right? I mean, would you say that's the case?
I think it's true. It's relating with other folks, but also how you relate to yourself. Because a huge part of tech is being in an industry that is constantly changing. It changes every day. Like today, I learned 6 new concepts that I had no idea about. And these are all things that people are doing in the world. Like all of you keep saying the word Vue over and over. I'm like, what is that? So I had to go look up what Vue was. And I'm like, oh, this is a real thing and all of you are using it. It's not a made up language. I learned what Kotlin was when I started working with Nithya. I learned Azure Static Web Apps, earlier this year when it was released. I'm like, oh, this is awesome. But it really is, you have to be okay with yourself. And you can't imposter, you can't FOMO, you can't go down these paths of, I'm doing this, oh my God, squirrel, oh my God, squirrel. You will never, ever learn tech properly if you are constantly going in 16 different directions. You learn a thing, learn that really well, and then expand to other areas. But don't get overwhelmed and don't get confused.
Speaking
I think.
of sessions coming up, we've got Working Smarter, 5 tips to getting unstuck.
That's right.
And I think that's actually really cool. Look, I suffer from burnout. I have issues sometimes. I'm just like, man, because like Don and I do some events, and there's some events that literally take a lot, not like these ones. These are fun. We're just hanging out, right?
Yeah.
But there's some events where it's like, you got to say this exact thing, this exact way, and if it breaks, a reporter's going to say something bad, and we could lose stock value, and oh my gosh, I'm going to get fired. And those take a lot out of you, and we go through burnout all the time. And the thing about us is that sometimes we get stuck on stuff that we really have to move on. And so I'm really excited about this particular talk. I'm going to listen intently. What about you, Donna? Favorite part of tech?
My favorite part of tech is how open people are to helping others. I think it's the most helpful industry. I actually have 2 other jobs. I'm a fashion designer. And fashion people are not like tech people. They are not friendly. They're not helpful. They won't share their resources. Like if I were to go ask someone else, oh, what tailors do you work with? They're like, why? And they won't share. They won't share the people they work with. They won't share their sources of fabric because they believe it's a zero-sum game. And tech, I don't think is like that because it's constantly growing. Before you know it, there's some new gizmo that we need to build software for or build hardware for. So it's not zero-sum. It's in fact the opposite. Tomorrow we'll drop a whole bunch of stats on you around the giant gap of tech skills and how we need to grow 150 million, with an M, people to fill those jobs. So do you know 150 million people? Because I don't. And those are the number of people who need to become software engineers to fill these tech jobs. So stay tuned until tomorrow.
That's right. And looks like Cameron's telling us that the next
Rukia
person
is here.
is ready. So let's go to that session, Getting Unstuck.
Hey, Rukia.
Thank you, Seth and Donna. Good afternoon, everyone. My name is Ruqayya Sheikh Mohammed. I'm a full-stack developer from Minneapolis, currently working at Suna, a really cool startup that has locations in Denver and Austin. I'm a new mom, and a little bit about me. I'm a new mom, fashion and art lover, and speaker and foodie. I've been in the tech industry, just a little caveat, by the way. I have a little cold, so please, I have a cold today, so please bear with me. I've been in the tech world for a little over 3 years now, and I came from a non-traditional background, the legal field. I made the switch, and it was the best decision I've made, and I haven't looked back since. So a little story about my non-traditional journey to tech. It started a little around 4 years ago, and I remember I had a really good friend of mine tell me that, hey, before you go into the legal field and pursue going to law school and spending all that time and money, you might want to work in the field first. So I took her advice, and I was a paralegal for a while. And throughout my time as a paralegal, I really had an inside look working with judges and attorneys, and I realized that the justice system wasn't completely always just, and it wasn't an objective system. And that really put me off. So then I started going on a journey of, you know what, I really want to know, I really want to find a different route, because that's not what I wanted to do. So I went to Kenya for a while. I moved there, and I remember I really wanted to get my foot in the door at a non-governmental organization. So I applied for a job at the United Nations, and one of the positions they interviewed me for, was a tech position internship. And I didn't really know what that software engineering was completely. So what I did was I went on all of these online resources to try to learn coding in 8 hours. Obviously that didn't go very well. So, but I remember it lit a fire in me. I was like, oh my God, this is so interesting. I really want to learn this and look into it. So I came back to Minnesota, and I was like, I don't want to go back to school for another 2 years or 4 years. I wanted to know if there was any other route to go into this industry. So I did some research, and I found out something called boot camps, technical boot camps. I found one in Minnesota, which was called Prime Digital Academy, and I applied, and it was I went through that process. I did an intense boot camp for 5 to 6 months. And then after that, I started in the tech industry. And over the years, I realized there was lots of triumphs, met awesome people, built really cool stuff, but there was lots of failure, imposter syndrome, broke some stuff. And overall, I learned a lot. But this is why I want to share some helpful tips I learned along the way. I'm a strong believer that it's not about working harder, but it's all about working smarter. What do I mean by that? In most problems, there's an easy way and a long, difficult way to get to a solution. For example, in school, your math teacher teaches you the long, difficult way to solve an algebra question before she shows you how to do it via a scientific calculator. Programming is similar to doing all the things via a scientific calculator. Working smarter ultimately gives you a priceless payoff: more time. In this talk, I'll be discussing 5 steps to getting unstuck, and I feel like I'm an expert at getting stuck, so let's just dive in. During my first year in tech, I worked on a team with all senior developers who've been in the industry for ages, and I was their first junior person on the team. It was really difficult for me because of the obvious imposter syndrome, in addition to the lack of experience and support from my team with the junior person. I was there first. There was a huge gap between me and the senior devs, but I learned one very valuable lesson along the way. I asked for feedback from one of the devs on my tech performance, and I remember one of the things he said to me stuck with me my entire career. He said, "You do not ask the right questions." I was confused because I've been told since elementary school there's no such thing as a dumb question, right? I asked him to elaborate. He said, "Ruqayya, when you're explaining the problem, you ask questions that are open-ended, not yes or no." And he went on explaining himself. And I know he didn't directly say dumb question, but that was his Minnesota nice way of saying it. I felt confused at first and more like an imposter. Not only was I questioning my questioning skills, my technical skills, but I was also questioning my questioning skills. I didn't even know that was a thing. Throughout my career, I used that conversation as a motivation to constantly iterate on getting unstuck on problems. Let's walk through a real life problem together and my 5 steps on getting unstuck to get to the right results. Let's see how we can solve this problem together. Side note, most of the terms I'll be using will be defined in the glossary for you for reference, and I'll also be explaining it on the way. I'll paste the glossary in the chat when I'm done. So I'll be working on a problem using Ruby on Rails, which is a backend language for web application, with Vue.js, which is an open source JavaScript framework. And the example I'll be going through is going to use RSpec, which is a test tool written in Ruby on Rails, And my test is using Capybara, not the animal, but a library that allows us to easily stimulate how a user interacts with our app. And the app is going to be a booking app, which a booking app with a login and create user page using Devise, which is a Rails gem used for authentication. So I know that was a lot of technical terms I just threw at you, but don't worry, you don't need to really know, memorize all those or really take it in, because I'll go through everything as we go through the 5 steps. So this is a real life problem I had. My ticket states that I need to add a system test, which allows us to test user interaction when creating a user on our app. I'll start by adding the test, password cannot be blank. RSpec syntax is pretty user readable. So basically what it's saying is it's how we're going to read it out. It should not be successful because password cannot be blank. So what it's going to do, it's going to visit a user registration path, and then within there's going to be a form there, and then we're going to fill the name input with the word test. We're going to fill the email input with test@example.com, and then we're going to click button create account. What we expect to happen is password can't be blank. Like that's what we expect the page to spit out to us. So I go to my console and run my test, and it fails. I didn't expect it to fail, and I'm not sure why it did. Now let's go through step 1 of the 5 steps of getting unstuck. Step 1, start by doing your own troubleshooting. Do you have any helpful error messages, console logs, or loud messaging that can direct you to the problem? This is an obvious step, but most people skip it. So make sure to pause and take some time to thoroughly read it. Here, there's a lot of red. It's not good. I want to see green because green means passing. Let's start off by reading the failure. It looks like it says, expect to have page cannot be blank, but it doesn't have that. I can see this because the error messaging in Capybara is telling me what it does see instead. In step 1, we have helpful error messages, what helps us understand our problem, but it's not enough. I'd like to point out at any point, if you get unstuck before the 5th step or at any step, stop. Because, for example, if you get unstuck on step 1, there's no need to go through the rest of the 5 steps. Remember, this is all about working smarter, not harder. Okay, let's move on to step 2. Start by Googling. Google specific queries. Make sure your questions is specific for your example. It's not broad. It's not broad. This is an example of doing Googling wrong. If you were stuck on a migration problem, like just copying and pasting the whole error message on there, most of the time it might not get you to the right answer. So let me give you an example. If you were stuck on a Rails migration problem, which is like a database problem, instead of Googling why am I getting a migration problem, it's best to be more specific and say how to correctly roll back migration columns in Rails. Let's try step 2 in our example. Password can't be blank. Okay, so let's see, what would a good example be? It's good to include the framework you're using, the language, and the tool. So in our scenario, it looks like we are using, I will try. So this is a more specific query. How to test create new user from an RSpec Capybara. I search what I want to accomplish, and I include my language, my framework, and my tools. I have a checklist I usually go through, which are, did I include the specific language? Did I include a framework? Did I list any tools? 2 to 3 words which you're trying to accomplish, and the obvious, put it in a question form. During step 2, most of the platforms I turn to is Stack Overflow sometimes, Dev2, Medium, YouTube, and Thoughtbot. Thoughtbot is result 3. The good thing about this is because Thoughtbot created FactoryBot, which we're using as our fixture replacement, which allows us to produce our test data. I clicked through a couple of the results and didn't get unstuck. So I guess we have to move on to step number 3. Look at other pieces of a puzzle. Take a zoom in and zoom out approach of the parts of the code to see if you missed anything. What do I mean by this? Let's use our example. If we zoom out, we notice that password cannot be blank. So what does that really mean? That the password is actually supposed to be required. It is able to be blank, so that's not correct. Next, if we zoom out, we need to look at other files that this code is affecting. Rails is a model view controller language. So we should look at these three things: the model, the view, and the controller. In our Vue.js code, everything we are using in our password input field seems to be correct. We are using something called vvalidate library to validate our password field. And that all seems to be correct. So we're looking at the view, the front end part of it, and that seems all to be accurate. So for the sake of time, let's just say I looked over my user model and controller and I didn't notice anything, and we're still stuck. So let's just move on to step number 4. This is one of my, I actually really like this step. It's to ask a coworker, a classmate, or somebody. Don't try to do everything alone. Asking someone is a tool which benefits you and the person alike. Sometimes in step 4, you get unstuck simply by speaking out loud to another person and explaining your thought process. In tech, we call that rubber ducking. When you use someone or an actual rubber duck to talk through your thought process, similar to talking to a rubber duck on your desk, this step, like in many others, might seem very obvious, but it isn't always done efficiently. From my story in the beginning, you recall the senior dev saying, I don't ask the right questions. Part of step 2 is to ask open-ended style questions, not yes or no, close-ended questions. What do I mean by that? Let's walk through an example. Let's say I ran into my coworker, Amal. An example of a close-ended question to our problem would be, hey, Amal, I'm getting an RSpec error when running my current user test. I'm not sure why. Do you know? This question does not provide any details. The answer is a yes and no, which won't allow further conversation. And thirdly, we haven't told Amal anything we tried. The right way to ask this question would be, hey, Amal, I'm getting an RSpec error when running my create user test. I'm currently using Devise as my login, RSpec as testing, and Capybara. The error in my test has a false failure. I'm expecting it to pass. I looked at my logs and it says X, and my console and it says Y. I did some research and read about Z. I read a couple of things and also looked at other files touching my test, and it's still failing. Cool if we walk through it together. This question is very detailed, it's open-ended, and it engages dialogue. And we told Amal what we already tried, so it ensures us not repeating any steps, which allows us to work smarter. What I love about this step is that you get to get unstuck simply by talking it through, and it works wonders when you unload your brain and you free it up for so much space to get solutions. After a fruitful discussion with Amal, we couldn't get unstuck. So let's move on to step number 5. Step number 5, step away. Clear your head, take a break, go on a walk, play with your baby, take a breather, and step away from your computer. Majority of the time, you just need to give your brain a break after cranking through a technical problem for a while. If you're new in this industry, you're gonna realize soon that when you're constantly working on a computer and like using that part of your brain, especially when you're new and your brain is reformatting to learn technology and all of that, it's exhausting. And sometimes all you really need for your brain to recharge is just step away. Okay, so statistics show that about 90% of North American employees that take breaks say it helps them feel refreshed and ready to get back to work. It might sound counterintuitive, especially in a hyper busy industry we are in, but science research from the Science Daily shows that increases productivity, improves mental well-being, boosts creativity, and creates healthy habits for you and your team, and just in general. I feel super strongly about this because boosting creativity because software engineering requires a lot of creativity, and taking a break helps recharge your creative juices and ultimately allows you to work smarter. I know we live in a time where now we're learning more than ever, especially being at home all the time and, you know, all the stress of 2020, that it's really important just to step back sometimes and just take a break. It actually helps you code and develop better. Okay, so today together, what we're going to do is we're going to take a speed break. In reality, your break should not be this short. Take a moment and just breathe with me. Close your eyes, actually do it, and take a deep breath for 4 seconds. Hold it for 4 seconds. And exhale for 4 seconds. Let's do it one more time. Breathe in for 4 seconds. Hold it for 4 seconds. 1, 2, 3, 4. And exhale for 4 seconds. How does that feel? Relaxing, I hope. At times, this is all of our body and brain needs to get unstuck and recharge and start again with a fresh perspective. I hope that felt great, because I honestly, it's always good. I love breathing. Now that we took a break and returned to our problem, I remembered something in step 3, the zooming out approach, that I missed. We made sure that the Vue.js front end was validating the password, but what about the back end? Let's look at our user model again. So it looks like we have an issue in our user model. We are validating the email, the name, but not the password. We can add our own validation, but since we're using Devise already, our password, our authentication, they have a well-encompassing validation module that we can call named validatable. What does validatable include? It has like, it validates for password presence, confirmation, length, and all of this other great stuff. If we add that to our user model and rerun our test, it passes. Step 5 is what we needed to get unstuck. Yay, good job, everyone. In summary, the 5 steps are: start by doing your own troubleshooting, Google very specific queries, look at other pieces of the puzzle, zoom in sometimes and zoom out, or do both, ask a coworker, classmate, someone, and finally step away. And remember, if you get unstuck at any point, you can stop at that step. And it's all about it's not about working harder, but it's all about working smarter. Throughout my career, I used these steps to never feel the way I felt that day that I had the conversation with this senior developer. I learned to change that stuck moment to a learning and empowering moment. I learned that these steps throughout my tech journey saved me lots of time and helped me get unstuck. And I hope it does the same for you. Now that I have the tool, not only did I become a stronger developer, but I became a more confident developer. And I hope if you follow these steps, you can too. I hope you enjoyed and learned some really helpful tips, and feel free to look me up in any of these socials, and good luck on your journey of working smarter and getting unstuck.
That was so good.
I know.
Thank you, Rukia. Seth and I are like writing notes.
Like I was sitting there in front of it, because we have a confidence monitor over there at the screen. And she was like, "Okay, do your breath thing," and I was like,
we did the breath thing. We didn't pass out, so that was the miracle. We breathed.
And new term,
right.
Rubber ducking.
Rubber ducking.
That was new. That was awesome.
Yeah, we didn't know what that was. So we learned things. Thank you, Rukia. That was great.
I gotta stop clicking this pen. It's like
Stop
driving me
it.
nuts. I know.
Yeah.
I know.
Stop it. Okay, so I have a hack for everyone. There's actually 2 hacks. The first one, and this ties up with Rukia's step 5, which is take a break. One thing, I read some study or something, and it says that the way to get your brain thinking creatively again, when you've been intensely focused, that's not creative, that's like work. But the way to get your brain thinking creatively is to do a repetitive, familiar task. So as soon as you start doing that, your brain gets freed up to start going in all these different directions. So if you're stuck on a problem, there are 3 things that I do that always work. One is taking a shower, because you know how to do it. You're just like kind of soothed and chill. So many good ideas happen in the shower. That's one. My second one is driving. So I just get in the car and drive around a familiar path. So not some adventurous road where I need to look up the map. I'll often get in my car and drive to the office and drive home. It's like about 10 miles each way. And the third one is taking a walk in a familiar neighborhood. So just like get out there, take a walk, and I always carry a notebook with me. And if I come across a great idea, I pull over, write it down. But those 3 things always work for me.
Speaking of writing things down, I have this
no.
really cool pen
Oh
that I
God,
bought.
the Declaration of Independence.
And
is
I
back.
also bought a moleskin. These things are these are too overpriced.
They're
It's-
really
it's
expensive,
stupid.
Seth.
It's stupid, but
You fell for the branding?
no, it's not that. It's
He
just
did.
that
He
it
fell for the
feels
branding.
like if I'm gonna have a nice pen, and now I like when I go and write things down, right? It's like
it feels official.
It feels like it's important. No, and now I know it sounds dumb, but now I really want to like write stuff down.
You should.
So-
By the way, if you write stuff down physically, you remember it more.
Yeah, look, Cameron's even like me too.
Yeah.
You know, as he gives me the not stink eye.
He's like, what are you saying, Seth? No.
He keeps telling me I'm number 1, but I don't know if that's the right finger.
Yeah.
Cameron.
You notice a trend with Seth and others. Yeah.
But I will say, look, if a lot of you are feeling stuck right now and doing like normal things, happy pandemic.
Pandemically yours.
We are celebrating month number.
A lot.
I mean, look, last week
12?
was the longest 6 months of my life, basically. And so if you're feeling yourself getting stuck, it may be a number of other things happening around the world. Let's
not
give
you.
ourselves a collective break.
Yeah, it's not you. If you feel like, oh, I haven't learned programming a new language during pandemic. Hello, we're having the greatest global disaster since 1815 or something like that. This is not normal times.
I'm having such a hard time learning how to code. I wonder why. It might be, global unrest, maybe sickies and all that other stuff. So let's give ourselves a little bit of a collective break.
Take a break. Okay, so second piece of advice that really works to get unstuck for me, and this works every time, have a textable tribe. So what the hell is that? So this is a group of people, okay, first, these are not your understanding friends. You know how we all have the understanding friends who are like, oh, that's okay, you should feel good about yourself, and it's fine you didn't do that, it's all good. So not them. What you need are the kick your ass friends. The ones who are like, oh, you didn't do it? I'm gonna come to your house and make you do it. No, I don't care about your social distance rules. Those friends. And put these people into like some sort of a chat group. You can use whatever tool you want, I do not care. But have a chat group. Don't have it be more than 5. I find 5 to be like a really good number. Everyone is engaged, very similar mindsets. You don't have to be doing the same job, you don't have to be in the same industry, but have this textable tribe. And the more they know you in a professional context and less in like your mom, your brother, etc., the better. Because they know you not as some kid who used to eat sand like Seth.
Yeah,
right?
no, mostly
Yeah.
glass and paint.
Yeah, so it's people who maybe used to work with you or know you in a professional context. But create a textable tribe. Text often. When you're stuck, just text the group. You'd be shocked at how many interesting ideas come up with from not you. Okay, we're getting the stop talking message.
Oh, already? It's only 3:24.
Yeah.
Oh, no, we still got time?
Oh, we have time.
Oh,
okay,
good.
never mind.
Okay. 6 minutes. Okay,
6 minutes.
good.
Oh, okay.
Here's the thing
He's
that I
saying
like.
move my hair because it's in my.
Oh, they're saying that hair is on the. They're
hair
so
on-
good. They're
I'm
like
gonna
over there,
shave
like.
this side. Yeah, I didn't understand what we were saying. They're like, don't do this cut. So he's doing this, right? So does this look like stop talking to you? Yeah, that's what it looks. He's saying
Don't
move
make
your
him
hair.
mad, okay?
Sorry. Jeez,
yeah,
scared.
we had this secret talk when we
Right.
turned our mics off, so he couldn't hear us. Yeah, don't make
yeah.
him mad. Here's the thing, like you gotta have the. I love the get the 5 people. You gotta have people that call you on your crap. 'Cause
Yeah.
sometimes we're just a little whiny,
We're a little whiny.
and
a lot.
sometimes we're like actually distressed, and that tribe will know if you're distressed or
Yeah.
whiny.
But this tribe, it needs to kick your ass out of your comfort zone. That I see as the biggest issue is people are very happy in their comfort zone, and that's fine. But if you really want to go learn a new thing, it's going to feel terrible. That's just normal. At the beginning, you're going to say, I suck, I'm not good at this. And your textable tribe's job is to say, excuse you, you were really bad at riding a bicycle too, but somehow you got it together and now you know how to ride a bicycle. So create your textable tribe. And that's my homework from me to you. Create a textable tribe, people who will kick your ass when you're having a whiny moment, and create your tribe and tell them your goal. This Twitchlings crew, this is a very good group. You may want to pluck a few people and form a textable tribe because you've gathered here for a reason, which is you have very common goals. So it's almost better to have a tribe of people you don't know very well because they don't feel so bad telling you you're being a whiner, stop doing that, and just focus on your goals.
People tell me that all the time.
Yeah, I know. No one feels bad telling Seth.
No, and it's actually why I'm so awesome, because I'm so, I don't know, what's
the sentence ended there.
What's a good adjective? We're gonna see. Let's see. We're gonna let the Twitch catch up because Seth is so, je ne sais quoi. Where's Laurent when I can speak French to him?
Yeah.
Stop whining.
Wow, stop whining.
I'm not
so
whining.
Seth's textable crew is the
Shirley
Twitchlings.
Dev is my textable crew. Whining.
Wow, whining.
I'm so whiny.
Seth is whining.
I'll happily be in Seth's
Stop whining.
tribe and tell him to stop whining.
Yeah, see? Other people will be in Seth's tribe. and
Maybe
tell them to
everyone's
stop whining.
first application could be a serverless application that texts me
Stop whining.
at
You know
regular
what?
or random intervals.
Just do it. Just watch Nitya's talk again. Make your mobile app that just randomly, her affirmations page.
But the opposite. Like
Yeah.
in that array of all the affirmations, just
affirmations
fill it with
page.
stop whining.
Mhm.
Maybe no
Stop
whining,
whining.
today.
No
Hey,
whining,
no
Seth.
whining.
Seth, you're whining.
How about you stop whining?
Stop whining.
Seth, why don't you?
Talking to you, Seth. Stop.
All right, so we got about 3 minutes. I want to do a little review of what we
Okay.
got going on coming up. We have
Stay with us.
confusion is the sweat of learning. Speaking of getting sweaty, coming up. I should have done that in reverse.
I don't think you should
Let's
have
just
done
reset.
it at all.
We're resetting. Okay. Speaking of getting sweaty.
It's not better the second time.
No, it is. It really is. We have the
So
confusion.
I just want everyone to know we're in this room, but it's like 85 feet apart. He's
Yeah.
all the way on the other end, and
Yeah.
that's the only reason he's still here.
Yeah.
Just letting
She
you know.
has tried to
Pandemically.
throw things at me,
Mhm. It's my throwing skills not so good. So.
but there's a gravity around his head, right?
Mm-hmm.
Confusion is the sweat of learning. Also, we have Brian Clark. Brian Clark coming back. He was here earlier in the morning.
Mhm.
He's going to tell us a little about intro to Twitch, invite
Right.
to MSDev Twitch channel to join the community.
Mm-hmm.
As you're looking around, the folks here, we have tried very hard, and you can see Cassie in the background working
Mhm.
amongst others, working very hard to create an environment of inclusivity.
Yep.
And hopefully you felt like every question you've had is respected. If you haven't, let us know, right? Or you could just create your app to tell me to stop whining. Either way, that's also inclusive. But we want to make sure that everyone understands that you may not have picked up everything that everyone laid down, and that is okay. But hopefully you picked up I think I want to look at that first more than anything else. Do that. Pick it up, take a look at it. You may not understand it all the way. I feel like I don't understand everything all the way that I'm supposed to be an expert in, like comedic genius. I'm not like a full comedic genius. Maybe like a 3/4 horse-ish.
I think it's time for our next presenter now.
Is it? Are they signaling already?
No. I'm pretty sure your next presenter is like, can I go?
Confusion is the sweat of learning.
Confusion is the sweat
All
of
right,
learning.
so I think we
With our
can
friend
see.
PJ.
Let's take a look if we have some Twitter things.
Okay, let's look at the Twitter.
So I'm going to refresh my page here. If we can go to that. Cameron,
Why are you encouraging him, Harold? Harold is
create
telling-
a textable tribe of 5 fellow professionals to kick you out of your comfort zone.
Yes.
Another great piece of wisdom, courtesy of Donna Sarkar. Maybe I had some wisdoms in there too.
Everyone tells Seth his wisdom too.
Getting
So-
unstuck. Huge fan of Bit and Bank. He helped me so much when creating my first GitHub repo. He
That's
is
Tyranny,
streaming
by the way.
live.
He's very helpful.
Very helpful. Here's Luisa Frisa. She's awesome. Yay, I got a free Microsoft certification exam. Oh!
Yay. Oh.
Speaking of the Cloud Skills Challenge, do that.
Do it.
Yeah,
Do the
you'll
Cloud
be able to do
Skills
that.
Challenge.
And
Okay.
did we get the signal already?
Yeah. No, our guest is actually here now.
All right, so
And
let's
we're
go to
ready
that.
to
And
bounce.
speaking of sweating,
We were never speaking of sweating. PJ, we're
working
so sorry.
confusion is the sweat of learning.
I'm excited to hear you talk, PJ. Over to you.
Awesome. Thank you, Seth. Thank you, Donna. Thank you, Cassie, for putting this on. Thank you, everyone at Microsoft. Thank you, listeners. I'm saying thank you to as many people as possible right now. My name's PJ. I'm going to start this a little differently than maybe other speeches have started. So I want you to imagine that you're walking through a forest. You haven't walked through this particular trail in this forest before, but you've shown up, you're right at the trailhead, and it's a beautiful day. The sun is like dappling through, the light is playing off of the leaves, and you just feel surrounded by the beauty of nature. You're walking through, the path is really wide, easy to follow, and you're just enjoying yourself. And as you're walking, you find you don't even have to look at the path anymore. It's not treacherous, there's no danger. And you're just enjoying the surroundings and seeing all the cool stuff that's around you. Well, while you're walking, at one point you do look down. You realize you're not on the path anymore. You are lost. The path is totally gone. You're standing surrounded by brush and tall trees, and just, you're not familiar with this area. And now you're a little worried. You're probably scared. You're probably nervous. Most of all, you're probably wondering, how did I get here? How did I get to this part? And so when you're lost and when you don't know where to go, what do you have to do? Well, you have to find the path again. So you start spinning around, trying to figure out where you came from, right? And you see it off in the distance. Way off in the distance, you see the path. You see a familiar area of this forest. So you slowly make your way back. You're stepping over branches, and slowly you get back and you find the path, but it's not nearly as wide as you remembered it. It's a little more narrow. It's a little less worn. There's not as many people that have been through this part of the path. At the beginning, it was wide open, easy. There was no way to get lost. But here, you have to be more careful. You have to know exactly where you're putting your foot to make sure you stay on the path. Hi, my name's PJ Metz, and I'm here to talk to you about confusion. Now, I'm making my way into the tech industry. Right now, I'm a high school English teacher in Orlando. And for about the last 5 months, I've been learning to code in C# with a brief detour into JavaScript and then back again to C#. I haven't done much. I don't have a tech job yet. I'm like a lot of you. I'm learning for the first time. A lot of the talks today that I watched on the beginning of the day were a little hard to understand some of the stuff that, some of the more technical aspects, what the speaker was talking about. So I am in the trenches with all of you, and I understand that we're all going to be a little confused sometimes. They're like, well, this person's talking about Node, and this person's talking about Xamarin, and this person's talking about, and it's terms we don't know. So we might be a little confused. Now, when we get confused, we might start to feel a little frustrated. We might be a little angry, and we might be a little ashamed that we're confused. And I'm here to tell you that that's totally normal. When you're confused, it makes sense that you feel that way. And more importantly, that confusion that you feel is one of the most important parts of learning something new. You have to be confused in order to learn something new. And that is a hard thing for a lot of people to learn. Normally, when we get confused, we believe it's because we're not capable. We believe we're confused because we just can't do it. And so we're a little more likely to give up when we encounter that confusion. And today I'm here to talk to you about why you shouldn't do that. We need to redefine the way we're thinking about confusion in order to maximize the benefits we get from it. So first, let's talk about our sweaty journey. Confusion is the sweat of learning, right? First, we're going to talk about why we're confused. We're going to talk about why we need it. And finally, it's how do we move through it? How do we get to the part where we're confused and then end up on the other side of it where we actually understand? So, as is totally normal for a high school English teacher learning to code, let's talk about neurons. So the way the brain works is there's these bunch of little pieces inside the brain that are called neurons. And when neurons are activated, it's called firing. So when a neuron fires, that's the brain doing something. Perhaps you've heard of someone saying, this part of your brain lights up. That's the neurons activating. So when neurons activate, that's your brain thinking or processing or being used in some way. So what researchers and what I understand from reading the literature on it, when neurons fire together, that means they're related, and that means that they're connected in some way. So the part of your brain that deals with math lights up, and the part of your brain that deals with the good feelings lights up. When you feel math, you get the good chemicals and you feel good. When these neurons fire together, that's the process of learning, because oftentimes they fire differently, right? They're doing their own thing. But when you're learning a new concept, it's about making them fire together. So this is actually why analogies work so well. An analogy is taking something unfamiliar and putting it in familiar terms. This is why people use analogies so often when teaching, because you're trying to get the part of the brain that understands an idea or concept and apply a new concept to that. So the title of this talk comes from our article called Telling You the Answer Isn't the Answer, and it's by a man named Rhett Allain. And it was in Wired magazine way back in 2013. At the time, I was teaching at a public high school in Melbourne, Florida, in the United States. And I taught a wide variety of classes, a class of kids that were trying to learn just note-taking skills and organizational skills. I taught regular English. I taught a mass media course about analyzing movies and film and music. And as soon as I read this article, I immediately took that tagline, "Confusion is the sweat of learning," and I put it up on the board for every class. Here's the concept. When you are working out, physically working out, or going for a run, or riding a bike, or playing volleyball, or throwing a frisbee for an extended period of time, if you're doing this outside, you kind of expect to get sweaty. You would never be lifting weights or running on a treadmill or riding a bike and go, "Wait, what's happening? I should stop. I'm getting wet." No, we expect it. This analogy says that when you're learning something new, confusion is to be expected. Confusion doesn't mean stop. Confusion doesn't mean you're not cut out for it. If you were running and going for a jog and you started to sweat and you go, "Well, I guess this just means I shouldn't jog." That's not how it works. You know you're going to get sweaty. Well, for learning, start knowing that you're going to get confused. In fact, with working out and sweating, I actually tend to measure how hard I work with how sweaty I get. So if I go and do a workout and I come out totally drenched, I'm like, that was a good workout. But if I don't sweat at all, I feel like I didn't really do much. The same is true for learning. If you automatically get the concept, it's likely you already knew it. You need to challenge yourself. In the vein of, I know I'm going to get very sweaty when working out. This is the type of shirt I need. When you sweat, the message "you can go home now" appears. So I'll know I've worked out enough when I can read that, and then I can finally go home and drink a big glass of water. So you know the workout's going to be hard. You know it's going to be difficult, but we still have these negative feelings associated with confusion, and a lot of that is because of school. School is really the first place we encounter totally new and different concepts. And the way that school is designed, especially here in the United States, it doesn't value confusion. It doesn't value question asking. It doesn't value not knowing the answer. Oftentimes in school, all that matters is getting the answer, right? So a lot of ways that a lot of classrooms work is the teacher has the information. They stand at the front, they say, "I know the answers." And the students go, "That's right, you know the answers." The teacher gives the students the answers. "Here's what you need to know." Then the students say, "Write it down in notes." And then later they tell the teacher the answer without the notes. And the teacher goes, "Very good, you have knowledge." But in that process, if a student gets confused, they're often left behind. Topics are not given time to breathe and not given time to be dove into. Topics often just move real fast. And so we don't value that confusion. When we get confused, since we get left behind, since we get lower grades when we tend to be confused, since we start to feel bad, we start to associate feeling bad and negativity and sort of stress and sadness and feeling stupid with confusion. And so we tend to avoid it later in life. In fact, there was a study at a university here in the Southeast United States that asked students what makes them more likely and less likely to ask for help. And they said that what would make them less likely is if it will make them feel stupid or they won't know what to ask. And of course, asking for help is going to make you feel a little dumb. If knowing the answer is the only way to feel smart, according to the way we go to school, when you don't know the answer, you feel dumb. You can feel this even if you do like trivia, like very minor trivia. When you don't know the answer, you start to get upset, especially if you think you should know the answer, right? So there's a lot of negativity and shame associated with being confused. And so much of that stems from school. So the first step really is overcoming the bad feelings and understanding that when you're confused, that's fine. It's totally normal, right? You're going to be confused. I'm confused all the time. I'm confused right now. I hope that everyone's hearing me, right? Like that's how I'm confused right now, but I got to keep going. So that's why we're confused. Let's talk about why we need it. Malcolm Gladwell, who's just a great author right now, he has some good podcasts. He wrote a book called Outliers, The Story of Success, and it's about what makes people successful. And one of the things he talks about is anyone can become an expert in any field or skill with 10,000 hours of work on that skill or in that field. Now, 10,000 hours is a lot of time. That's about 12 to 15 years of working full time in order to become good at something. Now, this is true for music. This is true for sports. This is true for any skill in life. If you put 10,000 hours in, you're an expert. Now, this is not 10,000 hours of understanding the concepts that apply to the skill. It's 10,000 hours of work. I'm reminded of a video of a famous, I believe they are a cello player, who posted a video of her practice session where she was practicing playing some scales and playing a song, and she couldn't get a part. And every time she got to that part, she would get frustrated and she would go back and try again and try again. And she kept messing up and she started crying. And she had this very deep emotional reaction to that failure. But then she sort of cried, wiped her eyes, and then went back at it again. That counts towards your 10,000 hours. The failures count. The failures are part of that. This is so comforting to me that all you need is time. There are, of course, barriers to finding that time, but if all you need is time, then put in the time. Be confused during it. It's not about being great every single time. Anyone who's good at anything will tell you they are terrible at some point in the process. So it's important to recognize that. I am, like I said before, I'm constantly confused, and you can actually watch this confusion live on Twitch on Sunday mornings at 11 Eastern Standard Time. That's me. I had a phase during quarantine where I thought a mustache was going to be an awesome idea, and my wife did not agree. And now that I look back on that picture, I think she may have been right. But if anyone thinks I'm actually looking good with a mustache, go ahead and let me know in the chat, and maybe I'll grow it out again. So here I am being confused on Twitch. This is actually some JavaScript, and there's a couple streams where I was so frustrated. And I only have sometimes one person watching my stream or 4 people watching my stream. But once in a while, some developers have come in and they've watched, and they're very smart about the way they help. I might be stuck on something. I'll be constantly getting errors. I'll be constantly messing up and not knowing where to go to fix things. And the developers, instead of saying, hey, you forgot to declare the variable correctly in this line, or hey, your logic is messed up on this line, they go, well, what do you think is going wrong? They ask me questions. What's that error really say? Have you Googled that error? what line is it pointing to? Is that line wrong, or is there a reference to that line that's wrong? And they ask me questions and guide me to the answer, and I find it myself. And this is important because I'm building a path in my brain of neurons. That path is going to help the neurons fire at the same time. And it is a physical process. The neurons move. These arms that they have move and shift and change to reach other spaces. So you need to create that path from neuron to neuron yourself. Because if they just tell me the answer, you forgot a semicolon on line 13, oh, then I don't learn and move my neurons into position to figure things out myself. That path makes learning easier. The first time you shift those neurons into place, it's really difficult. The next time, you've already got a path there that makes future learning easier. This is why if you talk to all these developers that have been talking all day today, they find it easier to go and learn a second, third, fourth programming language. They put in the time with their first language to learn the things that help them understand. Once they have that understanding, it's about applying that understanding to something new. This is why if you're bilingual, you can actually learn another language more easily than someone trying to learn a second language, right? Someone who speaks Spanish and English would learn French more easily than someone who only speaks English or only speaks Spanish trying to learn French. Your brain has already adjusted. So it's totally okay to be frustrated. It's normal. It's important even. That's your brain shifting and changing. That's the work, right? Doing bicep curls is hard, but it makes the muscle stronger. Being confused is hard, but it makes your brain stronger. So you can start out like this person and you can do, why isn't this working? I literally copy pasted the code. How could it be broken? And then you go, okay. I get it. And that feeling, oh my gosh, that feeling of finally getting it, and especially when you get it on your own, it is euphoric. A few developers today have talked about how good it feels when something goes right. I think that like Seth and Donna were talking about it earlier this afternoon. There's some days where you want to be under a rock and collect moss for a living. And there's other days where you're like, I'm literally the best developer in this office. Where's my $1 billion? Give me more stock. Come on, this is, be serious. I'm the best here. And then 2 hours later, you're like, nope, I was wrong. I need to increase my moss collection. They're going to fire me tomorrow. Everyone is feeling that same imposter syndrome. Everyone is worried that they're not good enough because your brain's a little confused. So knowing this ahead of time makes it easier to deal with. This is a post from the Sassy Scientist on Instagram. I really recommend you follow. This growth chart is true not just for learning, but for mental health, for physical, like if you have a physical disability or you have an accident and it reduces your mobility, that physical, what's the word? Like the physical training that you have to go through to get that back. It's hard. All of this is hard. And that first success is, I got this. And then a failure. Oh, I don't got this. And then you figure it out. And then look at that huge drop. That huge drop feels terrible. And it hurts. And you need to know that it might hurt a little. But knowing it ahead of time and knowing that you're going to get better if you keep going will help you get out of that. I need you to notice that the what's the point down here, as I point to my screen that you guys can't see, the what's the point, that's higher than where you started at the very, very beginning. You're still moving up. And by the end, you're going to be higher. It's got ups and downs. There's successes and failures. But knowing that your confusion is a normal part of it and that everyone has been confused. Bill Gates has been confused, right? Every developer that's presented today and is going to present tomorrow has been confused and come up on something that they just didn't know what to do. It's about leveraging that and making it work for you. So how do we move through it? Well, what's the last thing that you do understand, right? If you're using GitHub, like they talked about earlier, and something breaks, you go, well, that's bad. And you just go back to what worked before. Or like Donna said, go back to where there were less errors, right? It's normal. Just go back. It's not backtracking. It's looking for where things went the wrong way. And that's normal and that's good. It's good practice. I think several people have talked about rubber ducking today. Explain it to someone. Explain it to the rubber duck. Explain it to yourself. Teach yourself. The best way to learn is to teach. So if you start teaching yourself or teaching a friend what's going on, you might find where you got confused. And this isn't just advice for right now. We're all going to be confused right now. When I got to methods in C#, I think it took me weeks to finally understand it. And by weeks, I mean I just figured it out last month when my friend said, so let's try and write a method. And I did it and I went, oh, it worked. And he was like, yeah, dude, it's okay. And like he was like, that's cool that you understand it, but it's also a very basic thing. But I was celebrating, I was into it. But this isn't just advice for now. Throughout your career, you will hit confusion. And it's going to feel the same almost every time. So when you get to that part that's confusing, say, well, what worked last? And go back to it. Next is to understand that confusion is negative. Don't avoid it just because it's negative. We have a tendency that I've seen in a lot of my friends and a lot of people and a lot of society to try and say, well, that's a negative feeling. Let's push that away and let's just feel good. Overcoming negative emotions is not about getting rid of negative emotions. It's about processing them correctly and giving them time to be felt and knowing that at the end of it, there will be better feelings. It's hard when you're in the middle of being upset or sad or confused to see the light at the end of the tunnel, but you have to remind yourself, this isn't permanent. I'm not going to be confused forever. So it's about understanding it's negative, it's bad, but don't let anyone tell you, hey, don't feel bad. Say, no, I'm going to feel bad, but I'm going to feel better later. If you just put aside the feeling bad, it's still there. It just sits around and it can grow. But if you deal with it, it dissipates naturally and you let yourself experience those emotions. Last thing is building resilience. Resilience is the only thing that defines success. Resilience leads to 10,000 hours. If you put in 1,000 hours and stop, of course it didn't work out. You stopped. If you keep going, that's where you find success. Every day I read tweets from Danny Thompson and I'm like, yes, like this is the little bit of spark that I needed today. I needed to remember that I have to keep going, that I have to keep moving. Even if the progress isn't going all the way up, even if there's a dip, even if there's a part where I fail, I just have to get up, dust myself off, and take another step. Go back to the code. Go back to the basics. Take a break and come back. I spent a lot of time thinking that I wasn't capable of doing any of this. Throughout college and high school, I thought I wasn't going to be able to be a developer. I just always thought that's for math brains. I thought math brains was a thing. And I have friends that are engineers, that are developers. I have friends that are senior developers. I have friends that are working in computers. And I was just always like, yeah, because they get it and they're good at it. And that's unfair to them and unfair to me. It's unfair to them to write off their success as, oh, they're naturally good. They worked hard. It's unfair to me because I'm setting myself up for failure before I even start. I believed all the way until May of this year that I couldn't be good at coding. I just believed that it took a natural ability. And I learned that it's not. I made this website. I used ASP.NET Core and I made a website. I just added a database to it with the help of a friend. It works. It took a lot of hours and a lot of not knowing what was happening, but it works. I made a Twitter bot with a friend that retweets Shania Twain lyrics. It's Shania bot. And every day it tweets, let's go, girls. And sometimes that honestly really motivates me. It feels good. But the whole time I've done these things, these successes, I've just been confused the whole time. And it took a lot of adjustment to make that make sense. And I'm very happy that I kept going, because for a lot of my life, I really convinced myself that I just couldn't. And whenever I got confused, I quit. And I regret not getting into this sooner and giving up on myself as many times as I did. But it doesn't matter how many times you fail. It matters how many times you get up after that failure and keep going. So the next time I fail and the next time I'm confused, which again will probably be 11 o'clock on Twitch on Sunday, I'm going to keep going, and I'm just going to keep pushing through until it does make sense. I used Microsoft.com to learn TV. I used that to get started actually with coding. I've been fortunate enough to be on a great show with Chloe Condon and Brandon Minnick, who was in the chat earlier. And they have a show on Learn TV that also streams on Twitch. You can actually see them on the right side, the twitch.tv/Microsoft Developer, which hopefully you're on right now watching us. These are great places to get starting ideas, and then you just got to take it and run with it. I'm doing this Cloud Skills Challenge. I was hoping to be the first, but I got a little distracted today and didn't get to finish it. I'm still going to try and be like one of the first to finish it as much as I can. I need that certification. That's very important to me. Lastly, thank you so much. I feel so fortunate and blessed and happy to be a part of this event that's helping people just like me. If I wasn't speaking at it, I would have been at it all day anyway. But once again, I'm PJ Metz. You can find me on Twitter at MetzandAround. I have a website with a link to a bunch of stuff, metsandaround.com. And finally, on twitch.tv/MetzandAround. I'm going to be in the Twitch chat for the next 30 minutes. If you want to send me a chat on there and ask me any questions, if you want to just chat, if you want to just say, hey, I found a typo in your presentation, whatever, I'm around for it. And once again, thank you so much. You'll see me again at the panel at 4:30 talking about career changes. So thank you very much. And I hope you all have a wonderful day, night, morning, wherever you are. Thank you.
Thanks, PJ. That was so inspirational. I loved just his theories on you get out of your comfort zone and then you just stay there. It's not like you get out of your comfort zone, you do the thing, then you go back to your comfort zone. No, no, no. Stay there. You already got out of it. You know the map. You know how to leave and go to this, new world that's not your ordinary world. And Cameron's tossing his hair at me again, which means I should do that. Okay, so that was very good. I like that PJ is a teacher who is now learning to become an engineer. This is a path we've seen a few different times. Our friend Brian, our friend Minu, Jen from earlier, all people who used to be classroom teachers, now they're becoming software engineers because they see all the potential. But I found people who used to be a classroom teacher to be incredibly good at learning coding, but also incredibly good at teaching others coding. And coding teaching and classroom teaching are two very different things, but they're just very, very good at it, those 10,000 hours.
I used to teach high school. It was awesome.
You did?
Yeah. My first year I had 190 students. It was awesome, and they were all teenagers. It was fantastic. If I went back, if I retired from tech stuff, I would be a high school calculus teacher.
I believe that.
I would love it. It feels like the sessions started out with super high technical stuff, and then we're like, oh man, this is a lot. And then it ended with like, are you stuck?
Yeah.
Are you feeling a little beat down? This is you're in the right place. I
right
love how that
place.
went from super technical to, this is hard, but it's okay.
But you'll manage. You'll get out of your comfort zone. You'll do it. Like, it's okay. You don't need to do all this today, for example.
That is correct. And if you try to do all of it today,
don't do it.
Good on you, but I feel like it's not going to be good for you.
Don't do it.
Do the breath thing 2 times for 4 seconds, in and out.
The breath thing. So we just got the gesture.
Did he give us the signal?
Oh, okay. So now Brian is back. A lot of you are saying you really like this Twitch channel and this is like a cool experience, et cetera, et cetera. So Brian is going to come and share with us how to actually be a part of the Microsoft developer community, especially in a streaming point of view. Brian, please come back and tell us how to do that, because I've never Twitched in my life. But today was really fun, so I kind of want to do it too. Though I still feel uncool. Where'd he go? He's not here. Oh, he's back. Okay.
Houston, we're live. Yep. Yep. Oh, yep. Just kidding. I know. We're live. Hello, everyone. Welcome. Thank you for sticking around to the end here. And we have more to go after this, so don't go anywhere. Hopefully, I can bring the energy back because I, you know, it's that time of day. You're feeling a little lull. Maybe, you know, grab that tea, grab that coffee, whatever you need. And let's get into talking about Twitch. Now, I'm going to cut right to the chase. I'm Brian Clark. I go by Clarkio, but let's cut right into the intro to Twitch. I want to talk to you all. You're here. You're part of this conference. You're viewing the conference, and you're looking to make maybe a change into development, right? You're trying to start that career. You're looking for a new start. And the reality of that, right? Maybe you're looking to get a job in development too, right? And the reality of that is it's going to take some time, kind of like what PJ was talking about. You're going to have some failures. You're going to get through that. Excellent talk by PJ. Shout out to PJ for that. But it's going to take some time. And one thing you can do while you're taking that time learning stuff is documenting your journey. And the reason I bring this up is I want to share a story of a buddy of mine. He doesn't go by, his name is Danish Gajar. And he's somebody that I met on Instagram. And I'll tie all this in, why I want you to document your journey with all this stuff while you're learning development and going through this process. Danish was somebody that was working in a different industry as well. And I know you heard a lot of several stories from folks today, and you're going to hear more tomorrow. But in particular, Danish's story is interesting to me because Danish was working as a designer, so not too far off from the development industry, but enough to where he wanted to make the change to jump over to development. And while he was doing that, he started doing things like using resources, tutorials, courses online. But while he was doing that, he was documenting his journey. And what I mean by that is for him, Instagram was like a home for him, and he enjoyed that social media platform, but it could be something different for others. But for him, it was Instagram. And so what he would do is he would post pictures of his code or his just setup. And then in the post itself, he would describe what he was learning. And he was learning about CSS. He was learning about HTML, some JavaScript. And as he was doing that, it was great for him because he was keeping a reference of everything he learned so he can go back and look at it in case he needed a reminder. But he was also sharing that with the community. So other developers on the platform, which there are quite a bit on Instagram, by the way, he was sharing it with them so that they can find it helpful and get value out of it. But then on top of it, here's the really interesting thing that surprised me when I first heard it, was he actually got a job because of all that. His current employer now, and his current manager right now, had reached out to him via DMs on Instagram saying, hey, you know, I've been seeing this journey you've gone through. I love the progress you've made, and I love what you've been sharing. Would you be interested in taking an interview with us? And then that's all she wrote, kind of thing. And he has the job, and he's been working there ever since. And I really believe that that's one way. I'm not saying everybody has to go through this, but it's a nice way there's lots of value in doing that. And that's why I bring up that story. Now you might be thinking, well, Brian, that's Instagram. You're supposed to be talking about Twitch. What are you doing? It's just another platform, right? So Instagram is documenting it one way. Twitch is another way you can document your journey as you're learning and doing this thing. You're going through this process. And so, in fact, I have another very quick story. There's another buddy of mine who streams on Twitch, and he was already an engineer, but he was getting into developer relations. He wanted to, and he was streaming, and they checked out his streams, and that helped him land the job that he has now too. So to give you a more concrete example of that, but that out of the way, hopefully that inspired you to think maybe I could try out Twitch. Maybe this might be for me to do that, to document what I'm doing as I go through this. So enough. Moving on. Twitch, what is it? We talked about this a little bit at the beginning of the conference, but if you missed it, here's a quick reminder. Let's start sharing my screen here. So when you go to twitch.tv, you enter that into the URL on your favorite browser, you get this presentation. You get this UI that shows to you, this user interface. And the main thing you're going to want to look for is the search bar at the top. You type in there where everybody that's streaming programming, they typically stream under the category science and technology. Now, I say category because they're typically with Twitch, it's known for gaming, and a lot of times folks would think of it as different games. Somebody might stream Fortnite or Microsoft Flight Simulator or Minecraft, right? Those would be game categories, but Twitch has opened up to having other categories as part of their platform. One of them being science and technology. There's art. There's all kinds of different content. So even if maybe you are familiar with that other stuff, maybe you have skills in another area. Maybe you're an artist, right? For fun, you could stream that stuff and start doing that. But we'll get into the weeds of that in a minute. So science and technology, that is where folks that are programming stream under that category for the most part. So you search for that. It'll bring you to this next view. So in here, this is going to show you all the live streams at the moment in time that you searched for the science and technology category that's streaming under this category. From there, you're going to want to probably look at tags because that's going to let you zoom in on exactly what it is, what type of programming what type of science and technology stream do you want? Because there are other things going on in here. There's like ducks and chickens and turtles and earthquakes, which is science and technology related. Yes, but may not be what you're looking for. I mean, check it out if you're interested. You might like it. Apparently, you can feed them, according to that first one on the bottom left there. But you want to get into the programming streams, right? So you look at the tags there, and you can click on those or add those to your search, and that will, drill down into the programming streams. From there, once that's done, you get your results, and that's what all those little rectangles are. It's like little TV boxes, and you could see what people are streaming. You get a little snapshot, like a little screenshot of what happened at that moment in time, potentially. It's not like a live view, but it's a live moment from that stream. And then from there, what you would want to focus in on to help figure out which streams to watch from there is the bottom section underneath those little screenshots. The text that's in bold there, that is the title of the stream. So a lot of times you'll find, at least with the programming streams, they'll get a little bit more specific of exactly what they might be doing. Sure, they're doing programming, but what type of programming language are they doing? Or what programming language are they doing? What type of project are they working on? Is it a web app? Is it a mobile app? Something like that. They'll usually describe that in the title. And then below that, the text that's not in bold, like dash ducks there on the left side, that is the name of the channel. And then below that are those tags that are associated with the streamer's stream, that current session. So that's a quick overview of the science and technology. So let's say you found a stream that you want to watch, okay? And it's not going to be blurry like this. It's going to be this blurred out area. It's a snapshot from one of my streams. It's going to be this what's happening on the screen. That's the one side, the big rectangle in the middle there. And then on the right-hand side is the chat. The chat room, which speaking of, I need to get the chat up for the stream. How dare I? The chat room is where you get a chance to engage with the streamer and other people that are in the community that are watching the stream. So you can have conversations, help each other out, learn from each other. You can help out the streamer. The streamer can answer your questions. This is where all that interaction, that community building happens, is in the chat room. So shout out to the chat over there on Twitch, Microsoft Developer. I see Chris Jones messing around. And folks, thank you for being here. Thank you for tuning in. So that is what Twitch looks like for you, that those of you that may not be familiar with it haven't checked it out yet. Moving on. Why does Brian care? I'm Brian, by the way. Why do I care? I was going to share like a story about, well, I guess I'll really quickly a story about why I got involved with Twitch streaming. I joined this team. I didn't really know my place. I felt like imposter syndrome, which was talked about. Like I felt everybody around me was these like amazing, they are amazing people, not what were, they are amazing people. And how do I bring value to this team? I'm not trying to like do what they're doing, but like, how do I, as Brian, bring value to this team? And I was struggling with that. I was getting kind of depressed about it. And then I was like, you know what? I'm going to try out experimenting, connecting with developers on different platforms like Instagram, like Twitch, because a lot of us were focusing on Twitter. It tends to be the place that people focus when it comes to development, is Twitter being the platform. And that's true. Like there's a lot of developers on there, but I was like, let me try something different. And when I started streaming on Twitch, I just felt this sense of being a part of something. I just got lifted up, and the community was just really warm and like welcoming and just supportive. And that's my big reason why I still stream week in and week out. And so that's my reasoning. And I feel like the reason I talk about this is because I feel that others can get value out of this, whether you're a viewer of a stream or you stream yourself or both. I think you can get that same value. And that's kind of what I'm hoping to instill through this talk today. So let's now talk about, there's that two roles I kind of mentioned there, right? There's a viewer and there's the streamer. Now you can take on one or both of those roles if you'd like. Let's talk about each individual one a little bit more to understand what's the benefits and reasons why you might care as a viewer. And through this, I'm going to draw parallels since Twitch is very much known for gaming and streaming games. I'm going to draw parallels from the gaming side of things to the programming side when it comes to streaming that type of content, So the first one is exploring and discovering things. What I mean by this, like the value of this live streaming platform and being able to explore and discover content is, well, I really go back to the story with gaming. When I was younger, I never thought, when I was younger, I never really liked watching a friend play a video game. Like you'd be at their house and it's a single player game, and I'd just be frustrated. I just like, I want to try. And I was like, when Twitch came up and I heard about that, I was like, why the heck would I ever watch somebody else play a video game? And then I realized, well, one of the reasons or the value you can get out of it that I found I could get out of it is maybe I don't want it, when I'm looking into getting a new game, especially at that point in time, everything was $60. So that was quite the investment to drop $60 on a game, but you're not fully sure if you're going to like it or not. So with watching somebody play the game, that allows me to explore new games, discover new games that I might like, and it'd be worth investing my hard-earned money in. So that's with gaming. The parallel there with programming is you're thinking about, hey, what programming language should I learn? Which programming language seems interesting, will work well, will resonate with me? Well, you can start watching folks that are streaming Python, that are streaming JavaScript, that are streaming C#. And you can learn whether or not it's something that you want to invest your time in. If you're understanding more easily somebody that's streaming C# versus somebody that's streaming, Cold Fusion or something, I don't know. So that's, to me, one of the benefits as a viewer is you can figure out what you might like, what might be your interest. From there, we're talking about learning and getting better as a value as a viewer. So going back to the gaming situation, let's say you like a game and your skills there have kind of plateaued. You want to get better and you're struggling to do that on your own. What do? Well, you can watch somebody, especially in the gaming side of things. There's people that are getting paid. They make careers out of playing video games, and they play for hours on end and get better and know the ins and outs of these games, and they stream it. So you can watch them and learn about the little tips and tricks and strategies and tactics that they use and apply it to your own and start leveling yourself up, leveling your skills up in that game. The same can be applied to programming as well. So maybe you did decide that you want to go with C#. You're still struggling to gather the concept of like inheritance or something like that within C#. Well, watch some folks that are doing C# that are using inheritance and applying it to their projects, and that will maybe make it click for you. You can level up your skills in that way. Those are two options there, or two possible benefits I see as for viewers and why they would care. The other thing is real life, real time interaction. Now, I don't have a gaming, I mean, it applies to gaming as well, but specifically to programming here. When it comes to learning new things in this industry, we tend to lean on courses, tutorials, instructor led, classroom type things. And those are all great and well. And specifically when it comes to like the tutorials and courses or the videos online, it's kind of like they go from A to B, everything just works and rainbows and butterflies, right? But when you go to try it, you stumble. There's some hurdles. There's some things that maybe you missed that you forgot and you got to go back and watch. And it doesn't always go as planned as it did for the instructor in the video. When it comes to live streaming like this, you can see the behind the scenes, the raw experience of working through projects and working through learning something in real time. And you can see what that is, you can get that real experience, the more real life experience. So to me, it's supplemental. It's not saying the tutorials and courses don't bring value. They absolutely do. I just believe it's supplemental. Maybe for some people, it might be the primary and better way for some folks, because everybody learns a bit differently. It might be the best way for you to learn. So that's one of the benefits there as a viewer is you can get that real time. And on top of it, you get the opportunity to interact with the person that's learning this or maybe teaching it and sharing their knowledge with you. If something doesn't click for you, you don't quite understand it, you can say, hey, in the chat, I appreciate you talking about this, but I didn't quite understand that part. You kind of elaborate on that a bit more. And then a lot of times, because of how nice the community really is and the streamers here on Twitch, they'll pause, they'll stop what they're doing, and they'll try and help you out and show you and explain that a bit further. And last but not least, the community and social aspect when it comes to live streaming, because it's in the moment, people are coming together, albeit virtually, it still feels like you're there. You feel like you're a part of something. You feel like you're part of the team, and it's just a nice human interaction, human feeling thing that I personally find to be quite valuable and beneficial as a viewer and as a streamer too, honestly. Which leads me into the next part. As a streamer role, why would a streamer care? Why do you want to stream? And really quick going through these, you get a chance to reach new audiences, right? Some folks may not be on Twitter. Some folks may not be on Instagram or whatever it may be, right? They may be tuning into Twitch for their stuff, for the type of things that they do more leisurely. You get stronger engagement, I feel, right? In terms of like having that real-time feedback, being able to interact with people in the moment and get feedback on like, hey, is this working? Is this making sense what I'm talking through here? And then for those of you that are interested in doing more presentations, getting prepared for talks, constantly doing this, constantly streaming is building up that resilience to, work out the butterflies. I mean, to be honest, I still get them. Work out those butterflies before doing a talk, and just get you better prepared, get you more practical experience doing that without having to necessarily, especially during the current times, without having to go in person and talk in front of a group of people, physically being there. All right, so how? Right, I kind of convinced you, maybe to get started streaming, and you're wondering how do I get started? Well, we have a community-driven document, a guidance that we started creating up on GitHub. So if you go to this link, you go to aka.ms/Clarkio stream guide, you'll be able to check it out. It's rough right now, to be honest with you all, and it's been a little while since I've tended to that repository, but the value is still there in terms of what documents have been written up in the guidance that we have there, and we can evolve. And if you have input, I invite you all, especially in the chat, those of you that are interested, to contribute if you'd like, and add your thoughts and ideas and questions you might have that we can answer as part of that guide. So check that out if you'd like. But we're not done. So let's say you've committed to yourself. You're like, you know what? I'm going to give this a go. I'm going to try this. Thank you, Brian. This was wonderful. What advice would you give me to somebody new getting started with streaming? I got you covered. Don't worry. First of all, I would say try your best to work towards a consistent schedule. Now, I know everybody's schedules are probably all over the place and you got a lot going on. So that's why I say try your best to work towards a consistent schedule. And the reason I suggest that is because when you think about like a typical TV show, XYZ show is going to be on Tuesday nights at 9 p.m. Eastern or something like that, right? And so the folks that enjoy that show can carve out time in their day to make sure they can be there to watch that. And that's the idea here. If you want to, the more consistent you are, the more likely folks will be able to plan ahead to be there and join you for that stream. In addition to that, I would say keep it simple. Don't worry about getting all the bells and whistles, getting a fancy microphone, lights and cameras and all that stuff, because one, it's quite the investment. And two, you're just getting started. You don't know if you're going to really want to keep up with it or if you like it. And that's okay if you don't like it. It is what it is. Maybe posting, doing blog posts or something like that to keep yourself accountable and document your journey might be the way to go. Twitch is just one way. Live streaming in general is just one way to potentially do that. So keep it simple. And I'm going to show right after this slide what my first stream ever looked like so you can understand and get an understanding of what I mean by that. Keep it simple. Don't worry about getting all the bells and whistles with hardware and devices for streaming. And keep it real. Just be yourself. Be genuine. Don't worry about having to impress anybody or just because people will feel that even though it's virtually done, they'll feel whether you're just kind of putting on show kind of thing and whether you're being real, you're being true to yourself kind of thing. And that's what's going to cause people to connect with you or not, I think too, is how just genuine you are with yourself and with your audience that you have. And then don't overplan. And the idea I mean with that is I've seen folks go the route of basically treating live streaming like you're doing a conference talk, which is fine. I think it's good, but I don't know that is sustainable. Or I don't believe that is sustainable. And that's why I say don't worry about overplanning it. I think having a general goal in mind, maybe some outline you want to try and follow for a stream is good and all. But to be honest with you, maybe this is good, maybe this is bad. I don't know. People seem to like it, but I generally wing it. I just have an idea of what I want to try and do. I want to add a feature to my project, or I just want to talk through something. And if I get through that, good. If I don't, as long as I made some progress towards it, that's kind of how I approach each stream. Well, at least some of my streams. So that's the advice I have for you all with that want to get started with Twitch. And then here's that example I was telling you about with my first stream. So you could see I just took like my built-in webcam to the laptop I had. I just plugged that camera into the corner, and then I shared my screen, and I used the microphone on my like built-in laptop microphone, and I just clicked let's go, right? And then in terms of what to stream, I didn't know at the time. I had no idea what to stream. I didn't have a project or anything like that thought up. And I was like, you know what? I know about all these code challenge websites that can just help me practice my skills, my programming skills. So let me dive into one of these. This one in particular is called I don't know why I was fumbling on that. It's called codewars.com. For those of you in chat that might have heard of it, let me know. But there's a bunch of them out there that you can check out. So yeah, so that was like what I decided to do. I was Saturday nights, and off we went. This was back in January 2018, I want to say. And you can see, like, I wasn't looking at the camera right now. I'm looking into your soul right now, right? That's what you got to do when you're on camera. No, I'm just kidding. You just look at the camera, engage with the people that are kind enough to spend time out of their day to join you in the stream and join you for this conference talk too. So thank you everybody in the chat. By the way, Seth and Donna, we I love the name Twitchlings. I think I might steal that, because typically the way I've always, at least the Twitch culture, the way we address chat is we call chat. Say, hey chat, how you doing, chat? What's going on, chat? That kind of thing. But now I kind of want to be, hey, what's up, Twitchlings? But yeah, thank you for that, Donna and Seth. Appreciate it. All right, so what do you need to get started streaming? Well, you kind of need a decent internet connection. In particular, your upload speed has to be fairly decent. I typically recommend about 5 megabits per second per pixel. Why do I want to say pixel? It's late here in the evening on the East Coast where I'm at, and I'm struggling. So stick with me, folks. All right, I'm sorry. 5 megabits per second upload speed is kind of what I would hope you know, if you can get that. But I've heard of people being able to stream with less. A computer, duh, right, Brian? A microphone, a camera, optional. If you don't feel comfortable being on camera, that's fine. I've seen people have success without a camera. I just feel that a camera is an added benefit. It creates a more connection with the folks that are viewing your stream, and it's a face to the voice, and yeah, that's kind of why I suggest that. But you don't necessarily need it. And then broadcasting software, the de facto one that's free and open source is called Open Broadcaster Software, or OBS for short. That thing can be quite cumbersome. There's lots of other tools out there, like one is StreamYard. There's Restream. There's a bunch of them out there. If you need some help, that streaming guide and I'll have the link again at the end, will help you get squared away with doing that. And then just figuring out something you enjoy. So if you're looking to learn JavaScript and you just want to do some code challenges with that, try that out. That's a good way to get started. Or even like preparing talks or something like that. Whatever you feel you enjoy doing. It doesn't necessarily have to be programming. Give it a shot. Try streaming it. What now? Keep in mind, who's this for? Who are you going to be streaming for, or who should stream? Some people might think, well, you have to be a senior dev and have 10x in your title, 10x developer in your title, or something like that. No, it's a bunch of junk. I really believe anybody, regardless of experience level, should give it a shot. For one of the reasons, let's take it this way. Maybe you're new. You're folks that here in this conference, you're new to streaming. One of the ways I really feel that you bring, like I was saying earlier in the conference, you bring a new perspective to learning stuff. When it tends to happen with folks that have several years of experience in the industry, we take for granted the things that we have learned. It's called sometimes referred to as the curse of knowledge, and forget that that's something that, even though it comes so natural to us now, it's not actually that natural. We struggled with that at one point in time, and we need that reminder. And it's helpful to see that, right? Whether you're a more senior experienced developer, or you're just a fellow, newbie to programming, right? Everybody can learn from each other. I really believe that. And so this is not necessarily just senior devs, experienced devs that should be streaming. I think people that are new and wanting to document their journey and, doing that and connecting with the community to help you and support you through that journey, this is a great thing for you as well. Know your audience, get to know your audience. Keep that in mind. Keep them engaged into it. Don't just, sometimes we get into a train of thought and you're going to keep streaming and working on that, but then make sure you check back in with the chat. And then beyond that, listen for feedback. The community is fantastic with this. They'll be like, hey, your audio is off. It's not sounding good. Or we couldn't actually see that because your camera was blocking it, or whatever, things like that, whether it's production related or programming related. listen for that feedback, use that to help iterate on your stream and become better and improve. And that's it, folks. That's all I wrote. There's that link again, aka.ms/Clarkio Stream Guide. It's a GitHub repository, and it should help you out with getting started. If you have any questions, I'll be hanging out in the chat for a little bit longer. I know I didn't get a chance to really, answer to folks that were in there as the session was going on, but I'll be sure to catch back up anybody that tagged me. Just do @Clarkio in the chat, and I'll be sure to check it out. All right. Thank you all. Have a good rest of the conference. Back on over to Seth and Donna.
That was so good.
We didn't decide who was going to go first.
No, so we're both yapping at the same time.
It should be you. It should be you.
All right, it should be me. That was really good. Who thought that was good? Chime in on the chat. That was wonderful. Okay, I thought so too. Brian's almost convinced us to become Twitchers and refer to random people as Twitchlings.
I told our AIML PM Vanessa, because she tells me like what I should be doing and what I shouldn't be doing. I want to do some twitching, and she's like, "Are people gonna watch that, Seth?"
Yeah.
Maybe.
She said it just like that too.
Yeah.
Are people gonna watch you twitching? Seth.
I think it'd be fun. I mean, like one of the things for me is that when people are watching me do something, I like get extra hyper focused in making sure that everyone understands what I'm doing. And as I talk through it, remember the 5 tips to get unstuck? I start to learn what I'm doing, and so maybe I'm just going to do it selfishly to get unstuck.
That might work. Yeah. By the way, there's a really good conversation going on the Twitch with the Twitchlings around how do you overcome fear of public speaking and like just kind of get out of your comfort zone and go do it. And I will tell you my hack to get over a fear of presenting something that might be new. The reason you're afraid of public speaking is because you've never talked about this topic before. That's why. You're not afraid of public speaking in front of 5 people who you know and talk to all the time because you know that topic and you know these people. But my hack is to just put a date on the calendar 3 months from now and say, I'm going to give a talk on this topic and I'm going to give it to my textable tribe. So it's super safe. Remember, you have your textable tribe and say, we're going to get on a call and I'm going to give a talk to them on whatever topic. Python, JavaScript, AI, ML, Power Platform, does not matter. I'm going to learn a tech and I'm going to give them an introductory lesson on it. And they're going to give me feedback and tell me what else I can be doing. So it's not so scary where you're going to flee the country because it's not in front of 5,000 people. But it is important enough where if you don't meet it, they will yell at you. So that's my hack. And I do that for everything. I use it to get motivated for the most random things like, oh, I need to give this talk. I don't feel like writing it. I don't feel like learning it. I don't feel like studying it. But if I tell my tribe that I'll give it to you on January 4th, oh, it's going to be ready. It is.
Talk-driven development is what I call. Basically, the way my life works is I have a deadline to get this thing done, and then I got to get it done. And it's just like, right? But another thing, when you're speaking in front of people, literally the worst thing that can happen is you look foolish.
That doesn't actually happen.
Which makes it funny, which is good. So anytime I get on stage, I'm like, Seth, the worst thing that can happen is you're going to look foolish, which is funny. Live it up, right? And I mean, everyone's learning something. As soon as you recognize that, it's like you got something that nobody else has learned in a way that nobody else has learned it. And truth is like a ginormous ball, and we're little tiny specks living on each little part of it, and I want to know all the truth.
Yeah. And the thing that everyone gets hung up on is, oh, why would I give a talk on Intro to Python? Because so-and-so gave one here at Start Dev Change, or it's been given so many times. But why do you think there's so many introductory tutorials out there? If you look, there's always more introductory tutorials than there are of any other level because people are always looking for more introductory tutorials. They want different backgrounds, different stories, different methods, different techniques. They want your specific story. How did you come to learn about Python? What was your technique for learning it? What are you building, et cetera, et cetera?
If you see me pointing, it's because Cameron told us
we need to shut up.
It's time for the wonderful career panel with interactive
it's time
chat
for the career panel.
To talk to other career switchers and ask questions. We got Danny Thompson, April Spade, Philip PJ Metz, teaching learning to code. Cecil, Sophia, Aisha Brown, Cassie B as the moderator. I'm so excited. Let's go to that right now.
Let's go.
Hi, everyone. Welcome to the Ask Me Anything Career Switchers panel. I'm Cassie Brevu, and I'm a cloud developer advocate at Microsoft. I've probably been chatting with you in the Twitch channel if you've been hanging out with us all day. And today I'm super excited because career switchers and people that are self-taught developers is something I'm super passionate about. I'm a self-taught developer. I literally wrote my first line of code in Excel. And now I have a panel of people from a variety of backgrounds that are here to answer your questions about career switching, about how to get started, and all those good things that, you know, people have already been asking in the chat. So let's get our panel. Awesome. There they are. And first, let's just start with introductions. And why don't you all talk a little bit about how you got started in tech and what advice you might give somebody that's getting started. And we'll start with Aisha.
So, hello, I'm Aisha. I'm a program manager on the Fast Track for Azure team in Azure CXP. I got started in tech because my first job was at a mortuary, and I felt like once I did that, I wanted to be somewhere where people could talk back to me.
Oh, okay, and then let's move on to Sophia.
Hey everyone, my name is Sophia. I'm currently a software engineer at Free Will. I decided to make a career transition to software engineering last year in August. And so since then, I've spent about the past year learning full stack development. And last month in September, I joined Free Will as a software engineer. And yeah, outside of coding, I enjoy doing some indoor rock climbing and also baking sourdough bread.
Awesome. PJ.
I have not started in tech yet. I started learning to code in May. And if you're listening, I only need to give my current job 30 days notice if you want to hire a really handsome half Puerto Rican guy who's still learning how to code. But yeah, it's I'm just excited to be here. This seems like not a place I'm supposed to be at all. We're starting early with the imposter syndrome for me, real early.
All right. Danny.
Hi, I'm Danny Thompson. I am a software engineer. I learned how to code on my own and all that good stuff. And on top of that, I am a community leader of the largest group of developers in the Memphis area. I've helped over 70 people land their first jobs in tech. And one of my big goals is to try and bring as many tangible resources as I can to those that need it. And so far, I've helped give out courses, books, resources, and anything that you could possibly need to make sure that you are learning and growing. And the last thing that I do is I speak all over the world at events like this and boot camps, conferences or companies. If there's a way that I can help somebody, I want to be there to do it.
Awesome. And then Cecil.
Hi, everyone. My name is Cecil Phillip. I'm a developer advocate here at Microsoft. Originally, I'm from the Caribbean, born and raised, grew up little tiny island called Antigua. And, I started programming because, one summer I was at home and, computers wasn't a thing that we had in like high school and, schools and stuff like that. And, one day my dad brought home a machine and it had a bunch of books and I read some books and I was like, oh, this is cool. Like, this is kind of what I want to do for the rest of my life. And so I kind of had that, like a little bit of self-motivation to be, hey, well, I don't know where this computer thing is going to go. All the people that are around me are doing something different. Let me take a shot at this and try it out and let's see what happens. And here I am today.
Awesome. So when people are getting started out, a lot of time, they're trying to think, where do I start? How do I gain experience? And how do I get that first job? And one of those things about that first job is, do I choose a big company or a small company? And so what would you say about big company versus small company? What would be the kind of pros and cons of each one? And we'll start with Aisha.
So big company versus small company, I don't think it matters the company. I think it matters the responsibility. I would say just go for it. Get yourself a mentor. You need 3 types of mentors. You need a mentor that's been doing it for a really long time, one that's brand new, and one that's in a position you're trying to work to. You've leveraged those 3 different resources, and you'll be able to learn as you grow, learn, and work your way into that next level. But as far as picking a company size, it doesn't matter the company, it matters the responsibility, because you can be at a tiny corporation working completely ridiculous hours, or you can be at a big corporation working comfortable hours, or vice versa. So do what works for you. What you want to do is be somewhere where you're being challenged.
That is a really good point. And the mentors thing is a fantastic point as well. And yeah, when you interview at a company, you got to think about you're interviewing them just as much as they're interviewing you, and finding a culture that will be a good place for you to start. Anybody else want to just answer this? Should I raise your hand if
Yes.
you want to answer it, or I can go down? Cecil, you want to answer?
Sure. I totally agree with what Aisha is saying. I'll give a little bit of a personal take on what it kind of was like for me. So I've been in the industry for about 10 years, but I haven't been at Microsoft for 10 years. I came out of college. I didn't go to Ivy League school or anything like that, and I started working at a university. Actually, it was my first job. And we didn't build applications that were used outside of the university, right? It was like the guy down the hallway was the person that was my customer. And I can tell you from working at a smaller shop and going out to a bigger shop, I was definitely in a place that, well, no, I didn't have a mentor, but that's one thing. But working at a smaller shop like that, I kind of had to do everything. So I was the business analyst, and I was the software tester, and I was the developer and the designer, and I did the UI and I did the database. I had to do the whole thing. You know what I mean? And then when there were issues and when there were reviews and when there were demos, I had to do the whole thing because the team was only so big at the time. And I think there's pros and cons to that, right? Like the pro is you get to understand the entire life cycle, right? You get to not just focus on one piece or the other, but you get to understand how the entire thing works. The bad part about it is that you get to understand how the entire thing works, and you don't really get to specialize. And we haven't spoken about it yet, but one of the things that you want to talk about when we think about longevity is specialization. You know what I mean? And at some point in time, you realize you can't do everything, you can't learn everything, you can't be everything for everyone in an efficient way. So now we got to think clearly about how that works. And so now, as I moved on to work at larger and larger companies, I started to become more and more specific about not only what I wanted to do, but also the jobs that I applied for. You know what I mean? And so now, now that I had that understanding of here's where everything kind of is, and generally speaking, how people approach the job, now I could be like, okay, well, this is the thing that I want to do and I care about. And so now not only am I going to talk to my managers about those types of opportunities, when I look out for advancement in other positions in other companies, I'm going to start looking for that as well.
Yeah, that's a really good point. Specialization and picking something is so hard, especially when you're first starting out and there's so much stuff. We went over a lot of different topics today, and that was kind of intentional to show you all the different types of things you could jump into, right? But it can be overwhelming too. So how do you think someone should go about trying to pick a specialization? Danny, it looks like you have something else.
To pick a specialization, I would say the one thing that I tell people all the time when they ask me, what should I learn to code? I always send them in the same direction. Learn HTML, CSS, and JavaScript. And it's on purpose. I don't necessarily think web dev is the number one route for everything, but it's hard to say I like backend when you've never coded backend a day in your life. Or it's hard to say I like mobile development when you don't know what mobile development is. I truly believe that education is a window that you can peer through. So when you at least have a very limited understanding, if you go on a website like freecodecamp.org and you spend about a month, you're going to learn the basics of HTML, CSS, and vanilla JavaScript. When you're in that scenario, now you can understand, at least on some level, some degree, what Python is, what backend may be, what front end may be. Do I really like setting up the front end of a website? Do I like the beautification? Or am I really intrigued by the problem solving? Or you could say, you know what, I really hate making buttons, but I really would love to work on the algorithm. You now have a better idea of what you're doing. But almost to touch on one thing that we were just addressing before, as far as big company, small company, for me, I came from the background of frying chicken in gas stations. So for me, anything would have been awesome, but I had a very clear vision of what I wanted, and I couldn't accept Splenda when I wanted sugar, right? I had a very clear vision of what I wanted. And I always had this aspiration to go work at Google. And I started working at a company that wasn't Google, but I ended up creating enough of a brand for myself that I went to go speak at Google. And I met Google developers. And the one thing that blew my mind was Google developers quit. Microsoft developers quit. No one is going here really and retiring. There may be some people, for the most part, people get sick of these great companies. So it kind of made me realize you can make a phenomenal living at Jimmy's insurance company down the street, or you can make a great living at Fang. But what really matters is, are you content? Are you happy? And do you feel like you have purpose in doing what you're doing? So it doesn't really matter if it's big, small, medium size. Are you getting what you're worth? Because let me tell you something, you are valuable, whether you realize it or not. You have a very special set of skills that people are willing to pay for. Stop discounting yourself, because if you undervalue yourself, don't be surprised when they undervalue you as well. You are valuable. So walk into these situations with that mindset. But I will say, if you're trying to get a job in tech, I have 4 steps to get a job in tech, especially if it's your first job. Step number 1, you have to have a very strong LinkedIn profile. I highly, highly recommend that. LinkedIn is more powerful beyond belief. If you need help with that, I have a whole series on it on YouTube for free that you can go knock yourself out with. This week alone, I got 3 messages from people that watched that series a week ago that are now landing final interviews and landing jobs. It's paid for itself long ways, however you want to look at it. Second step, you have to have a portfolio site. When you're a beginner in tech, your portfolio site is like your business card in tech. You have to have it. It doesn't need to be technical savvy, but it does need to be appealing to the eye, because the average hiring manager has never coded a day in their life. They have a set of instructions that they're trying to fill. If they see a site that looks appealing, they trust that site and they pass it on to a manager. Third item that you need is portfolio items on your website. This is where you shine. This is where you show your technical prowess. This is where you show your command of the language. This is where you show your code. The last item you need is a resume. You gotta pass the ATS software, you gotta make it pass keywords, but more so than that, you need to be able to hand something over in an interview. And that's my time.
Yeah, no, that's amazing. That is so true. Marketing yourself. And now with GitHub and Twitch and all these different ways, YouTube, that you can create a brand for yourself without, waiting to get the experience at a job. You can jump in, you can start contributing to open source. You can just start doing it like right now. You don't have to wait for someone to give you like the torch and say, you can do this. So that's brings us to another good question, is about getting that experience without maybe quitting your day job, because bills are real, right? You have to learn, you have to pay your bills, but you still want to learn and get that new job. So like for me, when I first started, I worked in building things that were relevant to my current job. I started automating my current job with macros and then learning from there. So what do you all think is a good way to get that experience while, maintaining your day job?
I mean,
PJ?
I feel like I'm in that right now.
Yeah.
So when they closed everything down for the pandemic in March or so, my whole school year went virtual. So we had sort of different expectations for students. It's a big shift for the kids. And so it became sort of, I feel bad saying this, it became, my day-to-day got easier because I didn't have to be in a classroom for 8 hours. I could like set up assignments. I would make a video telling the students what to do. I had my email connected to my phone. I had my browser open, so if they emailed me, I would respond immediately. Our learning management system is something called Schoology, and they could message me on there, and I would just field messages all day. But other than that, I wasn't like actively teaching like I used to. That's when I started getting into coding, and I was coding like 3 hours a day, and it was awesome. Now that I'm back to real teaching, which real teaching is still not real teaching, we're doing this hybrid thing where I'm in the classroom, but I have some kids that are on Zoom, and it's a lot. It's very stressful, and I'm also doing an AP class this year, so my ability to code has like gone way down. What I do to try and balance what I'm doing at work, putting in, between 45 and 60 hours a week teaching, because I'm also, helping with the band and doing all these. Teachers never just teach. There's always other stuff. I set aside time. I'm not grading this time. That's time for coding. And I meet with someone and I code with them. I actually meet with Brandon Minnick, the code traveler who's been in our chat today, and I code with him. My first website that I built, the first thing Brandon asked me, he's like, well, you need to make something. What are you interested in? And I found poetry because that's what I love teaching. So my first project was like a cross between what I love about teaching, which is modern poetry, and what I am learning and taking something I'm learning and applying it to thing I love already. So that finding that thing that you can work on, that project, and I think other people have talked about this too. You have to have a project you're working on. Danny Thompson says it on Twitter all the time. He says, don't just learn the skills, do a project, figure out what you want to build and find a way to build it. And if it's in your interest, if it's in a wheelhouse that you already like, you're more likely to stick with it. So that balance, if you're working a real job and trying to code, it's hard. But setting aside time to do it and making your coding be related to a thing that you like and love already, I would say that's a great way to get started.
I love it. That's so true. Danny, you want to add something too? Yeah. Go for it.
One thing I'll say right now is that I just found out PJ follows me, so hire this guy. Like, definitely hire him. What I'll say as far as experience when it comes to code, I have 3 rules to become a developer fast, and it's ABL, ABB, CCC. ABL, ABB, CCC. Always be learning, always be building, code. Always be learning. Learn through multiple methods and mediums because no 2 teachers teach the same. You can learn 2 different perspectives and gain things on the exact same subject by using different mediums. ABB, always be building. Build. In tutorials, nothing breaks. It's a predestined road. In real life, everything breaks. Literally moving something by width and CSS will break a website. Build. Facing those errors make you a better developer. It's as simple as that. CCC, code. Let those fingers dance on the keyboard. There's no shortcut to success when it comes to development. You need to put those fingers on those keys and let them tap dance around and make something. It doesn't matter if it sucks. Make some. No one's curing cancer with a free code camp tutorial, right? We just need the practice to build up our repertoire of what we're doing. Now, when it comes to experience, when it comes to getting a job, I will tell you, I turned down 6 jobs before I accepted my first job in tech, mainly because I had a very clear vision of what I wanted, but I also am a firm believer in if I accepted something that was not what I wanted, I would have become too comfortable to go search for what I wanted. I'm not advising you to do that. I'm very stubborn in my life, and that's what I wanted. And it was tough to go back to a gas station and cook chicken when, someone just offered me a job in tech, but it wasn't what I wanted. But my advice when it comes to this is when someone has like this requirement, like we need 4 years of experience and we need a degree. Well, I had neither, and I still had them offer me positions because apply. Just apply. See what happens. Worst case scenario, they say no. Like you got the same answer you would have got whether you applied or not. Best case scenario, they say yes. Or at the very least, you have the opportunity to show them how valuable you really are. A problem that with a lot of people when they go into these interviews or have these phone conversations, they go in with this begging mindset. Please, I just need a chance. Please, I just need a chance. Just give me a break. I'll do anything for this break. Instead, go in with a value mindset. I am valuable. I will bring value to this conversation. I will bring value to this team. And if you come to me and you show me that you are serious, I will bring so much value that you can't turn me down. And I guarantee you, if you bring value, they will bring a checkbook. It's as simple as that. No company in the history of the world has turned down a surefire bet to make money. So come in with value and you'll get a paycheck for it.
That was super inspirational. Sophia, I think you had your hand up. You want to say something?
Yeah, I wanted to add on to what PJ and Danny said about getting in a lot of practice. Yeah, I really agree with that. And in addition, I think one thing that has been tremendously helpful for me learning how to code and getting better at it has been getting feedback from mentors and mentors who code, like who are software engineers and code every day. Yeah, I think one time I sent over a project to one of my mentors and I was like, hey, like, can I get your feedback on this? And he gave me a whole code review and made suggestions on how I could improve and what I was already doing well and should continue in. And so that's something that I've continued to bring to my job currently. So getting feedback from mentors is really important.
Yeah, which brings to a question that was in the chat earlier that I wanted to ask about how to find a mentor. And that's a really good question because I think that is a hard thing because asking for help, especially when you're new, it's kind of scary. So what would be your advice to somebody that's, they've came, they're excited now about this and they want to find a mentor? Aisha, is that you putting your hand up? Yes.
See, so one of 2 things, you can go on the Humans of IT, the Tribute app. I have a lot of people who reach out to me for mentorship on there. You can go on LinkedIn. start stalking people in the industry that you want to go into, and just reach out to them and ask them. If I'll put it this way, if you have a company that you want to work at, you want to know what the culture is of those people. If someone cannot or does not want to afford you the time to help you grow, then you probably don't want to work with those type of people anyway. That's
Truth.
simple.
Yeah.
But if you find me on LinkedIn, I'll respond. I promise.
Yeah. Yes, definitely reach out to us on our social. PJ.
So I stumbled into my mentor, luckily. But what I found is as I started following people on Twitter, more and more tech people started showing up. Techaria, Latina and Latino community in tech, seems to be a great community of people. Just follow like the big groups, right? Find the big groups that are talking about tech, and within that group, there's going to be people, and you just make connections. It feels hard to make connections on the internet because we're kind of used to like physical social strategies where you just kind of end up in a conversation with someone and, oh, we're at a meetup and I'm going to talk to this person. So online, if you like message someone, it kind of feels like you're busting into the room and going, hi, what's your name? What do you do? Can we talk? But there's such a welcoming community and such a diverse community of people out there who are all, I think what I've fallen in love with, and I wish I had gotten started in tech so much earlier, what I've fallen in love with is this tendency of people who have already started climbing a ladder of success in tech to turn around and offer a hand to literally everyone else that is just starting. I don't think I've met a person in tech who is like, well, I made it and that's it. Like the whole open source, like community, the idea of meetups, the idea of being like, we are better together than apart is everywhere. And if they're not like that, then they're not going to be a good mentor anyway. So getting involved in these groups and finding people to talk to in those groups that align with some of your other interests, like find them, get in there and just send someone a message. Just like Danny said, like, don't, what are they going to say? No? Sure. You're exactly where you are then. And it's wasted nothing except 140 characters in a message, you know?
Yep, exactly. The worst they say is no. That was one of the best things one of my senior developers said to me when I started out and I wanted to go to a conference. And they said, well, did you ask? And I said, well, no. And they're like, well, why don't you? The worst thing that happens is they say no. And I'm like, that's a really good point. Like, It doesn't hurt to ask. So we had a question earlier too about what a day in the life of a developer is like and a developer advocate. I think let's focus on developer. And I think, Sophia, do you want to start on that one since you're kind of in that new like first year? You know, what is maybe some things that you've found about the day? So what is it like and things that maybe surprised you?
Sure, yeah. So I'm about a month in, so I'm just about wrapping up onboarding. And I would say typically my day starts with some code reviews that my teammates have tagged me in, and I'll typically spend about 30 minutes to an hour on those. And then afterwards, there may or may not be meetings. I think some teams, depending on what organization they're at, they have a daily stand-up. Mine is all asynchronous. So over Slack, we share what we worked on yesterday, what we are doing today, and if we have any blockers. And then the rest of my day usually looks like either meetings. Typically, I don't have too many, except for maybe some check-ins with my manager. Yeah, and then the rest of my day will usually look like coding, either fixing any bugs or working on developing any new features.
And what was kind of like the surprise? Was there like a surprising thing when you got into that role as the first role, or like something that you wish you could have told like your first day self?
Yeah, I think something that has been surprising is how little meetings I have. In my previous role, I was in a more team-facing role, so I almost had maybe like 5 meetings every day. But now as a developer, I sometimes like have 0 meetings or maybe just 1, and it's just incredible. Like I have so much more heads down time to just work and code.
Cool. Anybody else have any kind of, we have about, I think 30 seconds-ish left here. So any other things that you wish you could have told your first day self, or something 100%. That you wish you knew as a beginner? Cecil, you've been quiet. I'm going to pick on you.
I'm in trouble. All right. So I mean, since we're about to end, I'll leave everyone with this. And what I always tell folks is like the reason you start is the reason why you're going to continue. And when I say that, I mean, you got to think about what's the reason that I want to learn to code for. Like, what's my passion? What's my motivation? Maybe I'm into medicine, or maybe I'm into cars, or maybe I'm into like, hardware, right? Like maybe that's the thing that got you in there. And then now you have that passion to start. And that's that same passion that's going to keep you going. I have, I teach, I talk to a lot of students. A lot of folks come in and they ask me, hey, I want to make a lot of money. I want to, buy a fancy car or whatever. And generally I tell them, I can't help you because like the motivation is not the same. You know what I'm saying? Like you gotta want to do something, because if you care about something, you got to do it. You know what I mean? If you care about something, you got to practice. I'm a big fan of sports, and so I like to use sports analogies. The best athletes in the world practice every day. Okay, they already have the job. Okay, they're already on the team, and they still practice every day because they want to be good at what they do, and they want to be good at what they do because they care about it and they have the passion for it. So if you have the passion to start, and if you have the passion to go into machine learning or security or web development or whatever the case is, always keep in the back of your head, like, what is it really that I want to do? And kind of just keep continuing to push for that and find new goals and new aspirations for you to reach for.
Love it. So there was actually a question, I think it was probably for Aisha, because it was a military question. It was asking any resources for veterans that are trying to break into tech.
Yes. So there's a couple. There's a lot actually. You can look at Microsoft has a Microsoft Software and Systems Academy, MSSA, and it's nationwide now. It's all online, but you can, Bing MSSA, Microsoft Software and Systems Academy, and those cohorts that come up, they have some specializing in CAD, cloud application development, Windows and server, cybersecurity, or you can look at Onward to Opportunity. And it's free. It's through the University of Syracuse in New York, but that's specifically for veterans and their family members. If they want to get, cloud application development, they want to get their PMP. If you want to get certified in AWS, any type of cloud certification or any type of tech certification. So those are two resources that I can think of right off the bat. If you want more, connect with me offline and I'll be happy to answer any more questions you have.
Awesome. Do I have more time? I think I have more time. So another question from Dax47 is, what do you do as a cloud engineer? Do you configure servers or code all day? Is it techno-functional role or fully technical role?
Do you want me to answer?
Yeah, absolutely. If whoever wants to answer, that wasn't directed to anyone.
I can't answer that.
So I'm a PM in the Azure space, in the cloud space, and I guess I have like a kind of like a PM/engineering role, because I can wear either hat depending on what certifications I'm using that day. But I mean, cloud engineers, we're customer facing. I guess it's a mix, and it depends, because I have cloud engineers who do not code and do not touch code. It's more of like guidance and best practices. And then we have some engineers who are absolutely hands-on coding alongside with the customers. So it really just depends on the role. I wouldn't take the description, cloud engineers, a one size fits all, because it's not. You're going to have to actually dig down and ask questions about the role specifically.
Awesome. Yeah, that's so true. And even the same role, like with the same title, can be really different company to company. And that's why when you interview and you ask those questions, those are the things you want to find out, is what are the real like responsibilities. Sometimes the job descriptions are like not reality. Sometimes they're written by HR and they're not really written by the hiring manager. And so even if you think you only have like half the qualifications, like still apply, because they're not always very realistic. So definitely good questions. Let me see, is there anything else in the chat? Well, I have another question here. What do you think makes a good developer? Who wants to answer that one?
I'll answer that. I want to answer that because I feel like it's similar to the same answer I gave a little while ago. Right, a good developer is a developer that cares. Right. I gave a talk earlier today on fundamentals of computer science, and I said, ultimately software is about people, right? I mean, that's what it's for. It's about the betterment of life of people. How can we become more efficient and work better together, and also communicate better together? And so if in the back of your head that's what you're thinking about, like how can I do the best good for society, right? Then that for me is what makes you a good technology person. Let's not even say good developer, let's say good technology person, because in this field, like there's tons of stuff that you could do that don't involve code, that you could be very successful and very productive in this field. And so, again, do I care what my customers are experiencing, right? Do I care how, I don't know, I'm going to build this app and like it kills my battery every single time. Do I care about my customer's battery? Do I care that everyone doesn't have a smartphone and doesn't have 5G? Do I care that my machine learning algorithm doesn't recognize people that of a certain shape and color, right? Like, do I care about people? So that's for me is what defines a good software or a good technology person, right? Like, can we really empathize and think about society as a whole and not just about the technology problem?
That's so true. It's like people first. And there was even some comments earlier, like about, I want to go into computers because I don't want to talk to people. And like, I thought the same thing. I have uttered those same words. Like when I first started, because I worked in a call center a really long time ago, and I was talking to people all day, helping them with their health insurance. And I was like, computers sound like a better thing right now than people. But the truth is, computer science and programming is a people thing. And computers are second. You're building solutions for people, and people part is awesome. So like, don't get too caught up on that. But anyways, we need to wrap, and I want to thank all of the panelists here. Such great advice. Thank you for sharing your stories, your knowledge, and your experience with our attendees. And I hope the attendees found this useful. So thanks.
That was so good. I love that panel. That was such a good panel. So everyone, Twitchlings, non-Twitchlings, thank you so much for sticking with us today. Like we said before, we've never done an event like Start Dev Change. Usually our learning events are for students, and this is for students from all walks of life. So it's been wonderful to hear your comments, your feedback, hear you chiming in. It almost feels like an in-person event.
Almost.
Yeah.
It was close.
Mm-hmm. Yeah.
So Cameron, is my screen working or is it still busted? Still busted?
Still busted. So we're going to interpretive dance our close.
So a couple of things. Remember, free certifications with the Cloud Skills Challenge.
Yep.
You can live stream. We're going to be live streaming on Twitch for Azure Fundamentals on October 20th at 11 a.m. Pacific time. And then we're going to live stream on Twitch for Power Platform Fundamentals on October 27th at 11 a.m. Pacific time. You can learn online, complete track progress, win certification vouchers tomorrow. Why did you tell us about tomorrow?
Tomorrow. Okay, so tomorrow is Power Platform Day here at Start Dev Change. So if you like the high code stuff, but you're curious about the low code stuff, tune in tomorrow. We start same time, same place, 8 a.m. Seth and I are back. Tomorrow we're going to have a whole new set of speakers, and they're all focused on the low code category. So you're going to learn to build your very first Android iOS app, your first chatbot, your first automation, a bunch of cool AI stuff, and you're going to do it all without writing a bunch of code. It's more Lego pieces coming together to build things rather than you going and like chopping down a tree and building it yourself. So both of them work. It just depends on what you're trying to do. So we just want to give you all the tools that we know of, so you choose which tool set you like and you want to invest in, and then go pursue the career of your dreams. Tomorrow will be very job focused. So in the interstitials, I will be actively reading you job postings that recruiters are pinging us and saying, yo, do you know anybody who wants this job? We're like, we know lots of people. I don't know. So tomorrow will be all about how to prepare you and your friends and family to get all of these 10,000 jobs in the US in the Power Platform space that are open and vacant and looking for you. So tomorrow's job.
That is correct. And incidentally, we have something called Learn TV where we stream a lot of our cool stuff throughout the rest of the year. It's a pretty amazing stuff. I'm pretty excited to be here. One of the things we'd like for you to do, if possible, is send some feedback our way. How did you like the first day? What would you change? What would you like us to do better the next time? Again, we were hoping this was going to be a friendly environment where everyone felt like they could contribute from their knowledge and learn from others. If there was any problems with you felt you weren't included or you wanted to learn more about something else, let us know. We're happy to help out in any way we can. And Donna, you'll have the last word to take us out, my friend.
I think we've all earned a well-deserved rest, especially all the Twitchlings out there whose brains are now full of code information all day. Like, you should be so proud of yourself. We started the day with inspirational stories of why this matters. Then we graduated to, here's a whole bunch of ways to learn to code, whether it's web stuff or app stuff or whatever it is. Then once we were feeling like kind of stressed out and impostery, there was a lot of like, breathe, take deep breaths, this is normal, etc. And we closed out with real people who've gotten jobs in the tech industry by career switching into them. So I hope you feel that it is possible for you. It's been really good to see many of you in the chat chiming in saying like, this conference is making me feel like maybe it's possible for me. It's not maybe possible for you, it's definitely possible for you. And if you don't feel like it's definitely possible for you, keep hanging out on the developer Twitch channel because people will talk you into it. So thank you so much for joining us today. I'm Donna Sarkar, he,
Seth Juarez, and the Mighty Pen.
And his Mighty Pen. We will both be back with you at 8 a.m. tomorrow along with the rest of our crew. See you then. Bye.
Take care.